Have you ever wondered how ChatGPT understands you and gives you the desired output every time? Or how Netflix knows exactly what you'll binge next? Or how self driving cars make split second decisions? That's artificial intelligence. And it's no longer the future, it is the present. AI is quietly powering everything around you, from the morning alarm to the ads you scroll past. And right now, the world is looking for people who can build this intelligence. The question is, will you be one of them? Welcome to Intellipaat's Artificial Intelligence Full Course, your one stop destination to understand AI from scratch and understand how the most powerful tech in the world really works. This isn't just a tutorial, it's a career launchpad. We'll walk you through the core concepts of AI, ML, and deep learning, hands on projects using Python, TensorFlow, and more, and the exact roadmap to land a job in AI, even if you're starting from zero. No fluff, no filler, just real job ready AI skills. So, if you have ever felt curious or if you ever wanted to not just use smart technology but build it, then you are on the right place. Let's begin your journey with artificial intelligence right now.
I want to bring about a concept which is going to be very critical for your understanding, and the PPT that you see in front of you were all talking about the basics. But guys, what happens is what we are going to be talking about right now is a type of algorithm that makes process even more easier, and the algorithm that we are talking about is going to be pretty much on something called neural networks. But guys, please understand one thing. Without understanding the foundational logic of what neural network is, what it does, the math behind it, and why do we need it, you cannot jump into programming a neural network, understanding the neural network, because the biggest mistake I have seen beginning data scientists make or AI engineers make is they have a terrible foundations on theory. Meaning, if your theory and your math isn't very strong, programming can be very easily done, but theory is to be understood really, really well. So I'm going to take you guys with the perspective of math and logic, but I would want you guys to pay all the attention you can in this class. Now, guys, personally, if you ask me, there are two very big frameworks, one of which is PyTorch and the other is TensorFlow. Okay. There are two frameworks that people usually use in companies, in big companies, right? Uh, we personally and I personally love PyTorch. PyTorch is something that I really, really am biased towards because PyTorch is so powerful, so incredibly fast, and so incredibly integratable with multiple different tools. I am officially certified in TensorFlow, but I don't use TensorFlow much because TensorFlow has its own issues, right? So there are two amazing frameworks that you're going to see people use in production, PyTorch and TensorFlow. I will give you an idea about both. Whichever you feel using, you can use. Personally speaking and also professionally speaking, PyTorch is something that majority of the companies use in production. So if you see, a lot of the organization nowadays have started migrating the TensorFlow code to PyTorch code also, because PyTorch supports something that TensorFlow does not support, and the name of that thing is called DDP, distributed data parallel. I'm not sure if you guys know about it or not, but DDP is going to make your distributed machine learning or distributed AI architecture very, very easily. So highly scalable, making your machine learning operations easy. Okay, if you don't know what I'm talking about, ignore. I'm going to give you the idea later. Now, let's get started with understanding the topology of a neural network. A neural network is nothing but a mathematical model of a human neuron or a neuron which is converted into a very simple mathematical sort of a model. Okay, so human brain inspired mathematical model is called as a neural network. Typically, an artificial neural network has a layered structure. Do you see three layers? The blue layer is called input layer. The middle layer is called hidden layer. and the outside layer or the green layer is called output layer. So first of all, whenever you design any neural network in the future, let's say you come up with your own neural network architecture, it will have three layers: input layer, hidden layer, and output layer. Input layer is where the data is going to be input into the model. It will pass through the hidden layer, and the output layer is the one that will give you the output to the model. Are we clear? It's a simple understanding. I'm not asking you to go deep. Now see guys, everyone has heard about AI, but many of us, right, don't really know the inspiration behind the artificial neural networks, right? And where do they actually come from? So you guys need to know that in humans, right, we have the concept or a neuron, a literal neuron that is used or that is available in our brain. We are inspired from that and we've created a model of our own. Now, I am not interested more in the biology of it. What I'm interested in is what information it carries. So guys, this particular graph that you see in front of you is taking the input x1, x2, x3, x4 all the way till x of n, passes through some weight value. We do something called addition of bias and we sum it, pass it through activation function, and we get the output. Now you must be like, okay, but I don't understand what the logic is. Like, okay, what is weight? What is bias? What is this x1, x2, x3? What is this w1, w2, w3? I don't understand. Okay, so let's first of all understand it a little bit clearly. A neural network that you defined or a simple perceptron that I defined will have a three input node. Input node 1, give me 1 second. Let me change the color. Let me make it black. Input node 1, input node 2, and input node 3. Guys, this is what I like to call as my input layer, IP layer. This is my first input layer. Then this becomes my hidden layer. Okay, the layer that is sandwiched between input layer and output layer. Okay, so this is my input layer, this is my output layer, and this is my hidden layer, and this is what I'd like to call as my output layer. Every single circle that you see, we call that particular circle as a node. Every single circle that you see here, we call that particular thing as node. Guys, every node from input layer 1 needs to be connected with every node in the hidden layer. Meaning node 1 will be in touch with this also, node 1 will be in touch with this also. Node 2 will be in touch with this as well, and node 2 will be in touch with this as well. And node 3 will be in touch with the hidden layer node 1, and it will be in touch with hidden layer node 2. Are we clear? This connection is mandatory. Can I do it, not do it? No, it's a mandatory connection. Then whatever your input layer connections are, your hidden layer connection will be connected to the output layer node 1 and your output layer node 2, and then you're going to get an output called output. Okay, this particular value will give you something called Y predicted results or your output. Now guys, if I name everything together, node 1, node 2, node 3, model 1, model 2, and say C1, example. See guys, from your input node 1 to your model 1, the connection is actually called as a weight. We call this particular thing as a weight, W-E-I-G-H-T, weight. So between node 1 and M1, can I say W1, W2, W3, W4, W5, and W6? There are 6 weight values that are connecting from node 1 to M1. There are 6 lines that are connecting. If you don't know what weights are, let me tell you something. You should look at a neural network like an information flow pipeline. So let me ask you guys something. Listen to me. If I have a place, a water tank, can the water tank have a pipeline which is a big pipeline, which is a big diameter pipeline? And the same water tank can have a pipeline which is a small water pipeline, correct? If my weight value is 9 and my weight value is 2, which pipeline carries more water? 9 will carry more water or 2 will carry more water? Will it be 9? Okay, listen to me guys. Can I say that from node 1 to multiple different connections that we are doing, the weight value W1, W2, W3, W4 are simply how much information I am passing? Yes or no? Will you think of it like this? How much information is being transferred from my input layer to my hidden layer? Understood? How much of that information is being passed? Remember, weight values can be positive also, negative also. Are we clear? They can be 0 also, positive also, negative also. Very good. Now tell me, sir, how can I know how many connections I need to do? Very simply, how many nodes do you have here? How many nodes do you have at the input? 3. And how many do you have at the hidden? 2. What is 3 multiplied by 2? 6. That will be the number of weights value you need to connect your input to the hidden. Are we clear? Multiply the nodes in the input, multiply the nodes on the output. That is the exact amount of weight value you need to connect. But have we connected all the weight value? No, because after weight 6, you have weight 7 and weight 8 also. Agree? So totally, to build a simple neural network connections together, how many nodes did I need? 3, 4, 5, 6. How many nodes? 6 nodes in total. Agree? 6 nodes, 8 weight values, correct? 6 nodes, 8 weight values. But guys, your job is not done, because in hidden layer and the output layer, you add also one more thing called bias. So this is bias number 1, this is bias number 2, and this is bias number 3. So please tell me together how many biases did I add? 8 weight values and 3 bias value. So total, how many parameters do you get? What is 8 plus 3, everybody? 11. So you built a neural network model with how many parameters? 11 parameters. And guys, the mathematics of this is so important. Have you ever seen a large language model, guys? Like, let me very quickly show you why the math is important. So let me show you something, right? Let's say Hugging Face. And let me take you guys through. Oh, by the way, I just want to let you know. See, this is our model that my team built. This is for AI for Bharat. So this is, oh yeah, look at this. This is 4,64,952 downloads. That's nice. That feels good. Wait, so yeah, let me just open up DeepSeek. So if you see, open up DeepSeek R1, right? Can you see the model has how many parameters? Let me open that up, or maybe let me show you one of the models that I like, Microsoft 5. So 5 3.5. Let me come over here. Let me say 5. Oh, there's also, okay, let's say 5 3.5 mini instruct. Here, my see, guys, if you see this particular model, right? This model I'm assuming is a, what, how much is the size of this particular model? I'm assuming what, this must be a 3 billion parameter model, I'm assuming. The large language model, which is Microsoft 3.5, I can literally chat with it. How are you? Right? If I send a message, it will be able to respond back to me. I am fine, Microsoft language model. I don't have a feelings, but I'm here to do whatever XYZ, XYZ, XYZ. If you observe this particular value here, can you see here? The model size is a 3.82 billion parameters. So the logic that I'm teaching you right now, the way to calculate the model parameters will come handy later on. Are you understanding? When you go into generative AI, the logic that we are learning right now will slightly help you there. I just want to see, I want you to understand the connections I'm taking you through. Okay. So guys, we built a neural network. The total neural network connections are 8 by 8 weights and 3 biases, total 11 parameter model. Understood? Your model size is an 11 parameter model. Now listen to me carefully. Rather than teaching you the theory and unnecessary stuff, let's understand what the logic behind it is. Sir, what is bias? Sir, why do we need a bias? What is the reason of bias? Okay. See, guys, in a neural network, okay, in a neural network, to make the model learn the pattern within the data, okay, to make the model learn patterns within the data, we add a little bit of error, a small uncertainty we add in the neural network. I'll give an example, right? Imagine you want a child to learn how to play cricket, learn how to play badminton, learn how to play. Okay, let's say you want a child to learn how to play badminton, okay, or tennis. So tell me one thing, your child is going to face lot of challenges while learning tennis. Agree? How to hold the racket, pain in the hand, tennis elbow, high competition, heat, and all of that stuff. But apart from all of this, okay, apart from all the technical understanding of tennis, will the child also learn other things like discipline, getting late to the, going late to the session, falling down on the road, other problems which you cannot ever think of, but it builds his character as a tennis player. It is raining that day. The city is closed for some, I don't know, for some Bharat Bandh or India Bandh for XYZ nonsense. So can I say there are some issues that you can never predict, but they can actually exist, that can stop you from becoming a tennis player? Can I say that? Some things that you can never judge, never understand, it might come up, but they will come up. I'll give you an example, right? I'll give you an example. Let's say, let's say you wanted to study for your exams. Everyone listen to me. You wanted to study for your exams. You have exactly 50 days to revise all the concepts. You've properly created all the plan that I will be able to complete all the revision in 30 days. But suddenly your relatives get sick and you need 15 days to go help them. Are you understanding? There are always going to be chances where your plans may not work out, where there will be some kind of uncertainty introduced in the model or uncertainty introduced in your life. What a bias does is we introduce that slight uncertainty in the model because we want our model to understand the pattern within the data, but with slight uncertainty, we make the model more robust. Are you understanding what I'm trying to say? That's the logic of a bias. Bias meaning we give it some kind of an unnecessary information that makes my model more consistent, meaning consistent variance within the model. Are we clear? Are you getting the logic? Preparing the model for every small little thing so that it understands the relationship actually, even if the small error exists. That thing is called as a bias. What is the English word of the meaning bias? A certain favorable position in a person's brain, right? A certain partiality of sorts, a certain favor or a behavior, agree? So bias must not be a very good thing, right? In English language, when you say I am a biased person, am I saying I am highlighting my positive character? No. So tell me, if I'm introducing the concept called bias 1, bias 2, and bias 3, I am actually introducing a small miscalculations in my data to make sure overall my neural network can be handled and managed by myself. Meaning, I can slightly tune my biases and I can change the way the behavior of the model works. Agree? Right? I can change the behavior of my model with the tune of the bias. Keep this in your mind. I'm going to teach you how you can do that later. Okay. Now, guys, I'm going to give you guys a small idea. Okay. Sir, we connected the input layer. Okay. We connected the input layer with the hidden layer and the hidden layer with the output layer, and we might get the answer. Okay. But before we even continue forward with this, I want you guys to understand one very important factor. Okay. Sir, how many input layers can I take? How many hidden layers I can take? And how many output layers can I take? First of all, you can only have one input layer in a neural network. Your input layer can only be one. Your output layer can only be one. But your hidden layer can be many. Meaning, I can take a hidden layer of node 3, I can take a hidden layer of node 2, and I can even take a hidden layer that looks like this. Everyone, listen to me. Suppose my input layer is 3 input nodes. I can take my hidden layer as the initial 3 input, then one more input layer with 2 nodes and one output layer. Can you see my input layer is of 2, hidden layer 1, hidden layer 2. First layer has 3 nodes, second layer has 2 nodes. Understood? Sir, why do we do this? How do we do this? We'll come to that later. But for now, understand that this is allowed in a neural network. Understood? You are allowed to take this particular infra. Okay. Let me repeat myself once again. My input layer is a specifically well-defined structure where the input of the model is taken. Agree, disagree? Only when the initial layer where the input is passed is going to be called as input layer. Am I making myself absolutely clear? Your hidden layer is not your input layer. Let me repeat myself once again. Your input layer is your input layer. Your hidden layer is not your input layer. So I don't know where you are getting the idea from. First of all, only your input layer accepts the input within the model. So only that has the capability of being called the input layer. Don't go into the direction where saying that hidden layer is also an input layer. Guys, no, I never said it. So let's not overthink. Okay. Point number 2. Listen to me very carefully. I can take a hidden layer where the number of nodes could be anything 1, 2, 3, 4, and 5. My hidden layer 1, HL1, has how many nodes? 5. I can take second more layer called hidden layer 2. How many nodes can I take? 1, 2, 3. Hidden layer 1 and hidden layer 2. I have taken how many layers? Hidden layer specifically 2. Hidden layer 1 is nodes 5 and hidden layer 2 is 3 nodes. This time, rather than having one node in the output layer, how many nodes do I have in the output layer now? 2. First of all, is this allowed? The answer is yes. Anything is allowed because it is dependent on the goal of your project. Are we clear now? Please first understand the logical differentiation and connect the dots first. Sir, how to decide how many hidden layer? I am not teaching that yet. I haven't taught you that yet. So let's just relax for a while. But the point is, sir, can you take 6 node in HL2? Sir, take 100 if you want. Take 500 if you want, sir. Sir, take 1297. Okay, good. Now, listen to me carefully. Will every single node be connected to every other node like this? Yes or no? Then the second node will connect to every other node 1, 2, 3, 4, and 5. Okay. 1, 2, 3, and 4, and 5. Okay. Okay. How many nodes did I have? Is this 3 node? Is this 3 node? Okay. How many node is this? 1, 2, 3, 4, 5. 5. What is 5 threes are? First of all, 15. So how many weights value do I need here? 15 weight values. Is everyone understanding? I am not even gone to the hidden layer yet. Input layer 1 to hidden layer 1 connection. Did you understand that you can take as many input nodes as you want, as many hidden layer nodes as you want? In the input node, any number of nodes are possible, and in the hidden layer 1, any number of nodes are possible, and the connection should be done like this. Acha, by the way, listen to me carefully. Sir, connecting the node of every single node to every other single node, the name of this connection is called dense connection. What do we call this? Dense connection. Remember, this is going to be your lifesaver in the future. We call this FCN or dense connection. What is the full form of FCN? Fully, FULLY, fully connected layer or network. Did you get it? FCN or dense connection. You can call it both. Either call it fully connected network or call it dense connection. Now tell me guys, I understood that between my input node 1 and my hidden layer 1, I can connect 15 different weight values will help me connect my input layer node 1 to the hidden layer node 1. Until here everyone is clear. Now guys, tell me one thing. Is my network complete? No. My network is not complete. So now tell me, do I need to connect my hidden layer node 1 to hidden layer node 2, which is layer 1 to layer 2 connection? So this is 1, this is 2, this is 3, right? And then this is going to be, let's say 4. I know the diagram is a little tricky, but get the idea, right? And then we have something called 5. Now, did I connect every single node to every other single node? Now, guys, tell me this, okay? This is how much? 5, right? Multiplied by 3. What is 5 threes are? So, how many weight values do you need here? 15. You need 15 different connections. Only hidden layer number 1 and hidden layer number 2. Only between hidden layer number 1 and hidden layer 2, how many connections do you need? 15. And between input layer 1 and hidden layer 1, how many connections do you need? 15. Are we clear? You are allowed, ALLOWED, you are allowed to do what? Take as many hidden layers you want. Hidden layer 1, hidden layer 2, hidden layer 3. You can take it to hidden layer 1000 also. No problem. Take it. You are allowed to take as many hidden layers as you want. First of all, are you clear? Hidden layer 1, hidden layer 2, hidden layer 3, hidden layer 4, hidden layer 5. You are allowed to take as many as you want. And in each hidden layer, you can take as many nodes that you want. Are we clear with this also? But tell me one thing, guys. When I say you are allowed to do whatever you want, shouldn't there be some kind of a rule you should follow? Shouldn't there be some kind of a universal rule that a student in United States of America or India or New Zealand, they all should follow the same rule? That if you want to take hidden layer, how many hidden layers should I take? For hidden layer number 1, how many nodes should I take? And for hidden layer 2, how many nodes should I take? Should there be a rule? Yes, there is a rule. Sir, what is that rule? I will teach it to you once we program the entire neural network. Are we clear? So yes, I will teach you how to decide that, but not right now because that topic is slightly complicated. Are we clear? So sir, why did you take 5 here? Why did you take 3 here? This is just to show you as an example. But remember, there is a reason behind why you should take 5 in the hidden layer 1 and 3 in the hidden layer 2. Are we clear? Got the logic? That doesn't mean that if I'm allowed to take 1000 hidden layers, suppose the hidden layer can be gone all the way to 10,000. But should you take all the 10,000 or 1000? You went to a mall and you saw this beautiful jacket that you want to buy. If the jacket is 30 or 3000 rupees, will you pay the cashier 6000 rupees for the jacket? When 3000 is enough for you to buy the jacket, will 6000 be an overkill? The guy will take 6000 happily. Why pay extra? Understanding? That logic applies in the taking of the nodes in the hidden layer also. Got it? When input layer or when the hidden layer can work with 5 nodes, why do you want to take 8 nodes? Number of hidden layer and bias will not decide the objective of the model. Okay? So tell me, why every single node should be connected to each? What if one of those are not connected? If they are not connected to each other, are they sharing information with each other? And if they are not sharing information with each other, are they truly connected or learning? The answer is no. So that is why every single node needs to be connected with every other node. Are we clear? So they can share information with each other. Let me give you guys an answer. I'm sure you guys don't know this, but if you do a crime in a state like Karnataka and run to Mumbai, do you think you can escape for long? Isn't Indian police connected every single place that you go in India? They share information with each other. One police station can share information with other like in a second. Are you understanding? Just like that, you have a neural network that can share information from one place to other place. Got it? To share the information and to learn better, they are all connected. Are we clear? So let's complete this. My hidden node 2 or hidden layer 2, will it be connected to my output layer this and then this will be connected to this and then this will be connected to this and this. Are we clear? And these are my output. Please tell me how many weights will I need here? 3 multiplied by 2. What is 3 twos are? 6. So 15 plus 16, 15 plus 15 plus 6. Can I say totally 36 weight values are required to build a neural network like this? Apart from 36, bias 1, bias 2, bias 3, bias 4, bias 5, bias 6, bias 7, bias 8, bias 9, bias 10. How many biases? 10 biases. So did you guys learn how to create a neural network first? 100%. So tell me this, guys. If you look at this PPT in front of you, what do you see? Do you see this big summation value? Biases are all on the other nodes except input nodes. How you decided 36? Okay. So now let's address some important and deep diving connection. First question. Is dense connection known only from input to hidden layer 1 or some terminology is used for hidden layer 1 to hidden layer 2 connection as well? Every single node connected with every other single node, connected with every other single node, connected with every other single node, no matter what the layer, everything is known as a dense connection. Meaning, when you build a neural network, can you only build a dense connection to input layer and hidden layer 1 but ignore all other? No. Dense connection means every node of every layer should be connected with each other via a connector. Cool? Good. Okay, next question. How we know how many biases we have to take? Starting from your hidden layer, which is this value. Let me remove this. Let me erase this. Starting from your hidden layer, you should start connecting every other node of the hidden layer, which is 1, 2, 3, 4, 5, and 6. Every other node until you reach to the output layer should have a bias of its own apart from the input layer. Clear? Every other hidden layer 1 node, hidden layer 2 node, and the output layer node should have their own bias values. Sir, is hidden layer 1 connected or dependent on hidden layer 2? Of course it is, right? Because it's the hidden layer 1 that's passing the information to hidden layer 2. So they have a connection with each other. They are related to each other. So bias is, in other word, means they are anomaly introduced. Not anomaly, slight irregularity added. Let's actually go one step deeper. See, I taught you one step in depth about how a neural network is built. Now let's go one step deeper. Okay. See guys, neural networks are also called universal function approximators. Now you will be like, what? What is this new terminology you keep introducing every single time here and there? Well, guys, the technical terms are important. Do you guys agree with me? Understanding the technical terms becomes very, very important. Otherwise, you will sit in a group of people and you will not know what to say. So first of all, sir, what do you mean by universal function approximators? Okay, so let me explain. Imagine I have a jug. Let's take a better one. Let's say I have a jug which looks like this. Okay, listen to me. Let's understand what neural network does so brilliant that my machine learning is incapable of that. Let's understand this. Okay. Okay, listen to me. This is a simple picture of a jug. Everybody agrees? Not a very complicated thing I'm drawing. A very simple photo of jug. Guys, if I want to build a mathematical formula to plot this jug on an x-axis versus y-axis data, for example, x-axis and this is y-axis. Writing down the formula to print this jug, a line, a curve that looks like this, a curve that looks like this, a curve that looks like this, and then again a curve, again one more curve, and a curve like this. Do you think it will require a lot of time, energy, effort, and computation to come up with the formula to print this jug? Mathematically speaking, agree? Like if I want to make this jug mathematically plottable, meaning this equation could be x to the power of 4 minus 3x to the power of 3 minus 0x cube minus this, and then this curve would be some formula. Then I need to combine all the equations together. I don't want to do that. Okay, I am not interested in doing that. So rather than dealing with a problem like that, can I do this? Can I take multiple different data points on that jug randomly? One here, one here, one here, one here, one here, like multiple different data points. Okay, like I'm going to show you an example. Look at this, everyone. I'm taking multiple different points. Okay, on this particular jug, random points, guys, random points, completely random points on that jug. Okay, now tell me, did I take all the data from the jug? Or am I taking the complete jug as the information? Am I taking the complete jug as the information? Absolutely not. Am I not taking some random data points on the jug? Yes or no? Now tell me, if I remove this jug, okay, just specifically the jug part, okay, or if I, how do I remove this? If I were to remove the jug from the background, okay, if I were to remove the jug from the background and just have the dots with me, are you seeing that the red dots are kind of taking the jug shape? I removed the photo of the jug completely, but the red dots are kind of giving me almost a very closer shape to the jug. Agree? So tell me, rather than taking the entire jug, calculating the mathematics behind it, can I use a neural network to take this data of the jug, give it the original picture of the jug, and it can approximate how the jug would look? So rather than exactly calculating the formula or the way a jug looks like, did it approximate what a jug would look like? So what should you learn from this topic? No matter how complex my data is, will my neural network fit that data, understand that data? It will approximate that data. Let me ask you this question, okay? Imagine my data looks like this, okay? My data of the customers look like this. My neural network, rather than coming up with the exact answer, will it fit the data like this? It will say that, yeah, depending on the data, my neural network's learning is, I have learned that the model follows this behavior, the green color part. Isn't my neural network's output approximating the actual data's behavior? Now, if I wanted to do this in machine learning, is it that easy? You know why this is not easy? Because every machine learning algorithm, does it not have its own bias, its own variance problem? So approximating the relationship if in a data which is very, very complicated, won't I have to choose multiple different algorithms? And even that algorithm is not guaranteed if that complex data exists, it will approximate the data well. Agree, disagree? This is one of the reasons, my people, neural networks are the best universal function approximators. Meaning, no matter how complicated your data looks like, my neural network can always learn how to fit it. Am I making sense? My people, isn't it the best way of learning something with a little practical example? Whatever I taught you was a theory. When we take an actual practical example, the one that is used in the industry, won't we learn better? That yes, sir, I think taking one example will give everyone a clarity about the theory that you had taken. Now is the time to learn the practical part of it. Are we clear? Because theory was important for you guys to first understand how to handle things. Okay, guys, I have a data set that looks like this. Okay, let's take this example. HOURS, hours of sleep. Cups of coffee, travel time, and productivity score. Guys, I only had 7 hours of sleep in the last night. And in the morning, I had 2 cups of coffee. The distance between my office and my home is 25 minutes. What will be my productivity score for that day in the office? Can I say 85? Productivity is a score between 0 to 100. How much productive will you be that day? I'm saying 85% productive I'll be. I had 6 hours of sleep last night, only 1 cup of coffee in the morning, and my travel time is 32 minutes from my office to my house. Will my productivity be 65%? I had 8 hours of sleep, 2 cups of coffee, and my travel time is only 17 minutes. Will my productivity score be 92? I had 8 hours of sleep, 3 cups of coffee, 19 minutes of travel time, and my productivity score is 95. Are you understanding this data? I have taken the data of how many hours of sleep did I get in the last night, how many cups of coffee I'm drinking, what is the travel time from my office to the home, and what is the productivity. Is this data set making sense to everyone? So tell me the relationship that my independent variable has with my dependent variable, the relationship can be understood by neural network really, really well, right? Under what hours of sleep, what cup of coffee, what travel time, what should be my productivity score. So if I want to calculate, I slept for 7 hours in the last night, had 4 cups of coffee, and my distance is 20 minutes. Can my neural network help me predict what will be the productivity score next? Yes or no? Agree, disagree? If I give it enough data, this is what my neural network will help me predict, no? Yes or no? Can we do that? Machine learning also will do, right? Of course it will do. Who says machine learning cannot do this? Machine learning can do this. But my question is, machine learning is also capable of doing this. Deep learning is also capable of doing it. Which one is better? Take that one. Let me tell you something very, very industry specific. Whenever in your company, they will give you data to apply machine learning on the same data, you can apply logistic regression, you can apply naive Bayes classifier, you can apply decision tree also, you can apply random forest also, and you can apply neural network also. Whichever algorithm is giving the best accuracy, take that. Agree, disagree? I am not saying neural network is the Shah Rukh Khan of deep learning. Am I saying it? No. Am I saying neural network is the Brad Pitt of machine learning? No. Anyone which is working the best, you can take that. Okay. So now tell me, will my model help me predict this data? So can we say neural network is not a machine learning model? No, 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 no. Don't make that mistake. So first of all, deep learning is a part of machine learning. Yes or no? Deep learning is a part of machine learning. So neural networks are also machine learning if you think about it. From the definition standpoint, neural networks are also machine learning. Okay. So don't say that machine learning is different and deep learning is different. Deep learning is a subset of machine learning. Okay. So they are both the same only. One is the father, the other is the child. Okay. Yeah. Okay. So guys, if I want to make my neural network built for this, how many input features do I have? How many features do I have? Hours of sleep is feature number 1. Cups of coffee is feature number 2. And travel time is feature number 3. Because productivity score is my target. Agree, disagree? How many features do I have? 3. So my neural network will also have only and only 3 input nodes, right? Can I take 4 nodes in the input? Sir, you cannot. Because in the first node, what will you pass? Hours of sleep. Agree? In the second node, you will add how much coffee did you take. And in the third layer, you will add the travel time node. So tell me, based on the goal of my project, how many input layers am I supposed to take? So did you guys understand why did I take 3 as my input node? Why does my input node layer or my input layer has only 3 node? Whatever is your feature, that is exactly the number of nodes you should take in the input. This is the rule. If you have number of features which is 5, how many nodes will you take? 5. Simple. Are we clear? Okay. Sir, how many hidden layer can I take? For simplicity reasons, can I just take a simple one hidden layer of two nodes? Can I please do this for simplicity? Sir, for 100 features, should the nodes be 100? Yes, it is. If your input feature is 20,000, then how many nodes will you add in the input layer? 20,000. Simple, plain mathematics. Okay. Now, can I say for simplicity reason, my input layer is 3 node. I am only taking one hidden layer with 2 nodes so that the logic will become simple. My people, my output layer node is also 1. You know why 1? Because my target variable is a number between 0 to 100. No, I want my output to be any number between 0 to 100. Won't one output layer give me that answer? One output node will give me an answer between 0 to 100. Now guys, listen to me. If my target variable had data like this, positive, negative, neutral. Example, I had 3 label. My label was positive, negative and neutral. Then how many nodes would have been my output? Positive, negative or neutral. Are we clear? If your output is a regression based output, which is continuous variable data, only one node is enough. But if your target variable was multiple different classes, equal to the classes will be your equal output nodes. Is the output clear? So depending on the goal of my data or the project, is this the neural network I have decided to make? This is how my neural network will look like. Node number 1 connection to node number 2, node number 2 connection to hidden layer node 2, then this with this with this, then this with this, and this with this. If the output variable is numerical, we should take only one node. 100% yes. Now, I will connect the node from here to here and a node from here to here, and then I will have an output here. Is this the neural network design that we have done? Guys, feel a little good about yourself because you have just designed your own neural network. We've just successfully just designed our neural network. This is the first step as a data scientist. Clear? Okay. So guys, imagine you and your friend are doing boating. You understand boating, kayaking, boating, whatever you want to call it. There is this beautiful lake and your friend is here. You are sitting on the shore, on the edge of the lake. Shiv is on the boat. Okay. And he is boating in the middle of the lake. And let's say Vani is sitting in the edge of the river or the lake. Now Vani has a very weird thought in her head. Vani wants to throw some rocks at Shiv. Okay. Now because Vani is sitting at the end of the lake, at the edge of the lake, what will Vani have to do? So what will Vani do? If you think about it, what will Vani do? Vani will pick up a rock and she will throw the rock at Shiv. Now what will happen is, unfortunately, the rock that Vani threw, sort of went here. It went to this piece of the lake. But based on the calculation, will Vani get some feedback? I think I need to throw the rock a little forward and a little to the bottom. Agree? Vani will get the feedback from the first mistake she made, the error she made. Oh, I think I'm way too far. I need to throw a little bit more and a little to the left. Now Vani throws one more rock, but she throws way too far. Will this error also give Vani the feedback? The third rock Vani throws hits Shivam on the head. So can I say that even us human beings, we learn from our mistakes? From the mistakes that we learn, do we become better? Do we become better from the mistakes that we learn? So listen to me. Can I say that mathematically speaking, the error is nothing but actual value minus predicted value? This is going to tell me how much mistake or error I have made. My actual value minus my predicted value will tell me the mistakes I have done in my predictions or my model, how good my model is. Don't you want your actual value and the predicted value data or the difference as less as possible? Agree? So tell me one thing, for the neural network to learn, to become better, don't I want the information flow to go like this? In this direction? Pass the data, like how many hours of cups of coffee did I have, my people? 7. How many cups of coffee? 2. And how many is my travel time? 32 minutes. Suppose I do something called as the forward flow of the information and the output my neural network will generate is 60. My people, the predicted value by the neural network is how much? 60. But what is the actual value? 85. So tell me, what is 60 minus 85, everybody? Is the difference 25? So tell me, is my model learning the best? Did it understand best? No. So once you go forward, don't you want to go backward and teach the model what you did wrong? In the forward flow of the information, in the forward flow of the information, I am encouraging my model to make some prediction. Agree? Once you make the prediction and based on the mistakes I need to know, don't I need to go back and fix my mistake? So going back, fix, again predict, fix, predict, fix, predict, fix, predict, fix, predict. Do I keep looping fix, predict, fix, predict? This loop goes on and on and on and on and on. Make a prediction. I'm far. Stop. Fix yourself. So tell me one thing. When I say fix, when I'm saying fix something, what am I fixing? First of all, guys, the neural network is able to make the prediction because there are some values called weight 1, weight 2, weight 3, weight 4. Some numbers are given to weight 1, weight 2, weight 3. When I say fix, am I saying I am changing the values? When I go back, I am changing the weight 1 value, weight 2 value, weight 3 value, weight 4 value, weight 5 value, weight 6 value, weight 7 value, so that my prediction is the best. Okay. So whenever you see this diagram in front of you, does this remind you of a neural network? Yes or no? Whenever you see this graph or this diagram in front of you, please remember, people either call this as a feed forward network, densely connected network, or very simple, it's also called as a multi-layered perceptron. Okay? Multiple different name, don't worry, it means the same thing. It is exactly the same thing. Now, I am going to copy the data set that we have here and I am going to paste it. Okay, I'm going to take this, or you know what, rather, let me start like this. Let me explain certain things to you, right? Let me copy this diagram that we have and I am going to copy this and I am going to paste this. Now, guys, remember one thing. No matter what neural networks you take in this planet, okay? No matter what kind of neural network you take, you have multi-layer perceptron, convolutional neural networks, UNet, masked RCNN, faster RCNN, RCNN shiny, multiple different kind of neural networks if you take, they will have one thing in common. And that common thing is called as forward propagation and backward propagation. Okay? Forward propagation and backward propagation. Rather than explaining you the concept of what a forward propagation is and a backward propagation in math in detail, I'm going to come to that in a second. But I want you guys to understand one thing. And that one thing is, remember guys, whenever you write a neural network, okay? A neural network will have something called as nodes. So first of all, the circles that you see in front of you, all the circles are called nodes. Everybody agrees that the circular thing that you see in my network are called nodes. Every single connection that you see in this particular network is something called as weight value, right? So can I say weight 1, weight 2, weight 3, weight 4 and weight 5. Then there is weight 6 and weight 7. So totally there are 7 weights and 3 biases. Bias number 1, then bias number 2. and one would be applied to the output as well. So bias number 3. So how many biases? 3 biases. Totally 7 weights and 3 biases are called 11 parameters of the model. Okay, 11 parameter model. Wait, 1, 2, 3, 4, 5, and so sorry, 5 and 6. So 6, 7, 8. So there will be 8 weights and 3 biases. I apologize. Yeah, there are 6 weights and 3 biases. That's correct. Okay. Biases add a certain irregularity, certain noise, certain error in the neural network. Okay. A bias adds a certain irregularity in the model. What it does, this error, this irregularity in the model, it helps my model perform a certain way. Now you can ask me a question, why and how come error is causing my model to perform well? See, what biases do is, weights alone cannot make my model tuned. When you say tuned, when you want to tune something, right? When you want to tweak your model into working the way you want the model to work, right? Weights alone cannot be tweaked to make the model representation better. Sometimes you have certain irregularity, certain noise that you can add to the neural network that can make your model tune a little bit better, can perform a little better to it. So that is exactly what biases do. Biases, as the English word represents, you are adding something which is not a very positive thing, but it ends up being a positive thing for the model, for the performance of the model. So any irregularity, any kind of a small noise introduced in the data is what you call as bias. Once you implement the math behind it, you will get an even better representation of what a bias is. Simply speaking, bias is just a number. Okay, this number has some importance. We'll talk about what the importance is. Okay, now a neural network's life, a neural network's soul is something called as a technique which is called forward propagation and backward propagation. Now you can ask me one thing. Hey Rudra, what do you mean by forward propagation? What do you mean by backward propagation? Guys, I don't want you to look at this neural network as a neural network. I want you to understand this as a way of flowing the information, or a way where my information passes from point A to point B. Now guys, if I ask you a simple question, the intention of the neural network is to take some feature values and make a prediction on the output. Whenever you want to make a prediction, whenever you want to make some prediction, you have to let the flow of the information pass in this direction, okay? From the input layer to the output layer. So whenever the flow of information travels from input layer to the output layer, very simply call that as forward propagation. Propagation means movement, movement of data, movement of something. Now, guys, when you make some prediction, you know for a fact that I also have a actual data and I have some predicted data. If I subtract actual data minus the predicted data, I will get the error my model has made, correct? Can I simply call this the error, the mistake my model has done? Now, based on the mistakes my model have done, can I go back and correct my model's mistakes? Why my model is making a mistake, where it is making the mistakes? I can go back and change something in my model, change how the information flows, right? This step in a neural network is called forward propagation and backward propagation. Let's actually write down the program, or sorry, not the program, but let's write down a neural network and let's understand the math behind it. Okay. Now, let's write this neural network down in a very different way. Okay. So first of all, let me write down a circle of sorts, and let's make the circle a little bit smaller. Okay. Let me copy this and paste it. I have one more circle, and let's paste it. Let me copy this and let me paste this as well. Right. Okay. Now let me also take a little larger circle. So let's take like an extensive circle here. Give me 1 second. Control Z. And let's make this circle a little bit larger. Okay, that's fine. Control C, Control V. I have two circles now. And let's take a smaller circle. So let me go ahead and copy this and paste it here. Okay. So First of all, a neural network's hidden layer, okay? A neural network's hidden layer, I am going to split the hidden layer into two different parts. The first part will be called summation and the other part will be called activation. The first part will be called summation and the other will be called activation. Just like how you have written your neural network normally, you will have multiple different features. Let's call this feature number 1, feature number 2, and feature number 3. This is my input layer. So let me write down I/P. This is my input layer. This is my hidden layer and this is my output layer. Now, what I'm going to do is I'm going to connect my node or my network with every other node. So this connection is going to be with this connection and this connection will be with this connection. Now the second connection will be on this node to this particular value and then this node to this particular value. Then again, the blue one is going to be connected from here to here and this one will be connected from here to here. So this is a dense connection or a fully connected layer. And then we have from this hidden layer to my output node and then from hidden layer to my output node. And finally, I will have something called as a ypred value, which will be predicted here. Okay. Now, two questions let me answer for every single person in this class so you don't end up being confused at all. First of all, guys, remember one thing. Okay. And I want you to be very clear about this. In neural networks, the math behind neural network looks something like this. Y is equal to mx plus c. Now you will be like, what? This is a line equation that we use in linear regression, isn't it? Agree, disagree? Doesn't this look like a simple line equation? Y is equal to mx plus c and like it looks very, very linear, right? This equation is also linear in nature, right? It will create a line that will be like this or like this or like this or like this, but it will end up creating line every single time, right? So in order for you guys to understand something even better, what I'm going to do is I'm going to first explain you the concept of something called activation functions. Okay. Activation functions. Guys, activation functions. Okay. What activation functions do, they add something called non-linearity in the model, in your model or your neural network. I'm just going to call it simply model because that covers everything, but you can assume it to be neural network. Sir, what do you mean by non-linearity? Let me explain very, very clearly. Guys, imagine if I have taken a data set like this. I have a x-axis data and I have a y-axis data. Okay. On x-axis, let me say the speed of the F1 car and the number of turns or the number of or I can say that the temperature changes every time you accelerate your car. So your data might look something like this, right? Okay. So your scatter plot looks something like this, right? Suppose you have a x variable and a y variable and your scatter plot looks a little like this. Okay. Now let me ask you a question. When you plot a x versus y graph, does this data look linear to you in any shape or form? Is this linear? Like if I can draw like a straight line, it will fit the data? No. For my model to understand the data, for my neural network to understand the data, it needs to also follow the behavior of the data, right? Like the model is turning here, bending here like this. This yellow color line would be called as the best fit data, correct? What it means is this yellow color line, the yellow line that you see here has modeled a relationship, right? It means it understands how the format or the pattern of the data looks like. So tell me one thing, if I very simply use neural network does linear calculation, anything which is straight. So tell me, if my neural network wants to map this data, would it look something like this? Line 1, for example, line 1, line 2, line 3, line 4, line 5, line 6, line 7, line 8, line 9. Does it look like a very good fit or a fit that I would want in my model ever? To do so much hard work and then make a fit that looks that weird or something very weird that does not fit the data well, I actually don't want to do that, right? I actually want my model to map the relationship of the data the way this entire data looks like, right? Like say for example, if my data set looks like this, multiple different turns and curves like this, I want to fit my neural network's understanding so that it can fit the data well. In order to introduce non-linearity so that your model can turn, bend, twist, basically understand behaviors that do not follow linear patterns, you have to use something called activation functions. Let me also give you guys a very simple example. If I have a straight line like this, okay, my question to you is the equation of linear regression is y is equal to mx plus c. Agree, disagree? So can I say y is equal to mx plus c line looks like this? Example, if I want to make this line bent, I want to take the same line, bend it to make it look like this. I want to take the same line and bend the line like this. Can I use the equation 1 by 1 plus e to the power of minus of mx plus c? The same exact line y is equal to mx plus c has now become non-linear. From linearity, did you go from non-linearity? You made it bend, twist, turn. You made it a little bendy, more flexible. Okay. So tell me one thing. In linear regression, do you use something called sigmoid function? The formula looks like this. 1 by 1 plus e to the power of minus x. Agree? Okay, let me explain it like this. I think this way you will be able to understand the math and the logic pretty clearly. Let me ask you guys a question. Okay. If my data looks like this, area of the house, I have a data set called area of the house. I have the data set called locality, and I have a data set called number of BHK available in that house. Can I use these features to predict the price of the house in the future? What will be the price of the house in the future? So if I want to make this prediction, will my line equation look like this? If it is a linear regression, my equation will look like this. M1 into area plus M2 into locality plus M3 into BHK. Everyone agrees? Plus C. Will this be the line equation that will tell me the price of the house? All I need to do is just give some area, some locality, some price and the value of my y-intercept C. It will help me predict this. Now, instead of this price example, if my data was a variable or a target variable with categorical values, like for example, buy or not buy, example, buy, not buy, buy means 1, not buy means 0, example. So now, will my line equation work anymore? Will it fit to the example that we have? No. So in order to make sure that my number or my output, whenever you implement logistic regression, don't you want your output to be a number between 0 and 1? The number should always be a probability value between 0 and 1. So if I want to convert this line into a categorical variable or an answer, can I say 1 divided by 1 plus e to the power of minus of m1 into area plus m2 into locality plus m3 into bhk plus c. Now your output will be whether the class will be 1 or the label will be 0. Whether to buy the house or not buy the house. Will you get the answer? A number between 0 and 1. So y is equal to mx plus c equation, which was a line, is now converted into a squiggle or an S-curve. I hope you learned in logistic regression a concept called maximum likelihood estimation. Okay, all right. Okay, now listen to me, guys. So first of all, every single person in this class got the idea that activation functions are to do what? To add non-linearity in the data. Is everyone clear? That it is there to give you non-linearity. Now, every single person in this class, listen to me carefully, because whatever we are going to learn right now is going to make a lot of sense to you guys. Okay. So this is my neural network. Everyone agrees? The original neural network that I had plotted in front of everyone to get the output, right? Like this is my original neural network that I have taken. Now what I'm going to do, my people, to this neural network is I will only consider node number 1. In the hidden layer, let's say there are two nodes, node number 1 and node number 2. For now, what I will do, I will take the information flow or the flow of the information from my input layer to the hidden layer only for node number 1 so that we can zoom into it and understand what is working. how it is working. Okay, so what do we do? Okay, so now guys, since I am only using node 1, can I remove node 2? Let me remove node 2 and the connection from node 2 also. Correct? Now, there are three connections that my model is having, right? One, let me remove the second one, and let me also remove the third one. Can I say, guys, between W1, look at this very carefully. This is called W1. This is called W2. This is called W3. This is called W4. This is called W5. This is called W6. Only W1, W3, which is weight 3, and W5, weight 5 is traveling to node number 1, correct? Only weight 1, weight 3, and weight 5 is traveling towards node number 1. Agree? Okay. What I'm going to do, my people, I will split this. Give me 1 second. I'm going to remove this, and remove this. Okay. Let me also do this. You know, guys, the moment I have started teaching deep learning, I have become quite a painter or an artist by myself. I have to draw so many things from scratch in order to make things understand by all of you, right? So it's like I have to sort of rewrite the whole thing every single time I do it, but it's okay. I'm happy to do it for you guys. Wait, and move forward and split it like this, and move this so that it touches the connection here. Okay, good. Okay, guys, my initial node or my hidden layer node is combined of two things, correct? One is called summation, add everything together, and the other part is activation. What I have done, summation I have taken separately and activation I have taken separately. Actually, they are one node, but for your understanding, I have split them into half. Are we clear? I have actually split them into half for your understanding. Okay. Now, everyone, listen to me. How does the information flow from neural networks input layer or the input data feature 1, feature 2, and feature 3? So first of all, is this my data, everybody? Right in front of you, is this my data? The first row value, the row value in the data, 7, 2, 25. Can I say these are the first input values that my neural network will see in his career? The day my neural network is born in a hospital, it will not see its mother or father, it will see the first row of the data. Agree? Row 1, 7, 2, 25. So can I say my input is 7, what was the next value? 2, 25. Can I say this is the input to my network? 7, 2, 25. Okay. Guys, whenever you run the neural network, okay, every single time a neural network is written, the initial weight values do you see, right? W1, W2, W3, W4, W5. The values of the weights are assigned randomly in the beginning. Are you understanding? Some random value will be given 0.2, 0.3, 0.169, 0.23147, 8.619334. Whatever random value you want to give, you can give. Are we clear? So can I also assume that the weight 1 value I will take is 0.1 randomly? No reason, just random value. Can I do it? You should do it. This is how it works. W3 is equal to 0.1 and W5 is also is equal to 0.1. So randomly speaking, did I just take 0.1 for all? For simplicity, you can take any random values you want. Anything you want is fine. Now tell me one thing. Because this node is a part of my hidden layer, will a bias also be added? Will you have to add a bias also called B1? Now, for simplicity reasons, my bias value that I'm randomly taking is -4. Okay, I'm taking -4. So see guys, when you combine your input layer to the first activation to the first summation layer, the output of this particular data will be called as Z1. What do we call it? We will call this Z1. So why negative value for bias here? Like I said in the beginning, it's random. It could be positive, it could be negative, it could be any number, my dears. It is just some random values I'm taking, which has nothing to do with anything. If you want to give me a value, please give me a value. I can add that also. So weights and biases, okay? Both weight values and biases value are assigned in the beginning of the neural network completely randomly. Any number can become weight, any number can become bias. It could be from negative infinity to positive infinity. It could be a float point value, integer value, anything. Anything. It should be a number, that's it. Are we clear? Is everyone clear that the weight values can be completely random and in reality also they are random, okay? Just that they are better random called he initialization. I will come to that later, okay? Sir, how do we come up with the logic, how to decide it randomly? Actually, we call this as he initialization. It's called came-in initialization, but we'll talk about that maybe some other time. So tell me, okay, can we take all weight values different from each other? Yes, you can. You should. You can. It's okay. I am taking it so that the math becomes a little easy to implement. You can take 100 also if you want, 2000 also if you want. No problem. It'll work. Clear? Does every weight value needs to be same? The answer is no. So let me repeat myself once again. Should every weight values be same? No. Can they be same? They can be same. If you want all the weight values to be same, you can do that. But in reality, does that work in real thing? No. Random values means they can be completely random. Weight values don't need to be same. Guys, you also have to understand one thing, that I am just giving an example to make the math easier for you. So if I have taken all the weight values same, it's just to make the math easy. If you just replace the number with your favorite number, the math will still work. The math will not fail. It will still work. So the first step in your neural network is to resolve the hidden layer, right? Whatever your output you are getting from the hidden layer, that you need to get. No, the information is passed from input layer to the hidden layer and from hidden layer to some output you are generating. Your goal is to first get that answer clear. So first of all, tell me one thing, guys. I have the first row value, which is called 7, 2, 25. So have I taken 7, 2, 25? This is my information. This is the information that I want to put inside my neural network. Okay, that's done. So guys, if you want to calculate the value of Z1, you know what you do, my people? Multiply the weight value with its preceding feature 1 value. So for example, can I say, rather than taking this as F1, F2, F3, can I please take this as X1, X2, X3? Can I do it, guys? Will you still understand? Rather than calling it F1, F2, F3, can I call it X1, X2, X3? The formula will look like this. Weight 1 value multiplied by X1 value, or let me take it in black. So the formula of Z1, or this output Z1 that you see here, will look like this. Z1 is equal to W1x1 plus W2x2 plus W3x3 plus whatever bias you are passing in node number 1, that bias 1 will be passed. So can I say things like this? The Z1 value is nothing but whatever weight you have, multiply it with the input plus weight 3 multiplied with the input x2 and weight 5 multiplied by this. So in simple plain English, W1, this will not be W2, W3, this will be W3, W5. So this will be W3, X2 and W5, X3. Now this will make a more sense. So this summation step that you see here, in mathematics, summation means add things together, correct? Agree? So before passing the data to my hidden layer, what do I need to do? I need to multiply my input feature with the weight value, input feature with the weight value, input feature with the weight value, and add everything together. And now that data should be passed to the hidden layer. Are we clear? You need to multiply all the weight values with the preceding feature values, multiply them together with the bias value and pass it to the hidden layer. So can I say, my people, that my data is ready to pass? So tell me, let's calculate the math. 0.1 into 7 plus 0.1 into 2 plus 0.1 into 25 minus 4. because plus minus is minus, so minus 4. What is the output? 0.1 into 7 plus 0.1 into 2 plus 0.1 into 25 minus 4. What is the answer? Negative 0.6. What is the answer? Negative 0.6. So everybody, my Z1 value that I got is how much? Negative Z1. Now guys, the Z1 value, who are you passing it to? Are you passing it to an activation function? When you pass this Z1 to the activation function, the output you will get will be called as G1. What will we call this? G1. So, guys, the activation function I will use to teach you an example will be the sigmoid activation function 1 by 1 plus e to the power of minus x. Are we clear? So if I want to get the value of G1, okay, so let me move this a little to the left. Give me 1 second, guys. Let me do a little sort of correction. Okay. If I take this part of the math, move a little bit to the top, or maybe somewhere here, or maybe here is fine. Let me remove this activation function equation. Don't want to confuse you with anything else. Let me delete this. Okay. Now, if I want to calculate the value of G1, okay, what can I do? Can I say that G1 is equal to 1 by 1 plus e to the power of minus of z into 1. This will be G1. So answer will be 1 by 1 plus e to the power of minus of 0.6. What is E? E is called Euler's constant. So let me explain something to you. Guys, in mathematics, have you heard of something called irrational numbers? For example, the value of pi. Can you take the value of pi and divide it by a divided by b? Can you come up with a pi value where a and b are a number that you know? You can't do that. It's impossible. Irrational numbers cannot be obtained like this. So E is nothing but Euler's constant. I think it is 2.7 something 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 something. Like the value of pi is 3.1415925 and on and on and on. 2.7 something something is called Euler's constant. Are we clear? Right? That is called E. So if you solve this particular answer, what do you get? 0.354. The answer is 0. Guys, you passed the information 7, 2, 25, but the way it came out of the hidden layer node 1, did it become a number called 0.354? Are you understanding how your information is transferred through networks, through nodes, and how the numbers are changing every single time? How you pass the input data as 7, 2, 25, by the time it went through the summation, through the activation, and you got the output from node 1, you got the answer as 0.354. Now tell me one thing, because we have done it for node number 1, should we repeat the same exercise for node number 2 also? We should, right? Because so far we have only covered node number 1, not node number 2. So guys, can I copy paste the same diagram? Same diagram, I will copy paste the same diagram, but this time I will repeat it for node number 2, right? So let me move this here, and the connections will change now. Like for example, the connections will be slightly different, right? So let me move this. Let me change this and this. Let me change bias value as well, this as well, and this as well. Okay. And I can say this. Now I will move this like this. And what connections were possible? Yellow, green, and blue. Okay, yellow, green, and blue. So yellow, then green, and then blue. So guys, can I say this is my node number 2 of a hidden layer 1? So now, can I call this particular value as W2, W4, and W6? Because W2, W4, and W6 are connecting node 2. Agree, disagree? The output of this function to this function, instead of calling it Z1, since you are dealing with node 2, can I call the output as Z2? And the output from this layer to this layer is called G2. Agree? So the math that we implemented here. Okay, so let's take some random values. So random values of W2, can it become 0.16? Maybe W4 will become 0.5 and W6 will become 0.6. So you have taken random weight values here, and the bias value that you will add here, which is bias number 2, let's say bias number 2 is also -4. So first of all guys, what will be the equation of Z2? Can I say Z2 is nothing but W2x1 W2x1 plus W4x2 plus W6x3 plus B2. Can I say this would be the equation if I want to calculate the value of Z? So guys, what is the W2 value? 0.16 multiplied by x1, 7, plus W4 is 0.5 multiplied by x2 value is 2, plus 0.6 multiplied by Wx3 value is 25 minus 4. What is the answer? 13.12. But your 13.12 now needs to pass through the activation function. Agree? So can I say G2 is equal to 1 by 1 plus e to the power of minus of Z2. So 1 by 1 plus e to the power of minus of 13.12. 0.99. Okay. So can I say 0.99 is approximately 1? So G2 is 1. So I don't have to deal with 0.0.0 every single time. So can I say the value of G2 is 1? Okay. Did I get the output for the first layer in my neural network? I passed the data from my input layer to the hidden layer, and your output from the hidden layer is what? So taking this neural network, we ran the neural network's hands-on code, and we got the output for my output node, which is the output node value came up to be how much? 0.354. So the value of G1 that I got was 0.354, and the value of G2 that we calculated is 1. Agree? We passed the data from input layer to hidden layer, and this is the output that I got. But tell me one thing, doesn't hidden layer to output layer also has something called weight 7 and weight 8? There are two values called weight 7 and weight 8. So tell me one thing, do I have to still go through the multiplication of my hidden layer to this? So if I just remove this part, is this portion of the neural network pending? This calculation I have not done. So tell me, after all of this, do I also need to add another bias because my output node also goes through a bias called bias 3? So tell me, my people, once you multiply this answer, will you not get an output value because output node is just a summation node? So can I say it directly like this, guys? Y underscore pred, my predicted value will be W7 multiplied by G1 plus W8 multiplied by G2 plus B3. Can I say it like this? Because my input node value is 0.354 and my input node value is 1. I am multiplying this exactly what I did previously. So what is my W7 value randomly? I'll say 7 multiplied by 0.354 plus W8 value randomly I'm taking it to be 3. So is equal to 7 is equal to 3. Some random values I'm taking. 3, G2 value is 1 and the bias value, let's say bias value is 12 plus 12 example. 17.47. So tell me, my people, what answer did I get from the neural network in the first answer? Y predicted value? The output that my neural network gave me is, I think if you have 7 cups of coffee or 7 hours of sleep, 2 cups of coffee and 25 minutes of travel time, according to my neural network, how much will be my productivity score? 17.47. Did I just show you guys how to make a prediction using a neural network? So tell me guys, if I want to calculate the error, can I say error is nothing but actual data minus predicted data? Agree, disagree? What is the actual data in the data set? What is the actual data? The actual value is 85. What is the answer? 85. Minus what is the predicted value? 17.478. Agree? What is the error? 85 minus 17.478. What is the answer? 67.522. So the error I got from my model is 67.522. This is the error, the mistake my neural network has made. How much error it made? It made 67.52 error. But tell me one thing, isn't this just the first row you gave the neural network? So it is still learning. It hasn't learned anything yet. It was the first data you passed. It's still learning, of course. But were we able to calculate the error? My people, the steps that I just taught you from this to this is exactly what we called as forward propagation. Are we clear? You just learned a topic called forward propagation. Now tell me one thing. Why bias is required for output nodes also? Because you cannot selectively add bias only to the hidden layer and very selectively leave out the output node. If bias needs to be added, it needs to be added to every hidden layer, every node of hidden layer and the output layer. Because input we already know. So I can't change my input, but hidden layer and the output layer will change. Hence we add bias to output also. See guys, the value of E is called 2.71828. The E is also called exponent, is a Euler's value. It's an Euler's constant. Okay. Now, is my job done? Is my neural network training done? No. Okay. Let's go a little bit more deeper. The reason you split the hidden layer into summation and activation both. See, let me tell you something. Okay. Sir, don't we apply activation function to the output node also? The answer is yes, we apply. We definitely apply. I'm not saying we don't apply. The reason we apply is more interesting. I'll give you guys an example. If I plot a sigmoid curve, will it look like this? Any value of x you have, any value of x, if you give to the sigmoid function, will the output be always between a number between 0 and 1? No matter what the value of x is. X could be 1 million, 1 billion, 1 trillion, 1 trillion, trillion, does not matter. The output of that particular answer will always be between 0 and 1. So if you don't want your linear regression output, I want classification output. So in the output node, can I also apply the sigmoid activation function so that the output is between 0 and 1? And now I converted my linear regression neural network into a classification neural network. I am not saying in the output layer you don't add activation function, but doesn't that depend on what the goal of the project is? If the goal is regression, then you don't apply any activation. But if your goal is classification, then applied sigmoid, and now the answer will be between 0 and 1, and you will either get 0 or either get 1 depending on the threshold. Okay. So far, we learned something called forward propagation. We have only done 50% of the work a neural network does, because I just taught you a second ago that in a neural network, the information needs to go one thing forward called forward propagation. But once you know how much mistake you have done, don't you need to go back and fix the mistake, everybody? That fixing the mistake is called backward propagation. Clear? So now my people, I'm about to teach you a concept called backpropagation. Okay? Let me call this and write down the title, backpropagation. So first of all, why do we need backpropagation? Because we need to update what, my people? Two things. We need to update our weights plus biases or bias until the error the error between actual data point minus the predicted data point is what? Is as minimum as possible. This simple English definition, is it making more sense rather than giving you more technical jargon? We do backpropagation because we need to update the weights and biases in my neural network model so that the difference of actual value minus predicted value is as minimum as possible. Let me give you guys a simple example. When you go shopping and your mother goes shopping, do you know what is the difference between you shopping and your mother shopping? If the vendor or the salesman tells you, ma'am, this jacket is only 5,000 rupees after 50% discount. Ma'am, don't worry. It's only 5,000 rupees. You will say that, oh, can you give it to me for 4,800 please, 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 pretty please. And then the vendor will say, okay, ma'am. But your mom will say, can you give it to me for 500 rupees? You see, Indian mothers don't bargain because they don't care what is logistics cost. They don't care manufacturing cost, marketing cost. When you go to the mall, there is also rent that the guy has to pay. Your mother will start at 500. You know why? The difference is your mother wants the item as minimum as possible in this given God's earth, as less as possible. But you are okay if somebody reduces even 100 rupees. Because she has experienced the world more than you, she wants to minimize the cost as much as possible. Just like how your mother is so adamant, so confident, and such a powerful person to reduce the cost of the item she's purchasing, the neural network also wants to do that. Are you understanding? The neural network wants to very deliberately, with confidence, like a mother, wants to reduce the difference between actual value and predicted value as much as possible. Are we clear? So in order to do this, do I need to update my weight values and my bias value to make sure that the error is less as possible? That is exactly what we are going to be doing. But in order to perform backpropagation, first of all, you need to know certain things. Number one, you need to learn a topic called gradient descent. Have you ever heard of the concept called gradient descent? What a gradient descent does? What does it do? Okay. Can I say this, my people? We calculate partial derivative of a cost function with respect to each parameter, meaning your weights and your biases. Then move in the negative direction. Now, if I give you this definition that I wrote, doesn't this sound like something that is too fancy, too technical, too much into, oh, explaining such crazy awesome stuff, right? Explaining something in such jargonish terms make no sense, right? Okay, let me give you a simple idea. Do you see this curve in front of you, everybody? This U kind of curve, okay? Do you see this curve in front of you? There are two curves in front of you. Okay. Guys, the goal of gradient descent is what? What does gradient descent do? Number one, it's an optimization algorithm. What algorithm? What does it do? Optimize something to make something as best as possible. Okay. So first of all, sir, what do you do? What does gradient descent do? What do you mean by that? Okay. Guys, is this a curve or a function? Can I say this is a function of sorts? Okay. Can I say this is also another function? Okay. If you take a ball and leave it here on this particular curve and leave it, will the ball roll automatically to the lowest possible point, which is here? But if you take a ball and roll it in this part, where will it go? Where will it fall? Will it fall here and that's it? It will be the end of it. Agree? Now in this curve and in this curve, in curve number 1 and in curve number 2, which point is the most lowest point? The most lowest point potential. Can I say this point is the lowest point in my entire particular data? And this point is the lowest particular point in my data. Agree? The one that has the highest, or sorry, the lowest point. Agree? When I roll the ball in this graph, it will always reach here. But what about this graph? It won't, right? If you just roll the ball, will the ball not come over and accommodate here? And that's it. This is where it will sit. Whenever you take any mathematical function, the most interesting point you want is you want to reach the most minimum position, and this is called global minima. What do you want to reach? The most minimum, or the most deepest point in the graph, and that graph value is called, or the technique name is called, global minima. Agree? I'm going to tell you guys something which will make you understand gradient descent not in detail. I'm not going to go to the math behind it. Okay. The most important factor in machine learning is, I'm only giving an analogy, of course, but here's what I want you to understand. Okay. If my graph looked like this, example, what happens now? Now tell me, will the ball, no matter how position I drop, will it bounce over and fall to this trap? So it will roll over, bounce back, roll over, bounce back. Okay. Sir, how did we even come up with this shape? Isn't somebody confused? Sir, how did we decide it is a curve like this, or a curve like that, or a curve like this? Yes or no? So let me ask you guys a simple question. Guys, when you train your machine learning models, your loss value should decrease, 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 and decrease. Agree? Your loss should decrease, right? The number of epochs, or the number of training data set, the loss will decrease. After a time, when the loss decrease, it will reach a very optimal point where the loss was the minimum. If you expand it even more, will it start increasing again? Let me give you guys an idea, right? Let's say you go to a store to bargain about the price of the product. Okay. The customer reduced the price to, say, first 500 rupees. Example. Okay. Say, for example, for 500 rupees. Then reduce, then reduce, then reduce. But after a certain point, no more reduction is possible, correct? There is always a limit to everything, including the loss function. If your machine learning model is running, it is loss is decreasing, 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 decreasing. And then suddenly, if you keep making your training algorithm run again and again and again, it will start increasing again, right? So tell me, which was the best possible value where I got the best possible result? Can I say the global minima was the best possible value of y and the best possible value of x where I got the most minimum number possible? Agree? I hope you got the logic until here. So that is why we are more interested in calculating something called global minima. I hope everybody got the logic. Whenever we do optimization, optimization means whichever is the global minima gave me the best possible output for that machine learning model. Are we clear until here? So gradient descent, whatever you are seeing that I am talking about, is more interested in calculating something called as the global minima of the data. In this particular graph, this part, the green part, is called the local minima, and the red part is called global minima. Are we clear? This green thing is local minima and the red one is called global minima. Okay, so please remember, like I said, I am not teaching you gradient descent in detail, because since you guys have an idea about it, and I don't want to go to the complicated math because that will take a separate one single class, but you got the idea, right? In gradient descent, our interest is global minima. That is my most important aspect. I'm not even going to talk about the gradients or the slope that you're going to take. Okay, anyways. So what defines a gradient? Imagine you want to go from your house to your school, taking small steps. Multiple small steps made you reach the entire school. Agree? The small steps, each individual small step is called as a gradient. That each small individual steps that you have taken to reach your destination is called as gradient. Mathematically speaking, from the perspective of gradient descent, what you need to understand is, if I roll the ball, Can I say that the ball can make a very big jump if I want to reach global minima, then a small jump, and then a third small jump will give me the final reach I want to the global minima? Now tell me one thing, can my ball also make this mistake? Jump too high, then another jump. So how do I do this? Make a very high jump, then another jump, and then come to this. Which one is more effective? The blue one or the green one? So gradients is basically nothing but slope or tangent. But if you don't want to go into the math, just say they are the steps my optimization algorithm takes. I hope you got the idea how much jump you take to reach your global minima. Those steps and those jumps are called gradients. Small gradients. Many people confuse gradients with something called as learning rate. I am not okay. So first of all, let me ask you a question. Have you ever heard of the concept called gradient descent in your past? Okay. I want to practice backward propagation or back propagation. In order to perform back propagation, you need to understand the concept of partial derivatives. Okay. Partial derivatives. See guys, the aim of my back propagation algorithm is to update my weights and biases until the error between the predicted value and the output value as less as possible. Okay. So tell me one thing, my people. The cost function in our example is nothing but actual data minus predicted data. Agree? This is my actual cost function, the one that helps me calculate the error. To make sure that your answers are always standardized, you take actual minus predicted and you square them. Are we clear? Because actual minus predicted can be a negative number also, a positive number also. I want my error to be a positive number. So what do I do? Actual minus predicted the whole square. That's it. Your job is done. Now, my people, I am going to take this particular graph because to make predictions in my neural network, wasn't this the last step that I implemented? So to go back, I have to go from this direction only. So tell me one thing, sir, if I want to do back propagation, this is the step you calculated ypred. After ypred, did you not calculate the error y actual data minus y predicted data, the whole square? From the y predicted value, you calculated the error or the cost function. Guys, just like a human being, when you want to go backward, first will you go from this particular function to this particular function? Will you make a jump? If I want to go back, I have to go back from this function to this function, correct? Then from this function to this particular function. This is how I will go back, right? So what did we do? To go back, okay, to go back, I have to go back from here to ypred and from ypred to somewhere else, okay? Ignore this for now. Did you understand this connection, this red color connection? So guys, when I went forward in my neural network, I went like this, right? From here to here, I went from here to here, then from here to here. Now, if I want to go back, should I go back the same way? Here to here and then back? Are you understanding? I am following the same thing that I did to go forward. Now I'm following the same thing to go backward. Now, guys, going backward isn't as easy as it seems. The reason is you have to use a concept in mathematics called chain rule. Okay. Now, for people who don't know what differentiation is, let me explain the concept of both partial differentiation or partial derivatives and calculus or differentiation. Let me explain the concept slightly, or how about this, right? Like with respect to cost, all right, guys, if I have a number called 4x to the power of 3, okay, 4x cube, or let me take a number called 3x to the power of 4, example. If I want to differentiate this number with respect to x, so d by dx, or if I want to differentiate it, example, take the value of 3 separately, x to the power of 4 minus 1. So can I say 3 into the value of 4 will come down as it is, or you know what, I think let's skip this for now. I don't want to confuse you anymore. Let's just skip it. I don't want to give you guys any unnecessary trouble right now. Okay. My y actual value and my y predicted value, which is called my cost function. Okay. Very simply, this is called as my cost function. My cost function is dependent on ypred. Can I say my cost function is dependent on ypred, and my ypred itself is dependent on the W7 value. If my W7 value was different, my ypred would be different, and if my ypred was different, my cost function would have been different. Can I say this is the relationship of y actual and ypred, which is cost function with respect to 7? Or the W7, this is the relationship. This relationship, if you want to write in mathematics, how do we write it? We write like this: del of cost divided by del of W7. Meaning, how much is W7 responsible for the change in cost function? This is what this means. So can I say that the relationship is cost function is mapped with ypred? So can I say del of cost is mapped with del of ypred? Agree, disagree? Cost is directly connected to ypred. My cost function is directly connected to ypred. And what is your ypred connected to? What is your ypred connected to? W7. So del of W7, are you understanding or not? Did you get the logic what I did here? When I wanted to understand how can I directly connect W7 with del cost or this value. So I said, look, don't make such a large jump, which is this value. Say that cost is connected to ypred, which is here, and then ypred is connected to W7. So did you understand the formula? Right? But guys, listen to me carefully. The value of ypred or the formula of ypred, isn't it mentioned here? Listen to this. W7G1 plus W8G2 plus B3. We already have the value of ypred given to us. Copy and paste. Don't I already have the ypred formula from our previous calculation? This is the value of ypred that I have. Now guys, listen to me carefully. When you calculate del of ypred divided by del of W7, guys, can you see here W7G1, W8G2 and B3? Out of these three things, which equation mentions W7 specifically? The first one, second one, or third one? Is W7 mentioned only in the first one and not the other one? Wherever it is not mentioned, automatically the number becomes 0. Are we clear? When you do partial derivations, when the equation or the variable in the bottom does not exist in that particular equation, automatically they are 0. And wherever you have W7 mentioned, replace this with 1, the number 1. So can I say the answer is 1 into G1? So the answer is G1. Okay.
Hello everyone. Intellipaat offers executive postgraduate certification in data science and artificial intelligence in collaboration with iHub IIT Roorkee. Through this particular course, you'll get to learn multiple tools like Python, PySpark, SciPy, NumPy, Pandas, Matplotlib, TensorFlow, Git, etc. You are going to learn multiple skills like data science, natural language processing, deep learning, fundamentals of generative AI, prompt engineering, and application based generative AI, as well as recent trends like agentic AI. This course is designed to get you ready for the AI world. So do check out link available in the description. Also through this course, we have already helped thousands of learners take positive step in their career. You can check out their testimonials on our Achievers channel.
Or rather, when we did forward propagation, we actually made sure that the flow of the information went from the input layer all the way to output layer so that you get a prediction called ypred or y prediction value. Now, When you did Vipred, which is basically go from the information to input layer to output layer, you basically get an output called Vipred, and the Vipred is 17.47. Now error, or the cost function, for now let's only call it error, is equal to actual minus predicted, and you got the error as 67.522. Forward propagation is always used to make a prediction. But remember, in a neural network, the soul of a neural network, the learning of a neural network, the intelligence of a neural network is actually controlled by two factors, the weights and the biases of that neural network. Because it's the weights and the biases of the neural network that it goes through multiple different instances of data. It learns the pattern within the data, and then it is able to make a prediction in the future. So remember, it's the weights and the biases of the neural network that makes the network intelligent. But as I already told you, whenever you learn or you work with a neural network, when you are building the neural network for the first time, the weights and the biases are completely random. Okay, what they do, you can take any specific value for the weights and the biases, and then pretty much you can start your neural network from then. Once we complete the forward propagation, we actually go ahead and we learn or we implement something called backpropagation. In backpropagation, the intention or the goal is to update the weights and the biases until the error between the actual and the predicted value is as minimum as possible. And I also gave you guys an example about a concept called gradient descent. Okay. And then I was teaching you guys a concept where you see what dependency or what and who is dependent on whom concept in backpropagation. Your y actual minus y predicted the whole square value is called as your cost function. Can I assume my understanding? Is my understanding that my cost function, which is y actual minus y pred the whole square, okay, is dependent on y pred. My y prediction or my y pred is dependent on the weight value W7. So when you write down the dependency factor here, you get this particular equation. Del cost by del W7 is cost with respect to y pred. So cost with respect to y pred with respect to W7, y pred with respect to W7. You already know that y pred with respect to W7 or a partial derivation of y pred with W7 is G1. So tell me, can I replace this y pred by y del W7 with something called G1 multiplied by G1, everyone? Can I do this? Because I already know the answer to this. Now, what is del cost by del y pred? See, guys, you already know del cost is nothing but y actual minus y prediction or y pred the whole square. Okay. Now, if you know your y pred value is called as W7 W8G2 plus B3. How did we get the y pred value? Do you remember that your G1 gets multiplied with W7 plus your G2 gets multiplied with W8 plus the bias 3 together is called as your y pred. Now guys, in mathematics, there is a concept called partial derivations or partial differentiation. Okay. Now partial differentiation or your derivatives which are partially derived, right? The concept of partial derivations is built in such a way that if you take the equation del y pred with del W7, okay, you want to have a partial operation with respect to W7. So tell me, in this equation W7G, in this equation W7G1, W8G2 and B3, which portion of the expression has the word W7 in it? W7 is mentioned in it. W7 G1 is the only one where W7 is mentioned, correct? Other places it's not mentioned. Wherever it is not mentioned, they automatically become 0. If you are partially differentiating your equation with W7, that expression that is mentioned there needs to have W7. And wherever you have W7 itself, the one you are differentiating it with, please replace that with 1. Multiply or replace it with 1. So will I get 1 into G1? So I got the answer G1. Everybody, we replaced it with G1. Now guys, in working with differentiation, suppose if I have a number called x square, suppose x to the power of 2. See, when you differentiate with this with respect to x, the 2 will come to the bottom. So 2 into x to the power of whatever is the exponent, you subtract it with 1. So can I say 2x is the differentiation? If I derive a derivative for this particular value, x square will become 2x. So tell me, your y actual minus y prediction, the whole square, if you consider this part as an x, so will you get 2 into y actual minus y pred? So basically x square becomes 2x. So the answer here would be 2 into y underscore pred minus y underscore actual, or anything, you can just ignore the signs because it is square, but yeah, 2 into y pred minus y actual into G1, right? So 2 multiplied by, what is y pred minus y actual, guys? Is it 67.5? Is it 67.5? The y pred minus y actual. So let me ask you guys something. Okay, it's a simple concept, not a very complicated. See, I'm going to replace the whole thing. My y pred value was 17.47 something something, right? So 17.478 minus what was the value? 85, right? Minus 85 multiplied by 0.354. What will be the answer to this? What is the answer? Everybody? 2 multiplied by 17.478 minus 85 times 0.354. It should be somewhere in negative. In forward propagation, the error value is too large. Is it okay? Yes. In the beginning stage of machine learning or neural network, it is okay. But the error should decrease eventually. In the initial stages, that's okay, Shubhash, that's how any neural network works. But eventually the error should decrease. Okay. So the answer is negative 47.80. Correct? Is the answer correct? My del cost with respect to del W7 is negative 47.80. Is my understanding? Guys, you were able to see that, or you were able to check that how much effect, what is the effect of W7 on you just calculated that. What is the cost? Okay. What sensitivity is cost function with respect to del W7? But tell me one thing. Totally in your neural network, how many weight values do you have? W1, W2, W3, W4, W5, W6, W7 and W8. 8 weights are. What did you change right now? Did you change the weight of a specific node which is called W7? Yes or no? Now, because W7 is calculated, is your job done? No. Now what you will do, you will calculate what, my people? The effect of y pred minus y actual the whole square with respect to y pred. So basically, my cost function is directly affected by y pred, and y pred is also affected by what value? Wait, agree, disagree? So if I write down the math behind it, let me sort of reduce the size of this. Give me 1 second. How do I do this? Boxed. So if I reduce the size of this and move a little to the left, so can I write it like this? My cost function is also affected by the weight 8 value. My cost function is directly affected by weight value. But since I cannot make a direct connection, can I say cost function is very recently affected by the ypred value? So del of cost divided by del of ypred. Can I say the same thing? And then the ypred is directly affected by weight 8. So can I say multiplied by del of ypred, which is my ypred value, divided by del of w8? Yes or no? Agree, disagree? Now, we already know that whenever you do del ypred by del w7, the answer is G1. So if I do del ypred by del w8, the answer should be G2. Because the logic works pretty much here as well. Same thing can be applied here also, right? The partial derivation of del cost by del ypred is same, 2 multiplied by y predicted minus y actual into G2. So tell me, what is the formula is 2 into 17.478 minus 85 multiplied by, what was the value of G2? I'm thinking 1. Yeah, it was 1 multiplied by 1. So can somebody give me the answer? What is 2 multiplied by 17.478 minus 85? If you multiply everything together, what would be the answer? Are you sure? It's positive 135. It should be negative 135 because the negative sign on 85 has a larger number, right? So the polarity has to be negative. Okay. So did we calculate the del cost by del W8, everybody? We calculated how much effect or sensitivity cost function has with respect to W8. Did we calculate both? Guys, if you really think about it, my ypred value or my cost function, isn't it also affected by B3 or the by practically it should also be affected by the bias value. So what we do, my folks, is we calculate the del cost divided by del of B3. See, this was my first calculation. Del cost by del W7, del cost by del W8, and the third one is called del cost by del B3. Now what you do is del cost by del B3 actually goes like this. Your cost function is affected directly by something called del ypred, and del ypred is responsible or affected due to B3. Now you don't go all the way to W7. So pretty much del cost divided by del ypred, same exact concept, and your del ypred is affected or caused due to del B3. Right? Now let me ask you a simple question. Guys, your del ypred partially deriving it with del B3. So tell me one thing, if I ask you a question, what is the equation of ypred? Okay, what is the equation of ypred? Why are you not using actual minus predicted? So most actual minus predicted is not going to give you the answer that has, how do I say this? Any positive. Okay, let me ask you like this. Actual minus predicted, it can be in any polarity it wants. Actual value can be larger, predicted value can be smaller, the number will be positive. The actual value is smaller, the predicted value is larger, the answer will be negative. When you don't want any differences between the actual and the predicted in any negative form, don't we apply square to it? Because in mathematics, when we take square, it looks like this. This is the graph of a square. If I want to derive or differentiate an equation called square, can we do it? The answer is yes. So the advantage of using actual minus predicted the whole square is way higher, also logically correct, than directly just using actual minus predicted. The reason is, if the actual value is a big value and the predicted is a smaller number, the answer or the result always will be positive. And if the result or the actual value is lesser and positive is larger, the answer will be negative. You will be dealing with a lot of polarities, plus and minus and plus and minus. We don't want to deal with that. I want every single answer to be standardized and become positive. So make sure that eventually errors can be added together, combined together, averaged together. We take a square, convert everything into positive. So the two main reasons why we take a square is because square is something that can be very easily differentiated. If you can see this particular equation here, del cost by del y pred. Actually, this is an equation which is y pred or y actual minus y pred the whole square. If you differentiate this, it is very easy to differentiate a square equation than, I don't know, than saying that I have a abs operator like this, like converting a number -6 into positive +6. So this is one of the main reasons why we use something called as a square. That square is to make sure every single number's polarity ends up being positive. The error always ends up being positive. I can add them together, average them together, sum them together, whatever I want to do with them together could be later. So let's talk about del cost by del B3. Now guys, if you talk about y pred, what is the equation of y pred? Your y pred looks like this. If you can see here, I have the equation of y pred the way I wanted it, right? Let me just copy this and paste it. And paste it here. So del y pred looks like this. Your W7G1, W8G2 and B3. My question to every single person in this class is, please have a look at the way I am differentiating this, right? Del y pred divided by del of B3. Tell me this, guys. In which part of the expression that you see here, B3 is mentioned very specifically? Is B3 mentioned? No. Will it become 0? Will this particular thing has no B3, so it will become 0. This will become 0. I know this has B3. B3 should itself be replaced by 1. So the answer is agree, disagree. So del cost by del y pred is 2 into y pred minus y actual, the whole, okay, actually it's differentiated, right? So 2 multiplied by 1. So what is the answer? I think the answer is same, 1 negative 135.044. So tell me guys, did you get this? We've calculated with respect to one bias value and two weight values. Agree, disagree until here. What you did is you've essentially calculated the weight values for what? W7, W8 and B3. Agree, disagree? Now tell me, you want to update to the new, the old values of your weights W7, W8 and B3, you want to now update them. I want to make sure that they change now because I have already seen what the result is. According to the result, to make sure that my error is as minimum as possible, I want to update it. This is where we use the equation of gradient descent. So the updated weight 7, the new weight 7 would be the old weight 7 minus the learning rate eta into del cost divided by del W7. This, my people, is what a gradient descent equation looks like. So tell me one thing, what is the updated, or sorry, what is the old value of W7? What W7 did we take? 7. The old value of W7 is 7. 7 minus, guys, this eta that you see here is a set or is given by us as developers. So let me take eta as 0.01, which is the usual learning rate that usually most neural networks take. So 7 minus 0.01 multiplied by, what is del cost by del W7? Negative 47.80. Negative 47 point, what is it? 8. Okay, negative 47.8. Can somebody calculate this? What is 7 minus 0? Yes. 6. Did you get the updated weight value, my people? Once you make the prediction in the forward past, while going backward, you told the neural network that, hey, your weight 7 value, which was previously 7, should now become 6.53. Are we understanding? You just came up with the updated weight value, the one that needs to be calculated. See, all the math, all the hard work that I'm doing right now for us, I'm gonna say us. See, I could just brush off very basic topics and just be the end of it. If I'm making sure that we are going through the math behind it, at least let me know if you guys are understanding. Because if we go through the entire topic in detail and half of you are already in the dream world, somewhere with a gap in your knowledge, what's gonna then the whole sort of the logic that we have is not gonna make sense. So let me understand. 7.74, 7.47. Oh, okay. I didn't know that. 7.47. Somebody calculated it. So is it 7. Is that correct? Whatever you guys say, because I don't know. I have not calculated it. 7.74. What is you? So for it is not n, it's eta. Eta. In Karnataka, we call food as uta, and this is called eta. Okay, eta is what you call as a learner. We could directly jump into coding, but the problem is I don't think that will give you a lot of clarity. Okay, so if it does not give you a lot of clarity, that then learning AI makes your foundations very, very weak. Okay, so since we are going through the math behind it in a very learned something important, and that importance was when you do back propagation, you change the weight values. Agree? You do back. While doing back propagation, you always make sure that the previous weight values are updated or changed when you do a single back propagation. Meaning, when I did forward propagation, I had some weight values. But when I went backward or I am going backward, I am basically changing my weight values that caused the data to pop up in a certain way. Yeah. So in that example, right, or in that what I'm doing with this particular variable or that particular data is just making sure that I implement a gradient descent function. Concept is in simple plain English or just mathematical terms, right? Your updated weight, WEIGHT, your updated weight value is your old weight value, old underscore WEIGHT, minus your learning rate multiplied by the gradient that you want to provide. So the old weight value was W7 minus your learning rate would be learning rate. Call it alpha, call it eta, whatever you want. Let's call it alpha, let's call it eta. Learning rate, what is your learning rate? 0.01. Let me remove this. Let me say 0.01 multiplied by the gradient is going to be that particular thing. Now tell me, my gradient or the one that calculates the sensitivity, the causes of the change for cost is del cost divided by del W7. Now we know that the answer we got was how much? What was the topic? W7 is how much? The old weight value is 7 minus 0.01 multiplied by minus of, see, we got the answer called 47.8. So we got this as 47.8. And I think everyone did the math, right? What was 7 understanding? Okay. So your updated weight 7 value is 7.47. Everyone with me until here? Once you updated the updated weight value for W7, should I do it for W8 also? The updated weight 8 value is W8 old minus 0.01, which is my learning rate. You can call it eta, you can call it alpha. Alpha and eta represents your learning rate. multiplied by the gradient, which is del cost divided by del W. So if I take the W8 value, what is the W8 value, everybody? What is the weight 8 value that we know? It is 3. 3 minus 0.01 multiplied by what is the del cost divided by del W8 value? Del cost by del W8. It is negative minus 1.04. Tell me, everyone, if I multiply these, what answers will I get? What would be the answer if I have them multiplied? 4.3 minus, in a simple, how do I say this? 3 subtracted by, first of all, 0.01. This is my learning rate. On top of it, I am multiplying the whole thing with negative 135. So negative 135.04. If I multiply this, 4.35. Do you see that my updated weight value became 4.35? What was the old value of W8? It was 3, but the updated value of W8 became 4.35. Did you get the? Your weight values can increase or decrease, does not matter. We are basically changing the weight values, the intelligence in my model, such that my model is able to make a prediction in the future where the difference between actual and predicted is as minimum as possible. That's great. Now, should I also change my updated bias value, guys? My B3 plus the updated bias value would be what? The updated bias value would be same thing. My B3 minus my learning rate value multiplied by del cost. So if I take the same exact thing, I can say this as B3 minus, which is going to be old B3 value eta with respect to del cost divided by del B3. Now, if I replace the value for B3, what was B3, guys? In our previous example, it was 12. 12 minus 0.01 multiplied by what was the value of this B3? Yeah, it was is negative. Oh no, it is not. I think it is negative only, right? Negative 135. Yeah. So you have negative 135.04. Sir, the value of eta or learning rate is universal, right? No. It is not universal. You can give it 0.1 also, 0.01 also, 0.001 also, 0.0001 also. I'm not sure anyone is foolish enough to take eta or learning rate in a very number like 100, 200. No, but usually it's mentioned like this. It's not universal, you change it. 13.35. So did we get the updated weight value also, my people? The bias one? Agree, disagree? I hope everybody got the logic behind the neural network. How you get the previous weight value. You first make the prediction, make the worst prediction, it does not matter. Whatever is the error, you go back and fix the error. Isn't this the process of learning in a neural network? I hope everybody got the logic behind what we were able to implement or what we are implementing in reality. The logic? Sir, how does a neural network understand that based on the error and mistakes I have made, I actually need to go back, fix that mistake, move forward, change it, then make the prediction again. Agreed? So tell. So far, I have only updated 2 weights and 1 bias value. Is the job done? Without anything. Guys, actually, my work isn't done. Why is it not done? Let me show you why it is not done. Think about it for a second and tell me if this makes sense to you. Okay? Tell me if this makes sense to you. If I copy and paste it here, I only did the mapping of ypred. Okay, my ypred value gives me the result of my cost function. So my cost function was responsible, or it was because it was dependent on ypred. My ypred was dependent on the weight value, which was W7 and W8, correct or not? And the bias 3. But tell me one thing, because they were dependent on this, wasn't there also a dependency on something called G1? And G1 was again dependent on weight 1, and weight 1 was again dependent on the input value. So can you see, I have to go all the way. Are you understanding? You just calculated the dependency of the cost function with respect to W7 and W8. But W7 and W8, or the answer G1 and G2, weren't they also responsible because they had a previous weight value assigned called W1 and W6 and W1, W3, W6 and 2, 4, 6, and they were in turn dependent on the value of the input layer? So tell me, in order to genuinely calculate the back propagation, you actually have to go all the way to your. I hope everybody got the logic that whenever you do back propagation goes all the way from the cost function all the way till the beginning. And whatever dependencies we have, we keep solving, updating, solving, updating, solving, updating towards the end of. Got the Did you guys get the logic? So tell me, listen to me carefully. Listen to me carefully. If I want to calculate del cost with respect to del W1, everyone, I want to calculate the dependency I have of my cost function, mapping it directly to del W1. Look at what is the relationship of my cost function with respect to del W1. So everybody listen to me carefully. Listen to me. Can I say that if you want to measure this relationship, first of all, cost is directly relational with del ypred. Everyone listen. Cost is related or is dependent on del ypred to get the answer. So cost answers are directly responsible or directly related to del ypred. Is this relationship? Then I can multiply and say that my del is related because it is responsible of G1. So can you tell me that my ypred is directly responsible with the value of G1? That agree, disagree? See, now we don't need to take W7 because we need to go all the way till W1, correct? If I want to go to W1, I can take beyond this. So ypred is because it is responsible with G1. Now tell me, what is G1 dependent on? G1 is dependent on the answer of Z1. Do you remember before summation we get an answer called Z1 where I have split the data into two? If you remember in forward propagation Z1 and Z2, my G1 is responsible on Z1 and my Z1 is responsible on W1. I am going even more detailed. So tell me, can I say it like this? Can I say that G1 was dependent and my Z1 is dependent on W1? Do you see how many mapping have we done? Cost is dependent on ypred, ypred is dependent on G1, G1 is dependent on Z1, and Z1 is dependent on W8. Can you see we went all the way back with whatever relationship we had? Now tell me one thing, if you replace and calculate the equations number every single time, can you get an updated value of del cost by del W1? And that del W1, you can calculate the updated value. I hope you guys understood the. So you had to go all the way back to map your cost function with W1, then W2, then W3, then W4, then W5, then B1, then B2, and guess what? You should be able to update your. You understood the logic that it takes a lot of time for neural network to calculate. Back propagation is the main reason why neural networks even have intelligence. Are you understanding what I'm trying to say? The knowledge of a neural network, the intelligence of a neural network is because of the algorithm called back propagation. Back propagation is also called as the algorithm of the year in 2020. 24, 25, it is called as the algorithm of the year because Backpropagation has made a lot of intelligence possible. So guys, did you understand the concept of backpropagation? What it does, how it does it, what's the logic behind it, how do we do a forward propagation, make some calculation, then go back and change my old weight values and bias values and then do forward propagation again. This time the error will definitely with the updated weight value and the updated bias value. This time after I do my forward propagation, my weight value or my error will be even lesser. So this is the reason deep learning models take a lot of time to learn. First, I want to address a topic which I left in the very beginning of the class. A lot of you asked me a question, sir, how many input nodes can I take? You guys already know the answer. The input node is always equal to the amount of features you have in the data. Now guys, when you take hidden layer 1, hidden layer 2, hidden layer 3 and hidden layer 4. Example, you've taken 4 layers. Hidden layer 1, hidden layer 2, hidden layer 3 and hidden layer 4. Guys, the word in the concept deep learning comes from the fact that if you take a larger hidden layer size, it's called a deep neural network. Are you understanding? The more hidden layers you take, the more deeper the network becomes, and that's why we call this deep learning. The word deep is directly proportional to the number of hidden layers. If you take one layer, it's not a deep neural network, it's a shallow. But the more hidden layers you take, the more deep or more deeper is the concept that you say that my model is. Are you understanding? Let me ask and answer this question to sir, can I take 4 hidden layer, 5 hidden layer, 6 hidden layer, 7 hidden layer, 8 hidden layer or 10 hidden layer? Which one is the best? Is have any series of mathematical polynomial formula for this? Like no. So first of all, correct money. G1 is passed to your Ypred is passed to cost. So going backward, cost is responsible because of Ypred is responsible because of G1 was Z1 with W1. Same thing will happen here. Cost with cost with respect to Ypred with respect to G2 with respect to Z2, and Z2 with respect to whichever function or value that you want to work on. So that particular weight value will be updated. So I hope you got the small question. Guys, imagine I'm asking you this question and you guys tell me if this makes sense or not, okay? And I want you all to please listen to me carefully in order for this particular thing to make sense. Z1 also depends on W3. Munna, you are only interested in calculating the effect it had on W1. So your mapping needs to go independently with respect to W1. Even if W3 and W5 are responsible for G2, we will come to that later. Meaning, first, my intention is to map del cost with del W1. So del cost should come to the numerator here and W1 to the denominator here. Mapping is correct. Sir, is there any benchmark like number of time we need to do back propagation for a specific minimum error rate? Kalpesh, that's a very good question. So what you do is you basically have something called epochs and batch sizes to make your life easy. But I'm going to come to those topics a little later. Like how many epochs do you want your model to run? Eventually your model becomes as optimized as it can for the given data. And after a while, the loss functions don't go down. The accuracy is not going up. So that becomes like the saturation point. So yes, you can give 100 epochs, 150 epochs, 200 epochs for your model to learn again and again and again and again and again. But yes, I'll tell you, Kalpesh, how exactly we have a stopping condition where the model can, oh, there is so many things, right? Like there is also something called stop loss. There is also another technique in deep learning where if the loss is not decreasing consistently, we stop it. We stop the epoch. Suppose if you've given 150 epochs and after only 10 epochs, the loss is not decreasing consistently after 10 iterations. then you can just stop. You know that the neural network is not going to learn. So I'm going to teach you all these concepts. Very, very important. Yes, Kalpesh, it exists. We have a value in deep learning or a concept in deep learning where you can make a very Okay. Everyone, I have a small question I want. Have you ever gone to shopping and your mom bargains, she buys the jacket for the most minimum price possible? If the jacket is worth 4,000 rupees, your mom will start bargaining with 500 rupees, correct? Because she wants the best possible value for, है ना? You stand in front of the shopkeeper completely embarrassed, wanting to run out of the shop, but you can't. When the owner of the shop says that the jacket is worth 4,000, your mom starts with 500. We spoke about this because we spoke about optimization with this example. When I example yesterday, I taught you with respect to the optimization factor. But listen to me. For that 4,000 rupees jacket, would you any day spend 7,000? Would that be called stupidity or foolish behavior? That something that's worth 4,000 rupees, why would you spend 7,000 to it? Agree, disagree? So humans do not want to overpay on something, correct? Over sort of pay on any value which or anything that does not have that value. Let me ask you a question. When you build a neural network, do you want to overly create your hidden layers? One hidden layer, two hidden layer, three hidden layer, four hidden layer, five hidden layer, six hidden layer, and then an output layer like that. Do you want to make a mistake of writing too many hidden? No. Do you want to make a mistake of writing too lesser? You want to find out a number which is just exact number, correct? A number that. Now tell me, my question to decide how many hidden layers and my architecture of my neural network, what should be? Let me ask you guys a question, and this will sort of give you an idea. Guys, have you seen a flow of a water in a pipeline? So suppose, imagine I have a water pipe that looks like this. My output nozzle is spread like this. What will happen to the water? The water will gush in current pressure, and will the water spread? Agree, disagree? Again, let me draw it down like this. Okay, let me draw it down like this. Imagine you have a pipe. Okay, and the water gushes out of this pipe in pressure. Okay, in pressure. Because of the shape of the pipe, the water will gush out in a very angled way, right? It would be spread. So can I say that the water is more spread? The input water, spread, and the output water spread is larger, right? My input to output water spreads are larger, correct? That's correct. Now imagine if I reverse the operation. If I have a pipe that looks like this, what about now if my water or my pipe is built like this? What would happen in this condition? The water would end up coming to this particular pipe, and because of a low restriction area, will it become constricted and go out with pressure? So my input spread is higher and my output spread is lesser. Agree, disagree? That if the water pressure or the flow of the water comes inside a pipe, the water sort of spreads out in an information or in a way where my input spread of the data versus the output spread of the data was completely different. But when I have an input, information or the flow, and I constrict the information is lesser. Take the same example, okay? Take the same particular example and tell me how you want to do it. Is that beard and bits? No, 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 no. That's not beard and bits. That's beard and binary. That's the channel, not beard and bits. I don't have anything called bits. Yeah, that is the one. That is the one. That is the one. It's called beard and binary, not beard and bits. However, I think that's a good name too, beard and bits, right? Because bits makes gender specific, is it? No, 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 no. Binary, zero. The 0 and 1 and the 0 and 0, right? Like that is there are two situations, situation number 1 and situation number 2. I have 3 nodes. You know what? 4 nodes. Let's take 3 nodes. Let's take 3 nodes. Node number 1, node number 2, and node number 3. Okay. And I will have another node called 1, 2, 3, 4, and 5. Now, guys, tell me this. What would your flow of information look like? Does it look like a pipe that is going like this? My inside information is lesser, but the output information is larger. My input information is lesser, but my output information is larger, meaning the information that comes in node 1, node 2, and node 3, can I say I am making the information flow that comes in node 1, node 2, node 3 is now being made to become larger, or my output variable or my output information is now larger? Yes or so am I expanding the information flow? The information flow that comes in with 3 nodes is expanded to 5 nodes. Now let me also explain it to you like this, right? Imagine, guys, you are the manufacturer of Coca-Cola. Okay. You guys know the secret recipe of making Coca-Cola. Now, because you know how to make Coca-Cola, initially only 3 people knew that information. How many people knew that information? 3. When the management changed the number of people, now how many? 4. Let me ask you a question. Has the information flow basically 3 people knew the information of how to make a Coca-Cola or how to make a beverage that is so rare, so good that you have to safeguard the information. And now 4 people know how to make it. But think of it like this, guys. Between these 3 people, 33% of how to make the Coke was known by one person, 33% by other person, and 33% by other person. So can I combine all of them together to make it 100? Can I say if I combine everything together, it becomes 100%, but the same 100% will be now divided by how many people? So first person will know only 25%, he will know 25%, he will know 25%, and he will know 25%. Agree? Now listen to me carefully and please tell me if this is logically making sense. In reality and in real life, not everyone is supposed to be equal. Now don't take me in a wrong way. Everyone is equal in life, but somebody is a CEO, somebody is an intern, right? Now we cannot make everybody CEO in the company, right? That is not possible, correct? We can't make everybody intern. So tell me one thing, is it not possible that when the information that you are passing in the beginning of the data was like this, first node handles 40% of the information, the second node handles 20, and the third node 30, or maybe this is 30, 4, 5, 6, 7, 8, 9, 10. Can I say it like this? 40% information is handled by node 1, 30% information is handled by node 2, and 30% by node 3. So when I split it into 4 nodes, can I say the first node is able to handle 50%, 60%, 80%, and 90 and 100%? Can I say? Did you get the idea? That when you expand your neural network connection that looks like this, the hidden information or the information that you got in the very beginning will now be built in such a way that you have of the spread of the data is now spread, but at the same time, the responsibilities have also changed. Agreed? The responsibilities have also changed. So give me 1 second. 1, 2, 3, and let's take this value, right? Then 3, and then there is 4. So are you understanding, my people? You have hidden layer 1 and hidden layer 2. When you take or choose to take a hidden layer 1 and hidden layer 2 in this value or in this variable, you are expanding or spreading the information from the input hidden layer 1 to the output hidden layer 2. You are choosing to spread the data. But reverse the condition. If you reverse the condition, so let me sort of reverse the condition like this. Give me 1 second. Let me take this particular variable. And how do I take this? And if I, okay, wait, control copy, control V. And if I reverse the operation, everybody look at me. And as in not look at me, look at the board. Let me erase this completely. Let me erase this, erase this, erase this. Guys, when the flow of the information passes through neural network, are you making sure that the information that was now handled by 4 nodes should be represented by 3 nodes? So guys, please, can I say this is a step of decompress and this is a step called compress? 3 people, too much load, decompress. Make it 4 people aware of the information. And here, the 4 people know the information, compress it to. Are you guys understanding the concept of hidden layers taken in multiple different form like this? Now tell me one thing. Can you not also take a neural network that looks, listen to again, copy and paste. Give me 1 second, paste. Can you see, you can even build a neural network with 4 hidden layers. And let me tell you the beauty of this, okay? Let me tell you the beauty of this. Let me erase this part completely. And let me move this part a little bit closer to my neural network. Guys, observe one thing very sort of crazy, but also very, very amazing. Okay, give me 1 second. Input. Or let me make one more reduced and let me erase this. Let me move this a little to here. Okay. And my green color combination ones would come to node and this. Then I want the orange one to also connect with every other layer. So layer 1 is connected. Then again node 2 is connected. Then we have the blue one, which is going to be, so blue's connected with this, blue's connected with this. And I think we have one more, which is called red. So I'm going to connect the red to red. Now guys, initially you took the data which was expressed in the format of, initially the data that you got was expanded into 3, or initially you had a value, it is 3. Then you expanded the information to 4. Then that 4 information you expanded into 2. Let me explain it to you in English so that the logic becomes a little bit further clear to you and you will start getting a little bit better idea. And let me explain it to you nicely. Guys, let's say your best friend is missing. Okay, your best of the best friend is missing from the house. He did not come to the house the whole night. The entire night your friend did not come to the house and your friend's family end up calling you. Now tell me, initially when your friend's family inform you about what happened, why did he not come, they also don't know too much information. So will the information they pass you will be less? We last saw him on 7:30 in the evening. He only ate food. So the information they will give you is going to be lesser and lesser. Again, the family members will tell you that we last saw him at 7:30 in the evening. He was speaking to some friend and we have spoken to a couple of people. He did not go there. But taking all this information, don't you need to take more information next? Who did he call? Where did he go? Can I have a CCTV footage of that area? Are you understanding? From the information you get, you need to extract even more granular level information. Now tell me, from that information that you extracted, don't you need to make a final decision? Go to the friend's A's house or go to friend's B's house? Because there are only 2 situations that can happen. So then you make the final decision, should I go to A's house or B's house? Because he must be sleeping there. Are you understanding? When you expand your neural network, you basically zoom into the data and try to get further detailed level analysis of the data. So expanding the nodes of the neural network means now you are trying to go more in further into the detailed analysis of what and who. Agree? I hope I am clear to everyone on what the logic and intentions of taking a neural network like this is. First, you take an information. More the nodes means more the features you are taking. Important details in the data that you're targeting. Coming back to 2 again means you're compressing the data into any one of the. Now the logic. Sir, is there a way or is there a mathematical formula to decide how many hidden layers to take? Actually, there are, but in my practical experience working in the industry for 12 plus years, let me tell you it's not. I'll give you an idea. Tell me one thing. To decide to build a neural network or to start building a neural network, first of all, what is the goal of the problem this understanding is? What is it that you want? What is it that you want to solve? Understanding that becomes. Agree, disagree? Tell me, would you just randomly start building a neural network just like that? Oh yeah, I got a project without understanding. Let me start building a neural network. I don't know. Crazy to do that? Or can we do it directly? Actually, no, we don't do that. The reason why we don't do that is because understanding the goal of the project is more important. With the goal, what business am I working in? Am I working in finance? Am I working in healthcare? Am I working in market research? Am I working in marketing? Is this the neural network or a deep learning case for marketing or sales? Does not matter what you are. Your goal and your business logic needs to be clear. So when I start building a neural network, I already know what my input layer looks like and what my output layer looks like. Agree? The idea that what will be my input, what will be my output will already be clear from the goal. Guys, the most simplest thing I'm telling you, start with minimum to minimum 2 hidden layers. Don't go beyond 2 hidden layer. Hidden layer 1 and hidden layer 2. Any one of the hidden layer compress the information and in other stage decompress the information, and try this model and see if you are getting the. Take one model, one node with a lesser information. How many numbers should I take? Take whatever. Depending on your input, my personal recommendation is, guys, whenever you take a node which when you are trying to sort of compress the information, suppose if you have a node of 8 input features, don't compress it more than 50. If it's 8, don't do 3, don't do 2, don't do 4. Try to keep it more than 50% or at least 50%. Don't go. Keep it to at least 4 or more. And then if you decompress it, also don't go double of this. So 8 to the 16, don't go beyond. If you keep your neural networks compression, decompression in this number, your neural networks end up doing the right answer. But sir, is there a mathematical way to calculate this? Yes, you can even mathematically calculate this. But we'll talk about it a little later in the portion of convolutional neural networks. I'll tell you how to do that. But did you guys get the idea? So basically, guys, this is more of a trial and error sort of a thing. The more deeper the neural network will be, the more better the knowledge is, the more better the understanding is. I'm going to explain this to you with an example. Okay. So let's say CNN. Okay. I have not yet teaching you the concept of CNN, but just giving you an idea. Okay. So first of all, imagine guys, you have a image of I don't know, a dog. No, I don't. I want something more detailed. Oh yeah, this is good. This is good. Okay. Let me teach you with example of. Okay, this also would be slightly complicated, but okay. Let me teach it to you like this. Wait, face. So let me just say image. Okay, let me copy this and let me paste it. Okay, guys, imagine you have an image of this person in front of You are building a neural network. Okay. First of all, guys, everybody get this idea, and this is a very critical idea for your generative AI use cases or your convolutional neural use cases or for your general understanding. See, guys, hidden layers, they all represent the information about the data. So suppose hidden layer 1, hidden layer 2 and hidden layer 3. See guys, hidden layer 1 is only going to get a basic idea, like in this particular image, the image has an edge like this. This is the edge, this is the shoulder edge, this is the edge of the face, there is also edge. So tell me one thing, is understanding the edge of the data very complicated? Is it a very complicated information? No. So the first hidden layer will understand something called as edges in the data. So can you see here? Nose also has an edge. Eye also, an eyebrow has an edge. The lips has an edge, right? Your face has an edge. So first layer will always try to understand the edge of the face or the edge, very basic level information. But when you go to second layer, you know what? It starts understanding even more complicated relationships, like this is what a ear looks like. This is what an eyebrow looks like. This is what an eye look like. This is what a nose looks like. This is what lips look like. So tell me, when you went to hidden layer 2, important features or features that are even more complicated, they started to show up in the your understanding of the image of a user became even more clear. By the time you reach to the third hidden layer, your third hidden layer will already start making relationships, meaning eyes and eyebrows come together. Nose will always come with eyes. Ears will always be opposite with each other. Nose and mouth come together. Are you understanding what I'm trying to say? So the more hidden layers you take, the more detailed your idea about the data becomes. Are you understanding? This is why deeper the neural network, more is the knowledgeable or more is the knowledge of the network. But the problem is, the more deeper you go, the more hard it becomes. No, 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 no. Please don't say that more is the accuracy. This is not the right way. It's not the accuracy that increases, Sonali, directly. It's just that the representation becomes better. Accuracy can always be found out in my model also, but the represent changes. The concept is tricky, but I will explain, Sonali, how that. Okay? Deeper the neural network, more complex the neural network. Are you understanding? So my question to every single person in this class is, don't you balance things in life? We need to balance things in life, right? People who are very, very rich don't care about how much money they spend in a day. People who are not that rich cannot spend or cannot afford to spend. And then there are people. Imagine if you work in a company like, do you care about the GPU cost? How much will the GPU cost will be? How much will it take for my training the model? And no, they care. I was in Microsoft for some time. We never cared, right? Like we never cared about. Microsoft people don't care if you want to train your neural network and if you want to take like A100 GPUs, they are like take 100 A100 GPUs. We don't care. But let's say you're a startup company. Do you now care if you want to train a neural network? Can you spend 15 lakh rupees bill? So remember, in deep learning or while working with AI, you gotta balance your price at the same time your knowledge. What I'm saying is basically, when you decide to make a neural network, please keep in mind what will be the time it takes to train the model and the money or the resources it will train the neural network, the model. And then you have to come up with the most optimized approach to handle this particular thing. The more money you spend, the better your neural network becomes, no doubt about it. But the deeper or the bigger your neural network becomes, it would be that complicated and that hard to train that particular neural network. Are we understanding? Are you guys getting what I'm trying? So please keep this in mind and understand this. So tell me guys, did you guys understand the logic and the architecture of how a neural network is written? You have an input layer. Okay, in my neural network right here, You have an input layer, you have a hidden layer, and you have, that's great. Is it okay if I teach you how the programming works of this particular, whatever maths that you have written? Okay. Do we control the number of hidden layers, or does TensorFlow and Keras figure it out? No, 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 Mike. We control it, my dear. Mike, we are the one who control how many hidden layers that I want to create, how many nodes in my hidden layer, and how many hidden layers sizes will be there. So we control it. It's not TensorFlow that controls it. We have the control over it. We are not supposed to make it complex yet get the outcome with accuracy. The idea is to keep the hidden layer and nodes limited and focused. You're right. The intentions are to come up with the architecture as best as possible that consumes less memory, less time, but is giving me the best possible output. Are we understanding? Okay, less money, less time, and get the best possible output. My idea is, if you have 50,000 rupees spent, I can take iPhone also. I can take Samsung. No, I think iPhone. I'm not sure if you can take an iPhone, but yeah, I mean, you can take a Samsung phone, or you can take a Huawei phone. You can take, I don't know, Redmi phone. But if you want to buy an iPhone, you have to increase the cost. Are you understanding? If you want to build something that the world has never seen, then you have to. So it works like that. Older model of iPhone. Oh yeah. So until here, did everybody get the logic? I am assuming nobody is confused. Is any external auto control system to balance the connection network of nodes? No, 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 no. It's all internal shift. You don't have anything external to control that. You always have internal logic, internal epochs, internal batching, internal optimization, internal sort of flow of information that contrasts, that sort of keep the topic, that keeps the topic on one single. Absolutely. For a neural network, the training data is the most important thing, because tell me one thing, if my training data is available in the model, or if the training data is available, I train my neural network on the training data. Whatever my neural network has learned, all the weights and bias values that have changed will now be used to test the data. I will be able to test my model, and I will be able to get the idea clear. Okay. So please remember, guys, in the beginning of the class, I told you this very important thing. In my neural network, you have an input layer, you have a hidden layer, and output layer. Every single portion of this particular architecture you can control. What activation function to choose, you can control. How many input layers will be there, you can control. What would be the output, you can control. How many hidden layers there will be, you can control. How many nodes in the hidden layer, you can control. How many, can I make my hidden layer deeper, you can control. So every single aspect of your network you can control. But every single person in this class, because we have advantages and disadvantages to everything, do you guys think there is a disadvantage of using this particular, do you think there is a disadvantage of using a neural network like a feed-forward neural network? The answer is yes. There is a very big disadvantage or a problem to use feed-forward neural network. And the disadvantage is it is very time consuming and memory consuming, or a memory intensive process. The time it takes to train a normal feed-forward neural, and the time it takes, or the memory it takes, is so humongous, so large, that it literally makes people think whether to use this kind of network on a production or a practical data set or not. But still, in the industry, we use it. I'm just showing you that there are advantages, no doubt. So now, my people, since we have a better understanding of this, can we do one thing? Can I teach you the math behind the machine? Since we've learned the concept or the math behind the neural network, what it does, can we create our own data and we code the solution, we program the solution all by ourselves? Meaning, We take the data set of hours of coffee, cups of coffee, something like that, and we basically print and return the result of how we actually get the answer. Today, I'm actually going to show you how a neural network is written. How do you even start creating a neural network by yourself? And at the same time, how do you make sure that the neural network that you've written the exact same way that you should do, or what it's recommended to do? Okay. But before I teach you the concept of neural network in the beginning, I have a small concept that I want to teach you, and it is an absolutely amazing topic, but also very, very critical topic. And the topic is called activation function. Okay. Activation function. Activation function. Now, guys, I gave you guys a very simple definition in the beginning of the class that a neural network is like this glorified calculator, right? All it does is calculate, 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 calculate. I want you to understand one thing right now through this class, that a neural network is nothing great. Okay, I want you to understand one thing. In machine learning, the reason why AI has become so predominant right now is because AI can understand the pattern within the data. Humans are also exceptionally talented at understanding pattern. The problem with human beings is we cannot do this at scale. Meaning, if you give me a 1 terabyte of data, I might require 12 human beings, incredibly talented 12 human beings, 1 month of time to understand what this data is trying to say. It's not that humans are not capable of doing things. I think we are capable much better than neural networks. But the problem is we are not scalable. What a neural network does right now is, example, if I have two variables, okay, one variable is called age and the other variable is called income, example. Now, of course, guys, in a very simple, in a very, how do I say this? In a very perfect world, my data would look something like this, right? Like as the age grows, the income also grows. So suppose if your age is becoming, sort of as in when you grow old, your income also goes. So do you see there is a kind of a linear relationship between age? As the age grows, the income is growing. Common sense. It's a very simple fact that I'm explaining, but in real life, it doesn't work like this, right? In real life, your age could be higher, but that doesn't mean you're making equal amount of money. It depends on your domain, your business, your education, your background, many things. So let's for simplicity say that my data kind of looks weird like this. Okay, let me put it down in the red circle. Give me 1 second. Red circle, red circle, red circle. And imagine my data kind of looks a little sort of, very wavy and curvy. Example, just to give you an example, please don't consider this to be a real life example. Okay. Now, guys, tell me one thing. In order to make predictions in the future, and whatever I'm teaching you right now, I want every single person to please pay your 100% attention right now, because if you don't understand what I'm teaching you right now, it's all gonna be a waste and a moot point. Okay, give me 1 second. Let me expand this. Now, guys, if I want to predict, suppose this is the data point. Okay, suppose I have a data point. Okay, so let me just write it down here: age and income, and this variable is income, right? This is my x-axis, this is my y-axis. My age is, suppose, so nobody is zero age, but just for simplicity reasons, let's write down the data like this. I am a 10-year-old guy, 20-year-old guy, 30-year-old guy, 40-year-old guy, 50, 60, 70, and 80, right? So let's just say that we live up to 80. I think that's also very hard nowadays based on the habits that we have developed. But yeah, let's say the maximum we live is by 80. So if my age is 62, example, what income is the prediction, or what is the possible predicted income based on the data? So for example, if my age is 50, so what income would I make? So what happens is a neural network is able to map your data and get the understanding of the pattern. So basically you will be able to plot something on the x-axis and you now get the value of y. So depending on the age 50, depending on the pattern of the data, you now will be able to predict what value of y you could get, right? So what I want you to understand is a neural network understands this relationship between two variables, four variables, 1800 variables does not matter, right? The intention is you want to understand the pattern within the data. But the bigger problem that you will be dealing with is a neural network is completely linear in nature. Yesterday, the last class, I taught you that whenever you have an input layer, you have a hidden layer and you have an output layer. From node 1, I'm just going to call it N1, N2 and N3, node 1, node 2, node 3, H1 and H2, hidden layer 1. To pass the information from the input layer to hidden layer, you need to make a connection. And this connection will have some importance factor. Let's call this importance factor weight 1. Okay, let me make the example even more fun. Give me 1 second. Let's just try to take it from a very mathematical yet very fun example, right? Imagine I have Pallavi in our class. Okay, Pallavi from our class, Dilip from our class, okay, and who do we take? Uma from our class, okay. So Pallavi, Dilip and Uma, they pass information to Kalpesh and Sakshi. Kalpesh and Sakshi. Now, Pallavi's equation with Kalpesh, how do I say this? If I would rank Pallavi and Kalpesh between 0 to 10 on friendship, Pallavi will say that my relationship with Kalpesh on friendship level, but Pallavi's relationship with Sakshi is pretty much 9. So tell me this, Pallavi is basically trying to tell how important her relationship with Kalpesh and Sakshi is. Agreed? Am I making sense? Right? So this weight value in mathematical term, we call this the weight value. Weight value basically says how much importance Pallavi's information would be for Kalpesh versus what Pallavi will inform Kalpesh more or Sakshi more. So imagine Pallavi knows that let's say Pallavi knows that melody is chocolatey. Okay, Pallavi has the information that melody is a very chocolatey, right? Now, if Pallavi wants to transfer this information to Kalpesh, Pallavi will only transfer 20% of the information to Kalpesh, but 90%. Just like that, Dilip also will have an equation with Kalpesh. So Dilip's equation with Kalpesh will be different. Dilip's equation with Sakshi will be different. Uma's equation with Kalpesh will be different. And Uma's equation with Sakshi will be different. But tell me one thing. Kalpesh and Sakshi both, they got information from 3 different sources, right? Source 1, source 2 and source. How much ever the equation of Pallavi, Dilip and Uma was with Kalpesh, we'll not talk about that. But at the end of the day, Kalpesh got information from 3 sources and Sakshi got information from 3 sources. So Kalpesh will be able to build a better story and also Sakshi will be able to build a better story because they have received different kind of information from people. So tell me one thing, if mathematically, if I write this, suppose if instead of Pallavi, instead of Dilip, and instead of Uma, if I write down the information that suppose node number 1 is a number called 10, 20 and 15 and the weight value is 2 and 9, example. If I remove all of these, just teach you the math behind this too, right? You already know that the logic is number 10 will be multiplied with its weight plus whatever bias it is available at Kalpesh end plus bias. So tell me, doesn't this look like the equation y is equal to mx plus c, which is a linear equation? Now tell me one thing, if my data itself is non-linear and my neural network is doing linear calculation, will I be able to fit a non-linear data? The answer is no, you will not be able to do that. So why do we use activation function? To introduce non-linearity in the neural network. In simple plain English, some flexibility in the neural network. We learn the concept of activation. Okay, that's great. So guys, let me explain and teach you guys a little thing awesome. Let me explain and let me teach you guys a little important topic. Sir, this is non-linear. Feed forward neural network is always non-linear if activation function is. I understand. If activation function is not used, that neural network will not be able to fit any non-linear data. It will not do it. It's simply not capable of doing it. To make sure your neural network understands the data, the pattern, the shape, if it is non-linear, you have to apply activation. Great. Okay. Now, sir, what kind of activation functions exist in my machine learning journey, and what do they mean, or what is the intentions behind them, or what do they mean by that? Okay. First of all, guys, I am going to import NumPy as NP. This is like the most important package that you guys need in your career. In an interview, whether you know the answer, does not know the answer, write this down in the first. So first of all, I am going to talk about one of the activation function called sigmoid activation function. Sir, how does a sigmoid activation function look like? Return 1 divided by 1 plus np dot exp e to the power of minus n. This is a simple activation function that I've written. Nothing will be missed. Np dot linear space. Let's take -10 to 10 split into 100 different splits, and plot dot. Okay, I need to import matplotlib also. So import matplotlib dot plot as plt. Okay, let me run this, and plt dot figure. Let me maintain every single figure separately, and figure size would be equal to, let's take a 6 cross 6. I think this should be easy, or this should be enough. Now plot dot subplots, and inside the subplots, let me take a, actually, yeah, let me take multiple canvases. I will fill the canvases later. So 2 comma 2 comma 1, right? So this would be, yeah, 2 comma 2 comma 1, and I will say plot dot plot a simple linear line where I'm taking x comma sigmoid of the value of x, linear space and non-linear space, right? Okay, so let me say plot dot title, and inside this specific title, let me say sigmoid activation function, and let's also make a grid to this, and let's keep the grid very light. So let's say alpha is equal to 0. Please tell me what mistakes did I do. Subplot, I am sorry, it's not the indexing plot, it's a simple non-indexed plot, right? Is every single person able to see what I have shown you in this particular graph or this diagram with the title called sigmoid activation function? Okay, that's great. So first of all, let me copy paste this graph and let me show you something awesome. See guys, in mathematics, okay, you guys have to understand one thing: there is always a way to do crazy things. Some really crazy things, if you want to do, you can do it. What I want you to understand whenever you see a graph from today onwards is what is the y-axis triangle. Guys, no matter how big the graph is, will the graph always be restricted between 0 and 1? Please observe. No matter what value of x you give, will the x value always be between 0 and 1? See, no matter what value of x I am giving, I am always getting the answer of y between 0 and 1. So can I say, if I want to compress something between 0 and 1, sigmoid is a very great option? Agree, disagree? Right? In machine learning, my understanding is every single person in this class has learned something called logistic regression. Correct? In logistic regression, you have pretty much used the equation phi of z is equal to 1 by 1 plus e to the power of minus z. That's great. Sir, how do we decide how many degrees? So shift, that is decided by the neural network itself. We don't decide it. The network decides the network decides what kind of turn, twist, movement my neural network has to make. And this all is done by backpropagation. Okay, we don't decide it, the neural network decides it. That is the job of neural network, to take care of it by itself. Okay, we don't tell how much degree of curvature should you move to accommodate. Okay, every single person has understood this equation called 1 by 1 plus e to the power of minus x or minus z. The reason we use this equation is because when we use binary classification, my labels are either 1 or my label is either 0. If I want my output to be at either 1 or either 0, then you will use something called sigmoid activation function. So in activation function, we compress our input to 0 and 1. So Jagdish, you have to be very careful when I say certain things. In sigmoid activation function, it compresses the input between 0 and 1. Not necessary. Every activation functions, to me very carefully. Not all activation functions will compress the number between 0 and 1. Only sigmoid activation function compresses between 0. I'm a big foodie. So, when you see multiple different sections of chocolates, you go crazy. Arey, which one do I select? But again, there are so many about all of them. But is everyone clear that if you use sigmoid activation function, it will be able to compress the number between 0 and 1, and it will also introduce non-linearity in your neural network. Correct? That's great. Okay. Now, after sigmoid activation function, sir, what other activation functions are very, very important and we use them? The other one is called ReLU. ReLU is rectified linear unit. Okay, rectified linear unit. What do you mean by rectified linear unit? Very simply, you will understand the concept if I draw the diagram in front of you. Return np.max inside a variable between 0 and x. So basically, you will understand when I plot the graph. So what do? I pretty much take the same graph and I plot it in the bottom. Now I want this graph to show up on index 2, which is the topic that I wanted to teach you, is one more activation function called ReLU. It's called rectified linear unit. But guys, let me explain something. Am I compressing the number between 0 and 1 now in this activation function? No. ReLU allows or works like a filter. What filter? Suppose -1 is trying to imagine, guys, you have this big amazing fort. Okay, this fort and this castle that you built for your princess or your queen, and multiple different people are trying to attack the fort. -1 is trying to attack the fort, 4 is trying to attack the fort, 100 is trying to attack the fort, and negative 156.96 is trying to attack. Anything which is a negative number will not be able to enter the fort at all. Anything which is greater than 0 or anything which is a positive number will be able to access the fort because they are friend. But whoever is a negative number is an enemy because you're a negative person. So no negativity allowed. So what happens in ReLU? In ReLU activation function, if you have couple of numbers, but I only want to filter out positive numbers, should you use ReLU activation function? Yes or no? You should use ReLU activation function only and only if you want to remove negativity from your life, negativity from a neural network. Any negative number that shows up or it is given to my neural network, that number will not be considered. Only positive numbers. Are we understanding this from this particular? So tell me one thing. Sir, how is ReLU activation function bringing non-linearity to my data? Why are you calling this activation function? What does it do? Let me ask you guys a question. If you have a data that looks like this, and I want every single person to please listen to me carefully because I have the habit of giving you guys some very deeper insights in a very simple analogy. Apologies. 1, 2, 3, 4, 5, 6. Does it look like a okay? If I randomly remove, it was a beautiful, But when I removed couple of points, now there has no relationship. So tell me, when a data passes through ReLU, right? It passes through the filter of ReLU, the very well looking behaved data now just looks like a set of random points, right? Because some of the negative points, correct? Something that was looking very perfect now got filtered out and looks like they are just set of random points. This is how ReLU introduces nonlinearity. Something that was very well behaved in the beginning, all the negative points are gone, all the negative information is gone. Now it looks like a certain set of points. That is how nonlinearity is introduced. Are you understanding, guys? Are you getting the idea, the concept behind it? Yeah, that's how you're supposed to remember it. Okay. Now, sir, after ReLU, what other activation functions there are? There are many, like I said. After ReLU, there is also something called Leaky ReLU, Leaky ReLU. Okay. Sir, what if you had a lot of negative data points? Won't ReLU drop them all? Yes. And that is one of the reasons it is used, Mike. So the intentions, Mike, of using ReLU is anything that is negative, I don't, right? So let's say you have a tool called spanner. Okay. You have a spanner. This is also a spanner. This is also a spanner. We also call this monkey wrench. Won't you use this spanner for a different use case, this spanner for a different use case? Let me also show you something called belt wrench. Give me 1 second. Okay. So, okay. This is called as a monkey wrench. This is called as a belt wrench. My question and my analogy is very simple. There are multiple different activation functions, like there are multiple different tools. But can every single tool be used for a different kind of specific? I hope the analogy is clear. Now let me tell you a very practical example. If you want only positive results to show up in the data, only the results where the weight values or bias values or any kind of information, only if it has any positive influence, only that should be passed. Any negative influence should not be passed. Is ReLU a good option if that is the eventually, when I'm teaching you the entire deep learning class, won't you get the idea when I'm going to be teaching you a practical example how ReLU is going to see right now, today, at this instance, I'm teaching you the topic of correct. Once you guys learn how to build a neural network, I'll also teach you how ReLU is applied practically in the real world scenario. But for now, I don't want you to focus too much in the future. Don't go too much in the future today. For today, understand what the tool is. How to use it will come to that a little later. But are we clear with the concept that how many different kind of everybody got the concept? So tell me one thing, sir, when will we apply ReLU? When will we apply Leaky ReLU? I'll tell you all of that. Don't worry. But for now, focus on what the data looks like, what the activation function looks like. Okay, x comma alpha is equal to 0.5. Return np dot where, okay, just the where condition when x is greater than 0 for the value of x, where alpha will be multiplied, alpha alpha should be multiplied with the variable x. Now what am I going to do? Give me 1 second. I'm going to copy this. I'm going to paste this in the bottom and I'm going to take this 2 comma 3. Instead of ReLU, I'm going to take a Leaky ReLU and Leaky Leaky ReLU, and let's make the answer right. Okay. So let me make this 0.1. Guys, please tell me, and since so many of you very brilliantly raised the point that, sir, won't removing negative values from my neural network a very bad option? Well, guess what? Sometimes it does become a bad option. So tell me one thing, can I pass a provision that allow negative values but only in a specific range? Can you see, my people? This is completely strict. Anything which is beyond 0 is allowed. But in Leaky ReLU, can you see that I am okay allowing some negative values, but they should be only in a certain range, like -2 to positive infinity, -3 to positive infinity, -4 to positive infinity. I don't want -10, -100, -800. No, no, no. I will allow some negative values, but majorly they should be positive. Agree, disagree? Now, can you seal this Angle, my people, everybody, can you see this certain angle, this tilt in the bottom variable part? You can change that angle using this parameter called alpha. So if I make this alpha 0.7, do you see the tilt has become even? Meaning I am taking the range from negative 7.5 to anything which, agree, disagree? If I am taking this alpha as 0.2, am I taking more? No, I am only allowing negative 2 to the positive infinity. So guys, what Leaky ReLU does is it is soft. It is not hard. Hard means no means no. No negative values allowed. ReLU is very strict with its operation, but Leaky ReLU is not strict. It will allow some negative values to come in so that my data has more plausibility, more accessibility to some negative values that I will be able to take. But again, those negative values should not go beyond the negative range also. I will be okay taking from -2 to positive infinity, but if you are -2 point anything beyond 2, I will not take you. I can't tell you that how many different versions of ReLU exist. There is ReLU, Leaky ReLU, PreLU. There is also something called DReLU. There are so many different kind of ReLU itself, right? Apart from this, one of the most important activation function that you should never forget, I would call this activation function as the how do I say this? The Salman Khan of activation functions, right? It's very famous. Which activation function is called Tanh? Sir, why is this very important? From transfers to long short-term memory models to UNets to multiple different kind of neural networks, they cannot function without this activation function called Tanh. And all it does is returns, okay, returns np.tanh, okay. And inside this, I'm going to pass the variable x, okay. This is related to ReLU. No, Tanh is not related to ReLU. It's completely different. Let me explain. Let me copy this. Let me paste this and let me call this 4. And let's call this Leaky ReLU as, and let's also call it Tanh activation. I don't need, okay. Are you guys able to see the Tanh activation function? Sort of looks like sigmoid activation only, but the difference is, can you see the range in the, it goes from -1 to positive. It does not go from 0 to 1, but it accommodates between -1 to 0, 1. Are we getting the concept? Are you getting the idea, everybody? What is it that I have taken one more activation function, which is going to be critical, and you guys slowly and become better and better. It has a sharper slope. Does the slope matter of Tanh? You can change the slope. If you asked a question, everyone to understand one thing right now, okay? Okay, let me show you a small game that I have built for logistic regression. Do you guys, okay, please listen to me for 2 seconds. Your idea will become very clear. Every single person in this class is aware that we use something called logistic function or sigmoid activation or a sigmoid function to set or to fit the value in the. Can you see I am moving my activation function or my sigmoid curve and I'm able to manipulate it? Am I able to see? I want all of you to observe at the classification error, right? The error. Your intention and your goal as a data scientist is to have the least amount of error. Your intention is to have the least amount of error. Look at this. Increased, decreasing, 1.07, 1.05, 1.03, 1.03, almost 1.03, 1.04, 1.03. If this sigmoid activation function is able to give me the lowest possible value, I'll also change the, let me try to change the bias a little bit, increasing, further decreasing. So are you able to see that on a bias of -10 and a weight of 4.2.0, this sigmoid activation function is able to give me the best possible output for. So tell me, did I not just show you that you can manipulate, that the S curve is not determined or it is solid? You can't change it. You can manipulate it, guys. That's the beauty of. That's the beauty. You can change this graph. You can manipulate it, and that is exactly what your neural network. I hope you're understanding. What Mike asked me, sir, looks like the slope is very steep here. Of course, the slope is steep here. You have to go from 1 to -1, but that does not mean you cannot change the shape. You can not change the shape, you can play with it, you can manipulate it. So, guys, as promised, let me show you some real life examples of a feed forward network. Imagine, guys, I have taken this variable called await. I have another variable called cups of coffee. Cups of coffee. I have another variable called travel, and my target variable out of all of this is the productivity score, correct? Are we clear? This is how I am going to be able to relate with my data. I'm going to be, okay, that's great. So guys, because I don't have a data of my own, right? For hours of sleep, cups of coffee, productivity score, I currently don't have any data of my own. So what I'm going to do, my people, I'm going to show you how to generate your own synthetic data, meaning your own fake data, to try the model on, just to get a hands-on how a neural network works. Then we'll take a couple of examples and then we'll try to solve how a neural network works on other data, right? So first of all, I'm going to import pandas as PD, right? This is one of the most important libraries that I'm going to. Now what I'm going to do, my people, how many number of samples do I want to generate? Can I say 1,000 samples? I want to generate 1,000 samples and only 1,000 samples. I'm going to say np.random.rand, random, number of samples, comma 3, multiplied by np. And inside this, I'm going to write 24, 10, 60. Now you guys will be like, all right, what does this code do? Let me ask you a question. My feature set is hours of sleep, cups of coffee, and travel time. How many columns are? 3. So can you see here? I have taken number of samples, comma 3. I'm telling NumPy that create 3 columns for me. The hours of sleep will be a number between 0 to 24. Agree, disagree? Because we have only 24 hours. So I want my NumPy to do a pointwise multiplication so that the random numbers will range between 0 to 20. Now tell me, how many cups of coffee do you think you can drink at a max? Can I say up to 10? I mean, more than 10, you must be, I think, crazy. But am I saying that randomly generate data between 0 and 10? And the number of travel time will be between 0 to 60 minutes. Agree, disagree? So it will randomly generate that data for me for hours of sleep, cup of coffee, and travel time. But for y, I don't need to do this. Why? Because y value is a random number between 0 to 100. So np.random.rand, number of samples, I will just multiply with this with 100. All I am doing is just creating random numbers between 0 to 100. This is just for the creation of my data. But the problem is, whenever you deal with random numbers, every time I run the program, it will give me, every single time, the program will give me weird random numbers, right? Random numbers also won't be very solid. Random numbers will be different every single time. To make sure the random numbers are generated once, but they don't change again and again, we have to use something called np.random.seed, and I will take the seed value to. I'll give you guys a practical example. Tell me this, np.random.rand, okay? And let me just say number of samples are 2, 1, okay? And if I run this, Can you see I'm getting a random number called 0.645 and 0.519? If I run the program again, is it? If I run this again, did it change again? If I run this again, did it change again? Again, this keeps changing. If I want the random number to be generated once, but don't change it again and again, what you do, take some random seed value and put whatever number you want to put here, but the number should be positive. Remember, negative seed values are not accepted. Anything 2 to the power of 31, 2 to the power of 31 is allowed. So how do I take power of 31? Because you are a actually 32, right? Because it's a 32-bit machine. So if I run this now, do you see I have a random number generated? But if I run this program again, is my random number changing? Look, no. I have generated the random number once and I have fixed them forever. Are we clear? Why do we use np dot? Perfect, that's good. So now that my data is generated, I have made my data work. What will I do? I will take pd.dataframe. Inside this, I will pass the value x, and the columns that I will pass will look something like this. First will be hours of sleep. Let me copy this. Let me paste it here. Copy, comma. Okay. So copy this, paste it here. Travel time, copy, paste it here. So what did I do here, everyone? I have taken pd.dataframe. My randomly generated data. I had 18 hours of sleep, 0.2 cups of coffee, 4 cups of coffee, 7 cups of coffee, 6 cups of coffee, and 5 cups of coffee. If you want to convert this into integer, feel free to do that. I'm going to take the same data that I've taken. I'm not going to change it. I'm going to keep it as it is, right? So right now I have generated this data and it looks like this. So, sir, how do I start implementing my neural network? First of all, guys, to write a neural network, you need to use a framework called TensorFlow. So what I'm going to do from TensorFlow, or you know what, import, let me not teach it to you like this actually. Okay, let's take it step by step. Let's not go beyond this. Let's do it one by one. Sir, I want to create my neural network. So create underscore custom custom model. Now listen to me carefully. Guys, to define any neural network from today onwards till the time you leave your job in neural networks or deep learning, remember one thing. You need to first declare your input layer, you need to define your hidden layer, and you need to also define your output layer, correct? This is how a neural network is defined. You split the neural network into input layer, hidden layer, and output layer. Sir, how do I declare an input layer? Use any variable you want. I'm going to say inputs equals to. Now, in order to create a neural network, we are going to be using a package or a module called Keras. Okay. So what will I do? From TensorFlow, I'm going to import something called Keras. To declare or to create my input layer, you need to say Keras dot with the capital I call input. Can you see here? Keras dot input. Now my question is, what will be the input size of the node? What is the input size of the node? Shape equals to inside the bracket 3 comma. Did you just tell the TensorFlow model, can you please create an input layer for me? I have already told you this is my input layer, and what will be the shape? How many values will I accept in the neural network at once? Only 3. Hours of sleep, cups of coffee, and travel time. Is the input layer clear? Is the input layer clear? So I just told my neural network, hey, please create the first layer and the first layer will have 3 nodes. How many nodes did I take in the model? 3. Did I declare it here? I did. After the first layer, which is the input layer, what do you need to declare next? The hidden layer. Correct? Take some variable x equals to. Now my people, what you need to do to write hidden layers, you need to import one more package, one more module from tensor dot Keras import something called layers. Are we done? Whenever you need to import any layer, you have to import something called layers. From TensorFlow.Keras, I have imported layers. I come to the bottom. What do I do? X will be equal to layers dot. You're telling the neural network that, hey, I am creating a layer, which is a hidden layer, and I want that layer to be dense. Whenever you say topic a little later, okay, I'm saying dense. How many nodes do I want in my input layer? 2, 1 and 2. One layer, but 2 nodes. So what will you say? 2. You guys know that when I taught you this program, what activation function did I take to show you the exact same code? Have I taken the activation function as a sigmoid activation function here? When I taught you the program, the activation function taken here specifically was sigmoid. So what will you say? Activation will be equal to sigmoid. Agreed with me? Now tell me guys, I have taken my input layer, I have taken my hidden layer, but did I connect them? Did I make the connection? Is the connection touched? Is there a point of contact? Not yet. How do you connect them? Take a bracket and pass. Can you see here? The variable or the variable name that I took for my input layer was called inputs, and I have just passed it in inputs. Now did I connect them together? Yes, it is connected. Sir, what do you mean by dense? Sir, what do you mean by dense? What does dense mean is you are now connecting each node to each other node. So 1 and 2 is connected. This and this is connected. And this is connected. Are we clear? Now you have completed your layer 1 and your layer. But here we only have, in the example of the neural network that I taught you, how many hidden layers have I taken, my dear? 1. So am I teaching you the exact example of what I took you to? Can you take 500 hidden layers? You can, my dear, you can. But I'm sticking to the examples that I taught you. Okay. So we'll stick. Okay. If we have 10 hidden layers, here we apply activation on each hidden layer. How that is done. Don't worry. They will be completely made independent. You don't have to define it. It will be randomly defined. A lot to do. Now I will create something called output layer. Now tell me one thing. I will take one more variable called outputs. So outputs equal to, because output is also a layer, so will I call layers also is a dense connection, right? Hidden layer and output layer also need to connect with each other, no? Fully connected, no, which is dense. So did I call dense? Okay. In my output layer, what will be the number of node that I want? 1. So what will I write here? 1 comma. What is the activation function? My question to you all is this. Isn't my output regression based output? Any number of productivity between 0 and 100 could be gotten. So I can't use sigmoid. No, I cannot use sigmoid because sigmoid will give me between 0 and 1. I want between 0 and 100. So very simply write down linear. Tell me, did I connect my hidden layer with my output layer? No. How do I do that? Put a bracket, pass x, no problem. Linear means my output will be regression based output. I'll also show you what does in this, don't worry. But sir, we have not declared number of layers in code. We have only declared number of nodes. My dear, when you say layers, it means layers. You have just declared layers by calling this particular thing called. Are you You just called layers, which means it is. If you want more than 2 layers, then you have to wait thoda patiently. Will come to how to declare 500 layers also, don't worry. But since, like I said, I'm showing you the exact same example which I taught you to teach the math, I'm sticking to that particular program. Of course, I will take your knowledge to a level where you will be able to do much more than this. But this is just your first class. Okay. So, thoda patience will take you a little far. If you want to use more than 2, 3 hidden layers, how will we write? So, Sapna, like I said the same here, 100% correct. If it is a regression based output, and the range is unknown, or you know the range, it can go beyond 0 to 100, 0 to 1000, 0 to 10,000. Remember, always up. Linear is going to give you what a regression does. Okay, great. Now, can I say my neural network is complete? Ask me. Let me ask you guys a question. So, can you just summarize what you've done in this function? Okay, so here is the thing. Let me first address the first question. Sir, can we use min-max scalar to get all the output done? Let me ask you. In machine learning, you have to do feature engineering all by yourself, right? Feature scaling, feature engineering, feature extraction, all of this. But in deep learning, do you do any of? My question is very simple. I'm not asking a complicated question. In machine learning, you had to do normalization also, standardization also, recursive feature elimination also, covariance, not covariance, sort of correlation testing also. All of this you had to do. But in deep learning, which is the neural network, is that an important? The answer is no. The answer is no. So tell me one thing. When you implement deep learning, sir, can I use min-max scaler, normalizer, standardizer? If I don't use it, what will happen? Nothing will happen. Your answer will be still the right answer. But sir, should I do it? The answer is because doesn't it save neural network a lot of unnecessary processing? Am I making sense? I'm giving you a very practical idea. Sir, should you do it? If I don't do it, will it work? 100% work. But if I do it, will it be better? 100%. Okay. So coming to the point, can we use min-max scaler? We can. But tell me one thing. Are the ranges too, ask me this question. Are the ranges too different? Meaning one range is between 0 to 10, other between 0 to 100 and the other between 0 to 10,000? No. Mostly, probably they are all in the same range. So you don't need a min-max scaler or a standard scaler in this. You don't need it. But can we do this? But good question. Sir, can you just I took the input variable or my input layer. I took my hidden layer and I have taken my output layer. I made sure I connect the input layer with I made sure that my input layer is connected, my hidden layer is connected to my output layer. This is the code that I've written. And my activation is linear because the output that I want from this model will be a number between whatever specified range will be. Okay. Okay, that's great. Now, my people, what you do, you take a variable by the name model. Now you import something called Keras dot model. What this dot model will do, inputs will be equal to inputs and your outputs will be equal to your outputs. What you are doing, you are combining your input layer, hidden layer, output layer all as one model, and the name of the model will be called model. Are we clear? Sir, can we take activation equals to sigmoid? No, you can't. In this case, you can't. In the activation or in the output, you can't take sigmoid. You want the answer to be between 0 to 100, not 0 to 1. Since the output layer is the final load, I thought so I'm using practically sigmoid and softmax to use my output. Sigmoid and softmax should only be used if your output has a classification based output. 0, 1, yes, no, true, false, positive, negative, neutral. Only in these conditions can you use in the output just these layers or just the activation. If your output itself is a linear regression or a regression based output, then you can't use sigmoid because you want your number to be between negative infinity and positive infinity, not between 0 to 1. Yeah? Okay. So guys, I have taken my entire neural network and called that neural network as a model. Can I say this? I will just simply return the model. Is my function written? Is my function complete? I have said I have created my own custom layer. I took the input, I took the hidden, I took the output, combined everything as one model, and I'm calling the whole thing as model. Only and only specific to this piece of code. Does anybody have question? Line number 25. Any question? The code is good. Now, my neural network, whatever model I have taken, I need to instantiate it or take a variable for it or a name for it, and I'm going to call create custom model. Have I done this? I did. Remember one thing, guys. Once you have created the model, in any neural network code, you need to compile the model. So model.compile. Inside this particular compile, you guys know that you have to use something called as an optimizer, right? Some kind of an optimizer that can make my neural network work as fast as possible, as best as possible. Usually, the kind of optimizers that we use is something called ADAM. There are many. ADAM, RADAM, ADAGRAD, RMS prop. There are so many. We are taking something called ADAM, and the learning rate I'm going to take for this particular ADAM is 0.01. And the loss function, since this is a regression based output, what is the usual loss function that people use? Mean, SQUARAD Explain loss function. When you implement linear regression, what loss function? Mean square error, mean absolute error, mean absolute percentage error, root. Whenever you have used linear regression or any kind of regression based output to measure how much loss it is, haven't we used root mean square error, mean square error, mean absolute error, mean absolute percentage error? These are some of the errors you can use in linear regression. I have simply chosen to use the concept of mean square. Agree, disagree? The optimizer, the one that will make my neural network run to the best of its ability, is ADAM. I'm going to come to optimizers some other time, not right now. And the loss function is mean. Now guys, what you can also do is you can print something called model.summary. And if you run this output, please tell me, everybody, input layer is what shape? Can you say 3 is the input layer nodes? The nodes shape is 3 in the input layer. Agree? Yes or no? Good. My dense layer, which is the layer, which is my hidden layer, also has 2 nodes and output 1 nodes. Now tell me guys, totally how many weight values will I have? And how many biases? Together total how much? So how many parameter model have I just built? What's the parameter model that I have just built? 11 parameter model. And if you want to summarize that, you can summarize it with something called model.summary. If you leave from your home to go to your office, you want to take the fastest route which will give you or which will get you from your work to your office and your office to your home. As human beings, we are always greedy. We want to go from one place to other place very, very quick. We want to make sure that we are able to sort of reach fast. Okay. My question to you all is, you as a human being want to optimize your distance or time from office to work, work to office. Just like that, a neural network wants to do something called converge. Sir, what do you mean by converge? Understand the pattern as fast as possible. Agree? I want to understand the pattern within the data in the best possible way, in the best possible direction. To make sure that my neural network converges or understands fast things the most effective way, not fast, but in the most effective way, you have to use something called optimizer. Optimizers make your neural network understands the pattern within the data in the most perfect sense, in the most right direction, in the most right sense of way. It makes your understanding. If I don't use optimizer, sir, will my neural network have a problem? No, it will just take a lot of time. But when I write optimizers, will the time frame and the understanding become faster? The answer is yes. That is what my data set is built of so many different types, right? So from sklearn dot, what do I call if I want to import for train test split? So I need to use something called model selection, right? I can import something called train test split. Yes or no? But in our example, I am not going to do any train test split. No, I'm not going to do it. I'm going to pass the data directly.
Hello everyone, Intellipaat offers executive postgraduate certification in data science and artificial intelligence in collaboration with iHub IIT Roorkee. Through this particular course, you'll get to learn multiple tools like Python, PySpark, SciPy, NumPy, Pandas, Matplotlib, TensorFlow, Git, etc. You are going to learn multiple skills like data science, natural language processing, deep learning, fundamentals of generative AI, prompt engineering, and application based generative AI, as well as recent trends like agentic AI. This course is designed to get you ready for the AI world. So do check out link available in the description. Also through this course, we have already helped thousands of learners take positive step in their career. You can check out their testimonials on our Achievers channel.
I will take something called as history. History is equal to model dot fit. So whatever model you have taken, I want to fit it. Sir, in the model dot fit, I am passing the value of x and y. Now, sir, how many epochs do you want to run? Epochs will be equal to, I don't know, let's say 150 example. And the batch size that I want to take would be approximately equal to 32, right? Validation split will be equal to 20%. And let's say verbose will be equal to 1. And if I run this model, okay? See what's happening right now. It's running my neural network, and you guys can see that it is printing something crazy. It's going on and on and on and on and on and on and on for 150 size. For 150 steps of operation is what my machine learning or my neural network will be trained on. Now, once all the 150 operations are over, can you see the list of the neural network training that happened? So my model went through step number 1, then went through step number 2, then went through step number 3. That's great. But sir, what do you mean by epoch and what do you mean by batch size? And sir, why is this an important criteria for me to remember? Okay. For a deep learning engineer or a machine learning engineer, why is it important? Imagine guys, I keep in front of you 10 different types of fruits or 7 different kind of fruits. And I tell you, you are facing in this direction. Your face is in the direction of the arrow. You are supposed to turn only for 2 seconds and then vapas turn back again. How many fruits were you able to remember? Only for 2 seconds. If you are able to sort of move your head for 2 seconds and then tell me how many fruits were you able to remember at once. Now, if I increase the complexity of 10 fruits to 10,000 fruits, to 100 fruits example, not even 10,000, 100 fruits. How many will you be able to remember in 2 seconds? Not much. Much will you be able to remember? No. So tell me, did you look at the entire data or the data that has been passed to you once? Did you look at all of them only once? Did you look at the entire data once or more than once? If you have to remember or understand the data well, do you have to look at the data again and again and again and again multiple different times? When I say epoch is equal to 100, your entire training data set is seen by the neural network 100 times to get a better idea of the data. Are we clear? Epochs meaning that particular data is seen by the model 100 different times. When I say seen, technically speaking, that same number is used in the neural network training 100 different times, because I want to make sure I understand the data really, really well. If you just pass the data to me once and expect me to understand everything in just one go, it's not possible. I have to look at the data multiple different times to get the idea. That is epoch. Are we clear? Now, sir, passing and looking at the data at once when the data set size is 100 is also very hard, no? Like looking at handling with so much data at once is also hard. So I will split 100 data point into small chunk, small bite-sized pieces. This is one piece, this is one piece, this is one piece of data, this is one piece of data, and this is one piece of data, right? This is what you called as a batch size. So if you have 100 data points and divide it into 10 batches, each data batch will have a 10 data points. Understand what I'm trying to say? Batch size means from the entire data, take a small portion of the data and pass it to the model. Understand what I'm trying to say? You don't take an entire data set, take a batch of the data set, pass it to the model, then take the second batch, so that bite size information goes to the neural network. It does not have the responsibility to look at the entire data at once. What is the batch size and what is the epoch? What is the batch size and what is the epoch? Batch size once again. Okay. If my data set size is 32,000, this is the training data set, and my batch size is 32. Each batch of data will be how much? How much will be the size of the batch? 1000. How many such batches will be there? How many such batches will be there? 32 batches will be there. Is the idea clear? Is the idea clear, everybody? Listen to me. Can you see something called verbose equals to 1? We have to give pattern in which our model looks the data. So no. See, when we use words, we got to make sure that they mean something. Pattern doesn't have any meaning. What pattern are you giving to the model? Model is responsible for learning the pattern. You are simply giving the data to the model in such a way which it becomes easy for the neural network to consume or utilize. So pattern may not be the right word or choice of word. We can say that we are passing the data in such a way where it becomes easy for my neural network to consume. We are nobody as human beings to pass the data. We pass the pattern. We use machine learning to understand the pattern. So there is nothing called pattern for machine learning. We don't pass anything. We are not the one passing the pattern. We are the one getting the pattern from neural network. What we do, it's just that I'm not sure if you guys like have seen a child who's just, you know, like a 5-year-old, 6-year-old kids, right? If you see them eat something, they don't sometimes have the idea that, okay, if I'm eating something which is not going to fit in my mouth, let me break it into 4 different pieces, right? You know, kids usually open a wider mouth and try to eat everything at once, which becomes harder for the kid, right? So rather, we break the food item into 4 different pieces and we give them piece by piece. That's the same logic. So rather than neural network handling everything at once, we just break it down into smaller chunks. Now verbose, sir, what is verbose? See guys, verbose is how you are getting the print statement. Okay. I'm saying what segment of data has given or looked by our model have some ways. When this model is running, I ran this particular model, correct? And I got the answer. But once you close this Google Colab, all the learning will be lost. Agree, disagree, everybody? I trained my neural network model. I ran the history. I ran this particular code. If I close this once again, I have to rerun the entire code once again and tell me if your data set size is 50 million data set. Do you think you have the option of running it once again? So, sir, my question to you is, if I make my neural network learn something really important, can I save that intelligence? The answer is yes. Am I going to show it to you? Yes. You got what I'm trying to say? Once your model has learned, it's understood the pattern, it's actually gone through the process of training, you can save the intelligence somewhere else. You can save the model intelligence so that you don't have to rerun the model once again. Sir, what do you mean by verbose? Guys, verbose is just a way of how the entire neural network will look like, or the print statement will look like. See, if I make the verbose equal to, let me take epochs equals to 2 and verbose equals to 2. So can you see here, when I change the verbose, hasn't the print statement looked a little different? Initially, it was looking proper and nice, and now the print statement doesn't look. And if I say verbose equals to 1, my print statement looks separately. So it's how you look at the data. So my verbose or my epoch size was 150. So I am just going to run the whole thing once again. Okay. Sir, what is validation split? You guys did machine learning. In machine learning, you guys know, right, that there is something called training, testing, and there is something called validation. Validation will tell the model on specific the test data set or a specific data set what my model's accuracy is. It's not training, not testing anything apart from that. It's a separate data set on which we do the validation or to check whether my model has done a good job. So that is what we have called or validation split. This is what validation means, okay? Do we have to find out the optimum density or we choose randomly? No, 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 this is random, Toby. There's no need of identifying it in the beginning or the prior. There's a smart way to figure it out. So now, guys, if you understood, we have run the machine learning model or our neural network for 150 epochs and the batch size 32. But my question to every single person is, guys, how do you accept that somebody, point number one, when you say, when your best friend says that, hey, I have consistently performed better in my exams, or I will prove I will consistently perform in the exam. Okay. How do you accept that claim? What will be the proof to accept that, yes, I believe now whatever you're saying is the truth? Result. So, from all the 5 exams that this person has been giving, his score needs to improve consistently, right? Like this. And his bad habits, the habits that he's been consistently carrying very proudly, should decrease, no? Right? So all the bad habits should decrease and all the good habits will increase. Agree? This is how you will be able to prove that, hey, you have proven that you are capable of change or you are changing. Just like that, if I want to tell my neural network or I want to look at my neural network, how my neural network has performed or whether it has performed good or not, I need to test that, right? I can't just suddenly believe and say that no. I believe my neural network is performing well. Do you think you can do this? Do you guys think you can do this? No, absolutely not. In order to get the idea clear, what do we need to do? What do we need to do? I need output is correct. So overall on the test data set, what loss have I felt or what losses have I taken into? So model.evaluate, and inside this pass the data x comma y since I have not split them separately. Verbose equals to 1. If you don't want to mention verbose, by default also it will be taken as 1. Print f double quotes of what is the test loss, what is the overall test loss that we got. So if I print my test loss, What answer will I get? I got the answer that the overall test loss value is this. It becomes a little. See, verbose equals to 1 means, can you see the print statement, the one that is printed in front of you? 32 out of 32 with the green color line, 0 seconds, 3 milliseconds per step. Overall loss is 844, but the test lot average is 826.09. If I change the verbose equal to 2, is my print statement different now? It is different. If I say, okay, first of all, very, very weird. But verbose equals to T. Did it print everything else unnecessary? Unnecessary information was not printed. So verbose is the way you want the print to look like. How you want the print statement to look like. How much information of the print that you want to give about the operation. Are we clear? It's the way the information is being shown or presented in the data. Agree, disagree? Are we clear until here? What about zeros if you give? What about 0 if you give? What about 0 if you give? Oh, verbose equals to 0. If you mention no verbose, okay, and print the answer, is it giving a by default value 1? Correct. So my recommendation is give verbose specifically to tell the developer that, hey, I have used a verbose of 1. But yeah, if you don't use 0, it does nothing. Okay. So how many maximum value we have for verbose? TensorFlow verbose. I think there are so many verbose values. I think there is 1, 2, 3. Yeah, up to 2. 0, 1 and 2. There are 2 values. Verbose is 0. Verbose is 1 and verbose. You split the data set into training and testing. Everybody knows this. Everybody knows this, right? If I have a data set, I split the data into training and testing. But tell me one thing. To really understand whether the model has learned, can I split the data set into training, testing, and validation data set? Can I do this? The reason why we take training and testing and validation is because who consumes training? Training is consumed for the model learning, correct? For the explanation of the model, for the knowledge of the model, the training data set is consumed, correct? Great. Sir, why do we use test data set? Test data set is used to test the learning, correct? Whatever my model has learned over a period of time, to test that, I use the test data set. Then what is the use of validation data set? Guys, my model, my neural network model, my machine learning model, is it working at the optimum capacity? Is it working at the most optimal capacity? How do you test that? You have used the training data, you have used the test data. You have nothing left in your model. You have nothing else left to check it, to validate it. So, what do you mean by validation? Validation will tell you multiple things. Is my model working at the optimal capacity? Am I going to be able to validate my model okay, testing is a different concept in English and validation is a different concept, right? When you say validate, you result it as an output. Okay, so when you validate somebody's feeling, do you acknowledge somebody's feeling? Let's say your wife comes to you and says she's upset about something and you validate her feeling. Do you acknowledge her feeling? Yes, I understand you're hurt. I understand I did some mistake. And this is the reason I have made, I understand I have made the mistake. You validate it, right? You inference, you understand, you acknowledge. In validation set in machine learning, what happens? If you want your model to perform at the optimal level, do you have any data left? No, sir. Training is over, testing is over. Validation set is like an extra test set that the model has not seen, on which you can do some extra operation that you want to do. Got it? Got the logic? Validation set is just like a test set. In fact, it is the cousin brother of test set. You can think of it like that. They are family members. But They both have not seen each other, or they both are unique. Models have never seen test set. Models have never seen validation set. Sir, why did you take validation set here? Tell me one thing. If I would not have taken validation set here, or if I would not have taken validation split, acha, let me ask you guys a very simple question. Did I not consume the data set into directly as an X and Y? So tell me, did I actually genuinely take a test set in my model? Do you see any X train, X test, Y train, Y test? No. So my validation split is my test set, right? When I mention validation split equals to 20%, 80% of my data has been used in training and 20% of it has been used in testing. Am I making myself clear? Because I did not do any training and testing split, I just very simply mentioned validation split equals to 20, which means my percentage of the data that was used for the model testing was 20%. I hope everybody got the idea. 20% of the data set was used for testing, 80% of the data set was used for training. Any questions? If my data set is 32,000 data points, 80% of my model will be used for testing. Because I have not taken any train test split, I have said that the validation split is 20%, making it a training set. If I have 100 data points in my data set, in my actual model, okay, this is my data. If I take 70 data point for training, so can I say 70% of my data set is going to be used for training, everyone? That's perfect. 10% of the data will be used for testing the model. Okay, so 70 plus 10 is 80. The other 20% of the data we are taking separately. Everyone should understand one fact very clearly, first of all. Sir, why do we take the data separately? Because we do not want the data to be seen by the model at all, correct? Sir, why do we keep the secrecy of this 10% of the data and the secrecy of the 20% of the data? Because we don't want the model to see this data ever again, correct? If the model sees the data, it will become overfit or overconfident, correct? Then real testing has no meaning. Now, Saraswati,
Yes,
why
sir.
do we use validation is, suppose you have run your linear regression model. Example, suppose you have run the linear regression model on the 70 data set and tested the model on the 10 data set, correct? Can you make your linear regression even better? Even better if I ask you, hey, Saraswati, can you make your linear regression model even better? You can say yes, you can say no, but do you have any more data left? Correct? Exactly. So why will you use validation? What is the intention of validation? 20% will be used for to make or to optimize your algorithm to make it even better. Got the logic? Sir, how do we make it better? Tell me one thing. In linear regression or logistic regression, you give hyperparameters, right? Like, uh, okay. Have you studied decision tree? In decision tree, how do you split a decision tree's root node? Gini impurity, information gain, or entropy. These are the three values, right? On which you decide which root node will be split. Either it will be gain impurity, either entropy, or either information gain. Which one is better? We don't know, right? Given data, we don't know which one is better. Already my training has been consumed by the training data set and testing has also been consumed. So tell me one thing, to optimize the answer, will you use the test data set once again? No, we can't do that, correct? So tell me, if I want to make my decision tree even better, even optimized further for hyperparameter tuning, can I take the validation data set on which my model's training will help me to calculate which data is better at splitting the decision tree for which criteria, how much deep my model should be. So rather than using the entire data set, will validation set help me? I want you to think, but there is a fundamental question you need to ask. Sir, what will be the core difference between training data, testing data, and validation data? Right? You have to really understand what is training data, testing data. Okay. Imagine every single person in the class is studying for a physics exam, okay? All of you, or a maths exam, anything, okay? Whatever you have learned for the exam, is that the training set? Whatever you have studied for your exam, whatever you could study for your exam, that entire data is your training data. Now tell me one thing, to test or to give the exam, okay, suppose you have studied something to give the exam, but before giving the final exam, don't you take multiple mock tests in between? They are like test, but they are like mock test to check how good you are performing, how optimized your results are, how better you have become. Agree, disagree? So tell me, won't validation set act as a mock test? But tell me one thing, whatever training data you have seen, if the same data will come in the mock test, won't you score 100 and 100? Validation set is like that extra special test set which you can test the model further on to make it better, to make it optimized, to go beyond a certain scope, you use validation set. Sir, what is, okay, so first of all, 0.20 means 20%, correct? What is the difference between validation split and validation step? Okay, validation underscore split and validation underscore step. First of all, remember this. It's not just validation split or validation steps, there are more. Okay, have a look at this. Validation, can you see validation batch size, validation data, validation frequency, validation split, validation steps? One, but there are many. First of all, validation split is going to be a number that will tell you how to split the percentage of that data. Validation steps will tell you how many batches, how many groups will you be able to take from the pre-existing batch size again and again to make your model run. Okay, I'll explain that very carefully. How many batch sizes do I have? 32. If you take validation steps equal to 2, out of those 32, how many batches will be taken for validation at random? Half of from batch 1, the 2, because 16 plus 16 is 32. Got the logic? Validation split is equal to 0.20. Okay. No. It actually genuinely improves. It becomes better. Hyperparameter tuning Moses is a step that you have to follow certain rules, certain regulation. What you're doing right now is just sort of doing like a quick dirty work. But yes, you are in the right aspect of thinking that yes, sir, I can call this sort of like a tuning of my aspect, which is not wrong, which is absolutely correct. No doubt. The data, so we cannot improve model with no. Okay, first of all, tell me this. Can you think of one logical reason of improving the model with a test set? Do you think you can do that? Is the responsibility of the test set to improve the model or to test the model? What is the responsibility of the test data set? If the same test data set you will use for model improvement, will your model for sure overfit? I want you to think about it for a second. When you studied for the exam and when you gave the mock test and the test in the real life, can you use before even giving mock test directly the test? Tell me this, will directly giving the test help you in some way of understanding whether you improved or not? No. Same condition may also apply for validation. I want you to think from a logical perspective a little bit and tell me if this makes sense to you. There is a responsibility given to each individual process. Sir, can I not just in the time of my examination on the test exam, can I just run away from the class? See, of course you can do whatever you want, but there are certain regulations specified and those responsibilities are not to be violated. Same way, if I am studying for the exam, I am giving some mock test for the exam and I have taken the test data set. The test data set logically and mathematically are built for what? They are built to check whether my model or my student is the optimal learner or not. That validation set and test set are kind of test set, correct? Validation is not a separate thing. It's a kind of test set, correct? But you should not use validation set for testing something. Or if you use validation for testing something, it should not be used for just testing. Only your pure test data set should be considered for whether my model has learned, your accuracy, your F1, your precision, your recall should be calculated only and only on the test set. On validation set, I can check whether my model could be further improved or not. Can I make my model's intelligence even better or not? In those conditions, only and only your validation set will be used. Otherwise, you can always confuse test set with validation set. Sir, can I not use validation test for test set? Of course you can. But internally, your machine learning library will not allow you to do that. At the end of the day, validation set is also a type of test set. When you train a machine learning model has the capacity to see the data, right? To understand from that data. If you have taken the test data set specifically to test the machine learning model, if you take the test data set and put it in the training model, will your model overfit or not? Tell me this. But validation data set, is it used? Okay, so let me explain. When I say I am improving the model, did you understand or did you think that I am taking the validation set data and putting in the training? Did you think that when I say I will improve the model, I am taking the validation set data and I'm putting in the training model? This is what you thought? Suppose मैंने 5 data set लिए मुन्ना 1 and 2, ठीक है? Age, Sibyl, salary, and this example. So let me say age, salary, Sibyl, and whether the person should be given loan or not. Example. So 1, 2, and 3. Random search CV and grid search CV से अज्यूम कीजिए मेरे पास 5 डेटा पॉइंट हैं 1, 2, 3, 4, 5 and let me remove 6 1. Okay, एक मिनट, remove 6 1, 7. ओके मेरे पास 7 डेटा पॉइंट. अज्यूम कीजिए मेरे पास 5 डेटा पॉइंट हैं 1, 2, 3, 4, 5 and let me remove 6 1. ओके एक मिनट, remove 6 1, 7. ओके मेरे पास 7 डेटा पॉइंट्स हैं. लेट मी expand this and in real life when my model is being trained, can I say I use say majority of the data? So data point number 1, number 3, number 4, number 6 and number 7 is used for training. So 1, 2, 3, 4, 5 is used for training. To test whether my model has actually learned from this data or not, I will use model data point number 2 for testing, correct? अब validation के लिए 1, 2, 3, 4 validation split will be data point number 5, correct? My model has been trained on this training data set, no doubt about it. My model will be tested on this data set to get the accuracy, which is going to be this particular value too. When I want to improve my model or I want to check whether my model is doing good or not, I am not checking or improving the model by changing anything in the data. I am not changing anything in the data. Nothing in the data will be touched. I am checking that in linear regression or logistic regression, there are multiple different ways a logistic regression algorithm could be built. Let me explain. Give me 1 second. Suppose I have a decision tree algorithm. In the decision tree algorithm that I built, I could have made my decision tree split the root node based on Guinea impurity, or I could have split the data on information gain, or I could have split the data on, let's say, entropy. Example. Now build the decision tree. Which data will I use to test which particular hyperparameter helped me build the tree better? Training and validation, right? Training will be used to train the model, and this validation data set will help me build that. On the validation data set, is Guinea impurity split the best, information gain split the best, or entropy split the best? At the same time, if I build my decision tree In decision tree, I have the option how much deeper I want the model tree to be built. So should I build 2 step deeper, 3 step deeper, or 4 step deeper? Can I try which step deeper also on the training data set and validation data set? Got what I'm trying to say? So, meaning the decision tree that you are building on multiple different types of decision trees or types of decision trees will be only built on the validation set, right? Not on the test. Training will be used for training and validation will be used to check which one is the best split model, correct? I have used a model called decision tree. Can you see right there? I have taken a decision tree algorithm. Okay. To make this decision tree classifier even better, have I taken multiple different types of parameters in the decision tree classifier that first try the decision tree to split on the basis of Gini impurity, then also on entropy. The maximum depth of the tree should be 3 leaves or 3 or 5 or 7. I have multiple different data. Can you see, to train the machine learning model or to make the machine learning model find better, I have passed something called X-train and Y-train, which is my model parameter. To train a machine learning model, you do pass a train a machine learning model, right? But can you see here, I have passed something called the cross validation equals to 5. CV means cross validation, right? So what do you mean by cross validation? Cross validation means it will try and test for 5 validating set of data points. Train will be done on the training, but the validation will be done on the score of validation data points. Meaning, when I ran the algorithm, I got that the optimized answer or the neural or the decision tree that you should build should have entropy as the criteria, maximum depth could be 5, min sample leaf could be 6, and min sample split equals to 2. This result came directly from validation dataset, not test dataset. Only validation is used, not test. The job of test is only to print precision, recall, F1. That's why when I'm printing precision, recall, and F1, look at this. Am I comparing Y test with YPRED? YPRED is nothing but this X test. See? If you want to further improve the model, add more data. If you can't add more data, take a larger validation size. If you can't take larger validation size, this is the maximum you can do. So validation done before testing, is there a very bad accuracy? If there's a very bad, then it is to do some change in the training data set. See, in real life scenario, if your model is not performing up to your expectation, it's not the problem of the test set or the validation set or anything else. It's the data itself. Because test data is 10%, 20%. Majority is going into training only, right? If it is not able to perform in the training itself, what can training and what can test and uh, uh, what can test data set do? What can validation do? So majorly it depends on the training data. Import matplotlib and PLT from or import matplotlib dot pyplot as PLT. Everybody listen to me carefully. Sir, I want to make sure that I want to check how my neural network performed. Okay. So plot.figure, everybody, inside this, I will say figure size is equal to SIZE. Figure size is equal to, let me take 8,6 example. Plot.plot, PLT.plot, and inside this history, HISTORY dot HISTORY, history of loss. The label that I want to put this in, LABEL, will be the training loss. This will be the training loss data. Plot.plot, understand, history dot history, and inside this I will take something called as the validation loss, pretty much the same thing, and label will be equal to validation loss. So validation underscore loss, pretty much the same. And what title do we give it? Plot dot title, let's say that the title of this plot is model over epoch, or you know what, train versus validation loss graph. Loss graph. And what I'll do is model or plot dot x label. I will pass this as the epoch that we've taken. Plot dot y label, and y label, I will say that it's the amount of loss the model has incurred. Plot dot grid, and of course I'm going to make plot dot legend also as true. And inside the grid part, let me take the alpha is equal to 0.4 example. Do you see this graph in front of you, my people? Okay, now listen to me carefully. Is my loss decreasing over a period of time? The more and more epochs I have given, the more and more the neural network has seen the data, the better the model has become, right? The loss function has decreased. Your expectation in any deep learning model is that my model and my training should decrease in its loss, and it is decreasing in the loss, everyone. The answer is yes. So, which means my model has eventually become better over a period of time because my loss function has decreased. See, on the x-axis, number of epoch, as and when the epochs have increased, my model's loss has decreased. That's why my model has become better at understanding few things. It's become better at understanding how the whole aspect of it works. Agree, disagree? Your neural network actually did perform well. And tell me one thing, didn't we just give a very simple neural network? We didn't even make it complicated. Even if the neural network is simple, it was able to understand things very easily and better. Now, guys, sir, I want to make a prediction. I want to make a prediction in the future. How do we particularly, can we see the neural network right here? What do you mean by CC, Grace? Are you saying print those circles and no, we can't do that. You can print the parameters for sure, but I can't print, like, there's no, I mean, we already know what a neural network is. The maximum you can do is print just the model. So if you just take the model and run it, see, you will have just this particular aspect of it. So if I try, no, let's try to unpack this. Right, model, no, you can't unpack this. So yeah, the maximum you can do is print the summary, but you can't see the actual visualization of it. History object used in plotting the graph is written by TensorFlow. Yes, it is. No, see, tell me, did we not take the model's training as history? So in this portion, when I used history dot loss within the history, what you're doing, whatever variable you have taken, within that you are taking specifically something called loss, and you're taking something called validation loss. That's it. That's what you've given. So this comes from TensorFlow, but we defined it. We are the one who've defined the name history. The name history doesn't come from TensorFlow. We've defined history, and that's why it's able to pop up here. Are we clear until here? So when you look at this graph, you get the idea that over a period of time, my loss function has decreased consistently. Both my training loss and my validation loss, they are both at the same aspect. But let me ask you guys a small question. Sir, if my age or my cups of coffee is something. So for example, if I have a sample data where the cups of coffee is np.array. Inside this np.array, what was the data set like, my people? Cups of coffee and hours of sleep and travel time. Give me 1 second, copy this, paste it here. Sir, let me take it like this, right? So, what is the cup of coffee? Hours of sleep. How many hours of sleep do you want to give, guys? How many hours of sleep do you want to give this guy now? Let's try it out. Hours of sleep will be 7. Cups of coffee will be 3, and travel time will be equal to 25 minutes. Can I say it like this? If I pass in hours of sleep, right? HOURZ, hours of sleep. Cups of coffee, right? Cups of coffee, and travel time. Sir, I want to make a prediction that for this data set, what is the answer? Can I say prediction is equal to model.predict and pass in your sample data? Prediction. What is the answer, everyone? His productivity score for that day will be 46.98%. Almost 50% he will be his productivity. Got the logic, everyone? If you want to take a knowledge, print the model, get the output. This is how you're going to be able to predict. That's it. I was able to predict what is the answer. Sir, what if I make the hours of cup of coffee 10, cups of coffee 6, and travel time 30 minutes? What about now? What will be his productivity score? 46.98. What if I make this 10, run it? What about now? 46.98. But sir, I changed the value. Why the model did not predict? Because tell me one thing, isn't my model's data completely random? We made the data of the model not from a proper perspective, but from a random perspective. So tell me one thing, was my intention of teaching this program to tell you how a model or a neural network works? Actually, no. The reason I taught you all of this was because I wanted to show how a basic neural network is written. Agree, disagree? The only reason I made you guys run through the entire code was to put the effort in just teaching you the concept of how a simple neural network is written. Guys, did I tell you how to take multiple hidden layers? How to take multiple nodes within the hidden layers? How do you take multiple? No, because we started with the basics of neural network. And my intention was not to teach you the complicated part of neural network. We wanted to simply understand that how can a simple neural network be built? And after running this code, you must be feeling slightly better, right? That, yeah, I understand how a neural network is actually written. What steps, what values are okay for me to do? What ways I can write my neural network? At least from this perspective, you will be slightly clear, correct? Now, guys, can we do a little hands-on? In the hands-on part, we will not just train the model, we will save the model, we will tune the model, we will check the model's accuracy and performance, we will plot the graph for the model, and we will even see if my model can be further improved and run as fast as possible. The one situation that you will be practically dealing with in your career if you ever build anything like this. So can we take a system which is a feed forward network? Do you agree with me? But tell me guys, do you want to do that today or do you want to do that tomorrow? Because the data set is for sure. No. I cannot share the collab link because this collab link is very expensive. It will cost a minimum of 3 to 4 cups of cappuccino or frappe or espresso. So I have given you guys the collab link. That's not going to be a problem. But my bigger problem and my bigger concern is when I wrote this neural network, everybody, when I wrote down this neural network, at least the hard work that I did for all of you to at least go through the entire process of making data, testing data and all of that, please tell me you got the logic right, how a neural network is created. In a simple term, how will you be building the neural network, your input layer, your hidden layer, your output layer? How do you connect everything together? Guys, the entire reason we did the whole exercise was to explain this particular line of code. That's it. This is the most critical part of the line, of the entire code, which I wanted to teach. And also this one, can you see here, my people? X comma Y, epoch equals to 150, batch size equals to 32, validation split equals to 20, and verbose equals to 1. This is also important. What we did does not matter. What are we going to do tomorrow? Or what data set are you going to implement? Or what kind of idea do you get? Okay. Everybody knows, right, that there's a website called UCI Machine Learning Repository. Are you aware about this website, everyone? The UCI Machine Learning Repository. If you ever want to learn practically how a data science works, see companies like Twitter, Meta, other big organizations, they upload the data set on UCI Machine Learning Repository, or they upload data on a website called Kaggle. Okay, these two are the companies that will upload their data set for you to try on. I'll give an example: heart disease. Okay, if I want to predict somebody might get a heart disease or not, so see, what data do I have? This is better than Kaggle. This is 100% better than Kaggle. So I have age, sex, chest pain, thread blood pressure, resting blood pressure, your sugar, cholesterol, your fasting blood sugar, your echocardiogram values, your old peak values. So see, I will be able to predict when you will get the heart attack, when you might not get the heart attack, and the columns in my data is this much. And can you see, overall, hundreds of people have run the model, and which model has given the best accuracy? Everyone listen to me. Which model has performed at the most optimum accuracy? XGBoost. XGBoost gave the most accurate results for the given data. Are you understanding? Can you see here? Your neural network was not able to do that well, but guess what? It is very close, no? Neural network is close, better than support vector machine, but who beat neural network also? Logistic regression. Can you see? Logistic is almost as close to the XGBoost. And what about precision? Same exact results. But in precision, XGBoost perform better than all others significantly. So listen, UCI machine learning repository is where you will get the data set from if you want to ever practically test everything. But apart from this, can I tell you a mafia way of learning things? The ones that nobody think of. It's a trick, it's a tip, but sort of people learn it like that. Nobody has something like that, right? Use GitHub, right? Like this, GitHub user content, and click on this. Can you see this website called raw.github.user-content? Can you see this raw.github.user-content? I'm going to open up my Git for you guys, right? So let me explain my GitHub. Let me open up my GitHub. Let me open up some repository. Let me open up, I don't know, color picker example. Do you see this link, this URL? Or maybe, I don't know, machine learning nodes. And let's say dataset, machine learning, k-means clustering, and income.csv. Yeah. Do you guys see this dataset in front of you? Rob, Michael, Mohan, Ismail, Corey, Gautam, David, Andrea, Brad, Angelina, Donald, Tom, Arnold. Yeah. Go to this particular URL, and instead of having github.com, write raw dot github user content. Click enter. Let me copy this. raw.github usercontent.com / the name of the ID is the same, or wait, give me 1 second. I have a better way of handling this. Copy this. Let me see if I can do it directly with the request package. So import pandas as PD, and I am going to be like, my data frame will be PD dot read read URL. So read underscore CSV, and inside this, my URL will be this, double quote here and double quote here. So if the package gets read, then I will know that the URL's request works for. Yeah, it is a parse error. So what is the parsing error? df.read something CSV. This is an HTTPS package. So wait, give me load this income.csv. loads the whole thing. So raw /raw dot GitHub user content. I don't need my ID. Let me remove my ID and click on this. What about the same particular model? Give me 1 second. Raw GitHub user content, or change this to GitHub user content and run this. This is weird. Can I take it directly from the base URL? I think I can, but what did I do? pd.read.csv. Let me take it separately. URL equals to paste this, not raw.github.user content, but the entire URL. This is my base URL, correct? Control X. Change this, actually replace this with the old content. Now, if I change and check for my raw.github user content, wait, let's just check for this website. It routes raw github user content.com. Okay, this is the link. The test will be on this, right? So this is how the GitHub content looks like. Okay. All right. If the entire thing is raw, okay. But I think the base URL does not change as it is, right? So meaning if I make this as GitHub content raw, so if I take the URL directly, for the same base package, I think it will change. So I don't know. So I think rather than changing the domain subbar value, how about I change only the aspect of it? So let me copy this, paste it here, and change just the portion of it. So if I say, okay, what was the name of this? Raw.github user content, right? So let me copy this raw.github.user content. Let me paste it here. Double tap HTTPS. Only for the GitHub part will I change this to raw.github with one single line. Actually, HTTPS 2 line raw.github user content.com. The name of the directory will remain the same. Would it also mean that I think I've changed it slightly? Yeah, I think the raw.github user content itself is not able to reach. I mean, I'm not able to sort of reach the whole package itself, which is not correct. This is HTTPS GitHub user content.com, which is going to be fine. The name of the repository and the blob that I have taken, which is pretty much the same. So if I even check it, will my URL hit right? I think it should give the answer. Or maybe did I make a mistake somewhere? Give me 1 second. Control copy and control V. So this is my base URL, right? My base URL is this HTTPS raw.github user content, which is fine, which is I've taken as it is. Okay, I understand now what the problem is. See, the problem with this is, I think I understand what the problem is. Let me show you what mistake I did, right? So let me copy the whole thing and let me paste it here. So let me zoom in a little bit and show you the base URL. Let's wait. Guys, the problem in the base URL is, do you see this thing called blob, BLOB blob? This particular route or route called BLOB blob. See, when you work with raw GitHub user content, right, it needs a base package reference, but it does not need the entire path. It does not need the entire route of the structure. So instead of github.com, if I just say raw.github user content, or Control Z, rawhub.github.user content. Let me copy the same thing. Copy this, paste it here. Where is it? Right here. Raw.github.usercontent.com. And after that, I don't need the github.com because there is also or always a .com parity available, right? After this, the name of the package or my repository, which is Parth Sharma 1011, ML codes, don't need the blob because blob is no longer in the route. Whatever your master is, machine learning 13. I think this should work. Oh yeah. Take over here, take this as a base URL, double tap, paste. Now, if I make this URL work, what did I do? Oh, URL. I need to pass the URL inside this also. Do you see the data loaded? See, the reason I am doing this is because sometimes you don't want to save the data unnecessarily inside your laptop, correct? Like for example, you went through GitHub and you went through the data set, you like the data set, but the data set is of 50 million size or 30 million size or 40 million size and you don't want to spend that energy. Loading it separately in a memory, then loading it again in the Jupyter notebook. So what you can do it, you can convert that into a GitHub user content library, remove the blob, please only give the repository folder and the subfolder and the file name .csv. You should be able to load that. If you want to look at the table also, you can check all the values at once. So you can use raw.github user content to load the data. You can use UCI machine learning repository. You can use Kaggle. Use all three to get the answer. Your life is going to be pretty much sorted. Are we clear? Just a simple introduction, a very simple introduction to what a neural network is, how it can be written for you today is a completely different way of handling things, writing down your neural network, saving the model, loading the model, and getting things done. So basically, the idea is right now, the way we are going to be handling things will be slightly different. Today, I'm going to show you guys an example of how actually, as a data scientist, you are supposed to handle data analysis, to saving the model, to loading the model, to showing how exactly you are supposed to work on a data set. Okay. So everyone, the data set that we are going to be working on will be completely different today. The very first thing that we need to do, let me go ahead and put a text comment here. And let's say with a double hash that this is an example code to showcase the capability of implementing neural network in production. Okay, so this is how we will be sort of working on the production. So the first thing I'm going to be doing, guys, is I'm going to be importing numpy as np. Let me zoom in a little bit. I think this is much better, right? You guys will be able to sort of see this. Okay, import numpy as np, import pandas as pd, and import mat.pyplot as plt. Now, before we do that, let's go ahead and connect our Google Colab notebook, because if you don't connect, it does not connect with the server. You cannot currently connect to GPU due to usage limits in Colab. Let me see what seems to be the problem. Change runtime type, T4 GPU, save, connect without GPU. All right, but I think if I do it without GPU, it's going to take a lot of time for me to implement. Okay, anyways, let's connect without the GPU part, no problem. Perfect. Okay, so I'm teaching you today is actually called a telecom data set. I'm going to show you guys the raw sort of link, and then we'll try to see how the whole thing works. So guys, first of all, I have a URL that is a GitHub's user URL, which is the GitHub user content URL. Let's load the data. And the first step that you are learning right now, the first step that I'm teaching you is what we call as data loading and exploration stage. Okay. The URL that we have here, df is equal to, we have pd.readcsv, read underscore csv. And inside this, I'm going to be passing something called URL and df.head of 5. Now, if I load this, if you guys can very clearly see, I am able to see a certain data set where I have customer ID, gender, is that person senior citizen or not, whether that person is a subscriber partner, how many dependents, what's the tenure of the person using the service, the phone service is used by the person or not, are there multiple lines, is internet service available, online security section taken or not, device protection. But observe one thing. Do you see this multiple three dots in between, a dot and a dot and a dot in between? Now, here is the problem, and I want you guys to listen to me carefully, okay? See, whenever you work with any pandas dataset, I want you to understand one thing very clearly. Sometimes you work with the dataset where the amount of columns in the dataset could be larger than 100 also, right? It could be 100 columns, it could be 20 columns, it could be 45 columns, it could be n number of columns. The problem is in Excel file, 1000 columns, I really doubt 1000 columns will be available. I have never worked or seen a data with 1000 columns, but yeah, it could happen. I don't know. It could also be one of the things. But what I want you to understand is this. When you open a data set in Excel, it's easy for you to scroll through the columns and look at it. But when I did that, the same thing with pandas, what did it do? Everybody, did it give me some of the initial columns and some of the final columns, but in between, it did not give me the columns, correct? It ended up missing out on some columns because it does not have space. Now listen to me carefully. In pandas, there are ways to bypass this system, and the way to bypass this system is using something called max columns. Okay, so pd dot, you use something called set underscore option. So can you see here? In pandas, we have something called set options. But the problem is, guys, have you ever worked in Excel where the minute you set the column, the text inside the columns is not wrapped? You understand what is wrapping, right? The text will overlap another cell and you won't be able to see it very clearly. So just because I expand the column does not solve my problem. I need to make sure I wrap those texts also. So in first of all, what we are going to do, we are going to tell pandas that, hey, I want you to give me each and individual column. I don't want you to miss anything. I want everything to be visible. So inside this, you need to mention a sub-module called display dot max underscore columns, max columns. And outside, if they don't exist, return none. Now what this will do is this will show you all the columns. But the job is not done. Because once you make sure you tell pandas that, hey, I want to look at all the columns, you want to prevent wrapping. You don't want the text to get unnecessarily wrapped so that my columns and my rows are unformatted. Okay. Why do we use none? If by mistake you have used the pd.set options, but there is all the columns that is visible, none will have the effect, the same effect, meaning nothing changes. It will still remain the same. So none means if I only have 4 columns and you've still written the code for pd.set options, none is going to save you from anything changing in the way the data. None returns none. It's going to return the same particular value to you, which you are able to see. Now, pd dot set options. Max columns is count for all the columns. Max columns will give you all the columns. Okay. Set underscore options, the same particular thing. And inside this, you have to mention something called the same exact thing called display dot max columns. Inside this, write down the same thing. So let me control X. Let me write down display dot. Same exact thing, display dot. Let me copy, let me paste it here. Okay. And inside this, you write something called expand underscore frame underscore wrapper. Okay. And outside this, you mention a word or a keyword called false. And again, pd dot Last time, you're going to say something called set option. And inside this, you want every individual column to maintain its own space. So max underscore call underscore vidth width, and outside, you're going to print none. If I run this code, and if I print df.head of 2, now guys, do you see I am able to scroll all the columns that were available in my data? Not just that, every individual columns, streaming movies, contract, paperless billing, it is not showing me paperless in one section and billing in the bottom, correct? It does not show like this, right? Paperless inside this billing, right? Even if you don't want wrapping, we have to avoid wrapping on the whole thing. Okay, we don't want the entire aspect of the code for the data to be ruined in any single way. So when we write down the display.expand frame wrapper, if you don't know, in Python we have a dunder method, right? Underscore underscore wrapper underscore underscore. You guys know this, right? This is a string override method. If you guys have done object-oriented programming in Python, there are two ways you can override anything in Python. One is called underscore underscore str underscore, and the other is wrapper. I hope you guys know what this is. There are two ways to override a string, wrapper and string. Okay, whenever you see the word wrapper, okay, you got to understand that this is how a certain overriding of strings are done without harming the original execution. Okay, so tell me this, we have how many data, right? So this is the data that we are dealing with, and if you observe the data for a second, towards the end of the data set we have a column called churn. Okay, now let me explain the concept of churn to everyone. See guys, in machine learning, or actually in the old days, we have a concept called churn analysis. Now what churn analysis simply means is, imagine you own Netflix. Okay, you guys are the owners of Netflix, and initially you had 32,000 subscribers. In the next month, 3,200 subscribers left your services and they are no longer with you. So if I take 3,200 divided by 32,000, what answer do I get? And multiply that answer with 100. What do you, everyone, what do you get? Do you get 10%? So the churn rate, the people who no longer require your service, or the people who've left, the customers who've left your services, your company, your product, are 10%. Now churn means, did the person still, or is the person still subscribed to the service, or is that person, or has that person left? No means the person is still with the company. Yes means the person has left the company, left your services, is no longer your customer. And right now, what we are going to be doing is we are going to be calculating or understanding the churn analysis for this given customer data. I want all of you to understand one thing. When you work on any data set that you are going to be given in your organization, or you do it for analysis, is every single column mentioned in the data important? Are you supposed to just blindly work with all the columns in the data set? The example could be, to predict the price of the house, will the area of the house is important? Is the area of the house kind of related to the price of the house? Yes, it is. Okay. What locality is your house in? Is this also good? Number of McDonald's in that area. Now, is this column important to the price of the house? No. But if you are given a data set, are you just supposed to blindly do machine learning or neural networks? See, the answer is no. So right now, we are going to do some basic analysis on the data. We are going to understand what the problems exist in the data. We are going to fix them, and we are going to also do something called feature engineering. Okay, we are going to be doing something called feature engineering, feature scaling, basically feature engineering in this class, to understand how to select the relevant columns, what are relevant columns, and we are going to be doing some practical stuff like that. Okay, so first of all, is everyone clear with the way we have loaded the data? The data is loaded and I am sorted to work with my analysis. Now guys, If you have worked on pandas, you guys know that whenever you want to do data analysis, there are certain things you need to run in order to understand your data really, really well. One of those things is to run something called df.info. What info gives you is give you idea about the data, okay? What this does is it will tell inputs. Point being this, listen to me carefully, but hear me out first and then tell me if I'm making sense or not. I don't mind giving you the URL right now. You can just take it right now. But if you guys want to code with me, along with me, that's not a very good idea. That's not a very bright idea, because here's the thing. Either you listen to me carefully, or either you are sort of rushing through the concept because you want to copy the code. Guys, the data set that I'm teaching you right now is something called as the churn analytics. Okay, we are going to be implementing churn analytics. This data set is a telco data set or a telecom data set where you have multiple different columns like customer ID, gender, senior citizen, partner, dependents, tenure, XYZ, XYZ, XYZ. But what I'm more interested in is the churn analytics. Are we clear? I want to understand towards the end of my neural network output, if I give you the data, what's the probability you are going to stay with me? What's the probability you will not stay with me or you will not stay with the company? Okay, this is what I want to. Cool. Okay. So the first thing that everybody should understand is when you do data analysis in pandas, there are some things called summary statistics, something called df.info. Info will give you the idea that there are 7,043 rows and there are 21 columns totally. Can you see that it says it is non-null, meaning every single column is properly filled. There is nothing called as an empty value. But what I want you to focus more on is, can you see that each individual column has the data type to it? Object data type means it is a string data type, meaning it's a simple string value. And you can see that out of the 21 columns, only one column is a float data type, two columns are integer data type, and 18 columns are object data type. Are we understanding what data type of data, or as in what data types are we dealing with? 100%. Now guys, let me ask you a small question, right? When we work with data set like this, what problem do you see? The problem is, can you see that churn is an object type, meaning the answers or the values inside the churn is a yes and a no. But will my machine learning understand yes and a no? It does not. It understands 0 and 1. So we know for a fact that my churn, which is my target variable, needs to be converted or mapped to 0 and disagree. Okay, have a look at this. Monthly charges is in float point. So tell me guys, whenever you charge $20, $25, 50 rupees, 50.67 rupees, it can be in float point value. But total charges, can that be a string value? Should that be a string value? No, that can't be a string value, right? Everything else makes sense. Everything else makes sense. Total charges and the churn value needs to be changed. At the same time, if you look at the gender, can you see gender is also female and male, which is a string value. I don't want string value. I want them to be converted into some kind of a label, 0, 1, right? So tell me, if I want to change them, df of, I want to change my total charges, right? So how do I do that? df.columns, columns, and inside this, I want, yeah, it's not a callable function. So see, I want to change my total charges into numeric value. So if I take total charges right now, remove the unnecessary one, what can I do with it? I want to take the total charges value, which is in front of you, in string value. I want to convert them into number. Okay. So while you do that in pandas, you can do that directly using something called pd dot to underscore numeric, right? So if I convert it into numeric directly, it will be converted automatically into float point value, because inside this value of total charges, it is 29.85. But there is one problem. Guys, whenever you use pd.numeric, remember in pandas, when you convert something in numeric, there are certain characters in Python like a white space or an empty space. In Python, even an empty space is considered an integer, it's considered as a. So suppose by mistake, if you have a number like 25.96 extra space in the end or extra space 25.96, you need to make sure that these errors are handled. So can I change pd.toNumeric? I want to make the changes on the entire data frame called this, but this time I want my errors to be what? Coerce. Coerce means if I find any error in the data, I will fix it for you. I will change it for you if it is fixable. If not, I ignore it. So can I write coerce? C-O-E-R-C. Meaning any special character, not special character, but any character which is apart from the type I want to convert, it will be changed. df of, if I want to convert gender, okay, what do I do with the gender? df of gender, which is this particular value, I want to change it. I want to make sure it becomes 0 and 1. So can I use something called dot? Inside the map function, okay, method, I want to change every female value should be converted to 0 and every single male value will be converted to 1. So what does this piece of line do? It is going to look at the entire column because you've mentioned the df of gender, which goes through the entire column, and anything which is female is converted to 0 and male is converted to 1. The same exact logic can be applied to my last column, which is called churn with the C capital. Please remember that to take the column names correctly. So if I take churn, copy this and paste it towards the bottom, which is here, and I map anything which is no in the churn value. So double tap, Control Z, yeah. If I change no into 0 and a yes into 1, and if I run this piece of code and say df of head of 2, so see, gender is converted or mapped back into 0 and 1. Or if you want to convert that into, say, total charges into a data type, say, a float point value, you can. Now tell me one thing, a good question, sir, could I have used label encoding here? 100%. You can. Because there are only two columns, yes and no, male and female, you can directly map the values or you can use a label encoder to get the process done. Okay, anything is fine. There are 100 ways of dealing with the same thing. But just because my column or my data says there are no empty value, can I still check if there are empty values? If is or are there any empty value in my data? In Python, there are two ways to do this, right? df.isNA.sum, correct? Can you see here? df.isNA.sum or df.isNull.sum. So let me just cut this and paste it here. Let me just paste it towards the bottom and paste it here and run this. What will this? Is it going to give me the answer that there are apparently some null values? No. Let me explain. Did you convert the data into a different kind of format, which is 0 and 1? Yes or no? So exactly, when you change it, when you change the way the labels have function, so don't misinterpret that as another value. As in, don't assume that there are changes. So let me show an example. df.head of 2. What does this show you? Do you see nan, nan, nan? Is it showing you nan? Observe carefully, guys. Why did it say nan? Or why did it say that it has to be considered nan? Why? Can somebody tell me what seems to be the reason? Because everything turned out to be none and everything turned out to be nan here, which is a null value. I'll show you why. Okay, I'm running the code from the beginning. You'll get the idea. Run, and run. Okay. How about now? Is there anything on churn, nan or nan? No, properly, every single value, including the gender 0 and 1, including the total charges and churn is 0 and 1. See guys, in Python, I hope everybody knows that pandas is, Jupyter Notebook runs on caching, right? If you write a piece of code or a function, it operates that function. But when you rerun the cell, it overrides the previous operation. Correct? You guys know this, right? If I take a cell, rerun the whole thing once again, it overrides the previous value. Okay? So that's not a problem. So tell me, how many empty values do I have here in this particular? What values do I have which is going to be completely empty? Can I say total charges? Looks like total charges has some values called empty. Okay, so sir, if I want to remove those values, okay, I don't want these to be sort of handled. I just want to remove them. So can I simply just drop? I don't want these values. I just want to drop them. So df dot dropna, drop na, and inside this you have to make sure that you write something called in place equals to true. Otherwise, the effect does not take place. Okay. Now, if I do the same exact logic, which is df.isNull.sum, copy this and paste it towards the bottom and run this, do I see any empty values in my data set? Sir, let's not drop the values. Let's take the average or mean. So Ankit, instead of dropping or taking average, you can use a better one called KNN imputer. Have you ever heard of this? And if you have an empty value, guys, sometimes in the data set, you have empty values like age, example, or salary. Suppose there are 4 data points or rows and 2 salaries. You can either take the average of data point number 1, data point number 2 and add. But I am going to ask you all a simple question. Out of 7,000 plus rows, 11 rows are empty. Is it worth the effort of adding extra resource and computation for just these 11? Tell me, if 7,000 rows exist and 200 rows are missing, can I think about? Yes, listen to me. Just because a technique exists doesn't mean you have to use it every single time. Okay, this is just a small advice I'm giving you. Remember, if you have a lot of missing values, rather than doing average imputation, go ahead and use something called KNN imputer. This one is a much better way of handling things. Okay, this is a better way of handling imputation rather than the average or the mean imputation. Okay, are we clear? So imputation will basically take these two values and come up with the new values for the data set. Okay. So now, currently, we have made sure that none of the values in our data is missing. Everything is done. Now, guys, tell me, can any of you tell me how and what columns in this particular data set are important for my analysis? Which column would be important for me to use for the analysis and which column will not be important for me? Can we get that idea? Right? So from our analysis, from a basic perspective, I think gender is an important criteria, right? I can say maybe, I don't know, tenure is an important criteria, but tell me, if you are not somebody from the business domain, if you don't come from a telecommunication domain or anything where the data comes from, is it easy for a data scientist to understand the business first and then understand the data? No. In this case, guys, there is a technique called recursive feature elimination. Okay. What recursive feature elimination does, my people, is it's a technique of identifying which column or which data point is important and giving more information to the prediction of the churn. Meaning, to get my prediction, which is churn, or to get the idea of what data or what column holds more importance within the entire data set. Okay, to understand that, it's a technique for feature engineering to replace or remove unnecessary columns and to only select the important columns. So today I'm going to teach you something called recursive feature elimination. However, let me tell you that decision tree, random forest, recursive feature elimination, okay, there are so many different techniques in order to understand, including chi-square analysis, including test of independence, including, I think there is something called FTE, which I don't remember the full name. There are multiple different techniques for you to identify which. ANOVA is also something that you can use, but ANOVA is to be used in a very careful way, because if it's a multivariate analysis, then you should use MANCOVA, okay, directly, not ANOVA, maybe MANOVA or MANCOVA directly, okay. So the best technique that you can implement blindly and it will give you good result is a technique called recursive feature elimination, okay. Now let's say, sir, I want to understand how do I implement recursive feature elimination, okay. If you want to talk about dealing with data set, okay, and if I want to specifically talk about dealing with our kind of data, right, or any other kind of data that you don't know how to work on, RFE is always the best sort of technique to understand in the very beginning what data set is important. So what do? We will take all the numerical features in our data. So tell me guys, in our data set, which is here, how many data points are numerical in nature? So ignore numerical, but yeah. Sir, can we apply this to the whole thing? Yes, you can apply recursive feature elimination to any data. You have no restrictions on what kind of data RFE cannot be applied. RFE can be applied on any data. It's just make sure that the data size is sort of large. You gotta make sure that the data set size are larger. Only under those conditions it will be important. So guys, in order to predict, let's say, in order to get my prediction on churn, according to me, gender is an important factor. I think gender is going to have some effect towards identifying whether, how to define whether the data side is larger. Ankit, if a data set size is 1000, do you think you can run machine? If you want to predict whether the customer will stay with you and not stay with you, 1000 data points is nothing. It means nothing. How to determine what data set size is enough or important? It depends on your company's management also. If you have 1000 data point and your company's management is like, it's okay, we are ready to test it on our customers. But if your company has high restrictions that no, at least make sure that the machine learning algorithm has enough data points or enough data sets, because the production tool or the software that we are building is a customer facing tool. We don't want to make a fool out of ourselves. So deciding what dataset size is enough, according to my experience, I do not prefer using, I don't prefer using any dataset size which is lesser than 25,000 guys. Like frankly, as per my experience, if your dataset size is 25,000 and more, you can make the algorithm customer centric. If it is lesser than 25, I personally don't prefer you go ahead with the production. Like at least 25,000 and larger is enough sample size for me to validate and say something. If it is less than 25,000, I personally have not gone into writing a machine learning algorithm in production or any customer centric algorithm without having a large data set size. So yeah, man, I mean, it will depend on your company's risk appetite, but I personally don't think you should go for a lesser sample size. Like people think that, sir, I have a 12,000 data set size. It's nothing. It's nothing. It's peanuts. What data you could have collected, right? Like imagine if you have a data set size of 1 lakh customers, right? Or 100,000 customers. This is the data. If you say 10,000 data points, 2,000 data points, you can only play with the data, but it's not ready for production. Like if you want to build it and have customers experience something, I don't personally think that's a. So guys, I think gender is one variable that I am interested in taking. So let me show up df.columns. Give me 1 second. Let me copy this. Let me paste it here. So I am going to take for my churn analysis, I think gender is one thing that I want. I can also say senior citizen is important. I will also prefer senior citizen. Okay, let me copy this and let me paste it here. partner or not does not matter, dependent does not matter, tenure will matter, right? How longer has this person availed the services? We can online backup, whether it exists, does not exist. I don't think so. It has. If you recommend, let's take online backup also, but it does not make sense to me. Yeah, whether that person had any tech support in the past or not, I think we can do that also, right? We can also take something like monthly charges. I think monthly charges make sense. So let me copy this. Let me paste monthly charges also. Let's take how many dependents there were. I think this also makes sense. Okay, this is also fine. I can also take phone service. Yeah, I can take total charges also. Makes sense. Let me add total charges. What else makes sense, guys? Tech support I've taken, contract I have taken. I think paperless billing also we can take. Let's take paperless billing also. Let me copy this. Let me paste it here. Do you think anything else can be taken? Payment method. What about no, customer ID has no importance at all. It makes no sense. So let's say payment method, right? Let me add payment method. I think this is good enough for me to start my recursive feature elimination. Guys, I could have taken the entire data set also. I could have taken just the entire data set end to end also. But here is the idea. Sometimes when you're working in the organization, you also sometimes know which columns are important, which columns are not important. Okay. So you can either select the way I have done it, or either you can apply to the whole thing. But please remember, if you apply any unnecessary techniques, it will take time and it will take resource. Agree, disagree? Meaning, applying on the entire data set will require CPU resources, time, energy, effort. You can also know that you can select some of the ideas that according to you, which one works best, and you can take both of them. Clear? So according to me, I have taken some potential candidates that I personally think that these could be the candidates. So this is how we actually work in real. I mean, analyze the columns manually. Yes, we do. Because I'm not sure if all of you know this or not, but your company has a tool called data warehouse. Are you aware? You have a tool called data warehouse. Guys, if you work in any organization like I am working, they take unnecessary data for the entire history. Suppose if I want to take the employee data, they will take your age, name, email ID, phone number, blood group, previous company, previous work experience, and all of that. Because they might use this data some other day. So tell me, if I am foolish enough to load the entire data from data warehouse and run recursive feature elimination, is that going to make sense? Think about it. When you run your SQL query, right, doesn't sometimes when you combine two tables, you get this table's data also, this table also? Have you ever combined two tables? Like when you write a SQL query, sometimes you have to do an inner join. So it doesn't make sense to take all, right? So sometimes when you're working on a data set, sometimes you also know what could be my potential candidate. See, I'm not saying that you cannot do it. You can do it, but it is going to be a very expensive operation, meaning you have to wait for a couple of minutes for the RFE to run and tell you which columns are important. Rather than that, can I help the algorithm or the technique by selecting some potential candidate? Once again, you can take all the columns. No. But I am doing the smart thing and taking some potential candidates that could help me predict the churn, which is these values. Do you want me to add any other values in this? I will add. Are we clear? So guys, once this particular numerical features or the features that I want my recursive feature elimination to take. So first of all, see, I am not going to go too in depth about what RFE does. It's a completely different technique altogether. I'm not going to call this algorithm because it's not algorithm. It's more of a technique. See guys, what recursive feature elimination does is recursive, meaning it repeats itself until there is a base condition to stop it. Correct? Okay. So you guys know what recursion is, right? What a recursion is. Like if you calculate a Fibonacci sequence, You know, right? You can calculate the the recursion tree until there is a baseline condition, like how much or where do you want to stop the Fibonacci sequence, because it keeps implementing something called as a deep hidden recursion. Okay, where you get the problem of stack overflow or over buffer flow, right? Recursive feature elimination, what it does is it calls itself again and again, okay? When each and individual features are eliminated, not required features are eliminated. In a simple plain English, if you give it 4 features, it tries to tell you that feature 1 and feature 2 are important, rest are not important. This is the job of a recursive feature elimination, okay? It it will tell you which columns are not critical for your analysis and you can ignore. It will give you an array, it will give you a list. You can decide whether to choose it, ignore it, or take it. It's up to you. So I have taken these features. Now, what do I want to do? For in numerical feature, NUMERI, okay, numerical features, if df of dot type is equal to object, what does this piece of code mean? I am looping through this entire array, taking the key of gender, senior citizen, tenure, online backup one by one, correct? First, I am picking up gender, then I'm picking up senior citizen, then I'm picking up tenure, then online backup, and I'm checking in the data frame that if it's data type, it's object, what do I do? df of call is equal to p factorize. Have you ever worked with a method called factorize? df of call, and inside this tuple value, I'm going to take the first value. Okay. So let me explain the concept of what does dot factorize do. Guys, if I want to work on pandas or working while in pandas, okay, what would my best option be? Like, what is my best option be to convert thing? Can I convert the data type of something in pandas? Is it like a feature that I get? Like pandas does not let you unnecessary worry about anything. It will always have a function to change something in the data set. Now, sir, what do you mean by factorize? See, it will convert anything which is categorical value to a string value. For example, okay, let's say, okay, let me take another bracket, right? So let's say if I have a value of say yes and no, true and false, maybe not maybe, and if I convert them into say some kind of a value, okay? So let's say if I have a value like this, right? Okay, label, comma, val is equal to pd dot factorize, and inside this, if I pass in things like this, right? Yes, comma, no, comma, yes, comma, yes, comma, no. And if I run this piece of code and print the label and print the value and run this, what do you see here? In the pd dot factorize part, did it first convert the yeses and the nos into numbers like zeros and basically label is added to a given string value, okay? Even after giving the string value, I am also able to get the value itself, which is yeses and nos were present. So if I say yes, no, and maybe, example, maybe, comma, maybe, comma, no, example, comma, no. So what will happen now? See, there are 3 labels, right? Yes label, no label, and maybe label. So it also gave me the label that, hey, you have given, okay, so no needs to be capital, sorry, yeah, factorize does not do this. So there are 3 label, yes label, no label, maybe label, and each individual label is given its own label index or a label ID, like what a label encoding. So if I want to do label encoding specifically on the entire column, I would have had to write a longer code. But if I just factorize it and let it run real time on each row, then my problem is sorted. Basically, this is a step towards optimization in the code. I don't want you to give me everything at once. I want you to go through it one at a time. So tell me, if I take 0, is it going to give me just the label part of it, which is the zeros and ones? I don't need the yeses and the no and the maybe, because I know I have the original data. I don't want you to tell me unnecessary that. So 0th index will give me the first values because they need to be converted into numerical factor, numerical values. Yes or no, everybody? Okay, so tell me, now that you understood the concept of factorize, sir, after I have converted every feature, okay, every feature into numeric, or every categorical feature into numeric, I need to make sure that every feature is available in the data frame for my access to one. Okay, so numerical to feature, sir, can we use pd.toNumeric? No. This is the problem with pd.toNumeric. What is the problem, everyone? Let's look at the documentation. What does pd.toNumeric does? It will convert an argument into a numeric type. It will return a default d type of either float or int. Now, am I dealing not with number precision, but just labels? Meaning, I don't want you to give me precision based answers or conversions. I just want you to give me simple plain labels. In our program, did I use this concept called dot map? Right here. But when the total charges was a continuous variable data, it had $1, $26, $18, $19, $26. I wanted that to be converted into float type D, which is D type float. But simply, if I only want to convert them into labels, pd.numeric is not going to got the concept. Okay. Now, my people, if I run the same particular code, numerical features, which is this particular data, I want to make sure, okay, I'm going to write down this piece of code, f for f in numerical features, if f dot, or sorry, f in df dot columns. Okay. What am I doing here, everyone? Just take a good look at this piece of code, this line. And what do you think I'm doing? Numerical features is equal to f for f in numerical features, if f in df dot columns. What am I doing? The features that I just conveniently converted into numbers, I need to check whether all of those features are still available in all my entire original data set, correct? To validate, to check whether I have made a mistake, is anything in my original data changed or not changed, correct? I am keeping the same name, numerical features and numerical features. Because I did an operation of changing the original data, I want to still check if something has been missed or not, correct? The original data is still the original data, making sure that every single feature is available in my original data set, which is df.column. So am I just checking that every particular thing like gender, senior citizen, tenure, online backup, tech support, all of these are still found in my data? This step is called validation step, correct? This is a simple validation check. Just a simple validation check. Agree, disagree? Okay, that's great. So guys, I have taken all this particular data, which is converted them into numerical. So tell me, X variable here will be df of numerical features. I am saying that, can you please check all the candidate features that I have chosen for recursive feature elimination and check them against a Y variable called df of churn? Agree, disagree? To predict churn, out of these many features, which feature is holding more importance and the other holding lesser importance? Agree, disagree? Am I making sense? Okay, good. Now guys, listen to me carefully. Sir, to to understand which feature is important for me, I would love to come to this place, which is here. See here, I have imported all the libraries, correct? That I will be using in the way my codes are written. What I want you to do is import two things. Number one would be from sklearn dot. The first thing you need to do is a submodule called feature selection. Okay, sklearn dot feature selection and import something called RFE. So I am going to write down capital R and F and E. So recursive feature elimination. The first thing I want to draw and call is recursive feature elimination. I am also going to be importing something called from sklearn dot, because I have to use a model or an algorithm to use recursive feature elimination, I will import something called random forest classifier. Okay, random forest classifier. I'm going to run these both and I'm going to come towards my bottom. Sir, what I have done is I have used two different algorithms or called two different algorithms called random forest classifier, and I have used something called recursive feature elimination. Sir, what does ensemble mean? Okay. Did you guys learn random forest and decision tree before coming to this? Okay. When you use one algorithm, your one algorithm is responsible for the prediction in the future, correct? When you combine multiple different learners to combine the prediction, this is called ensemble learning, right? Multiple weak learners can be combined together to form one strong learner. This is called ensemble. In random forest, don't you build multiple different trees and combine the trees together to predict the output? So this is an ensemble model. I hope you guys were taught this concept. Were you not taught this concept, guys, before you? So first, what I'm going to do, I'm going to take a variable called RF. So this is to RFE, recursive feature elimination. Okay. I'm going to take a variable called RF is first what I'm going to call my people is a random forest classifier. Okay. So first what I'm going to do, I'm going to call random forest classifier and I'm going to pass in a variable called n estimator is equals to 100. What do you mean by n estimator equals to 100? I want my random forest to create 100 trees in order to run this particular algorithm called RF. And I'm going to pass something called random state equals to 42 or maybe 43 or whatever you want to call. It's okay. Number of estimators will tell you how many codes will be created. If you do not mention number of estimators in the program, by default, how many trees will be created in random forest? Automatically 100 is anyways created. So can I say 100? Can I say 120 everyone? Because by default also 100 trees are created whether you mention or not. But I mention number of estimators equals to 120 because it makes my code very, very clear. Shiv Shankar will know how many trees he specifically created, correct? So I don't know, right? So this is a good practice of writing a. Are we clear, everyone? This is a good coding practice, a good programming practice to specifically mention the argument and its value. Okay, now that we've understood, sir, RFE is equal to recursive feature elimination equals to, I'm going to call something called RFE. Inside the RFE, guys, you have to pass two different variables. One is the estimator. Estimator meaning which algorithm do you want to use for the recursive feature elimination to make a decision on? Can I say random forest? Recursive feature elimination cannot work without a baseline algorithm. If you don't give it an algorithm to work on, it cannot work automatically on it by itself. Are we clear? Are we? N underscore features to select equals to 5. Now you can ask me one question. Okay. Sir, what do you mean by n features to select equals to 5? What does it mean? Guys, since Python is more English oriented programming language, according to you guys, what do you mean n features to select would What do you mean by this? You are telling recursive feature elimination that, hey, can you please tell me the top 5 features that are the reason why my algorithm is working or will work in the best possible way? Are we clear? If you mention the top 5 feature elimination or whatever, this top n features to select equals to 10, it will tell you 10. Please remember, don't go beyond the features that you've already given. So tell me the number of features you have to give me which are important will be 5. Are we? So now, if I want to run my program, I want to get the features, right? SELECTED underscore FEATURES, selected features equals. I am going to write a list comprehension code. I want you guys to tell me if this makes sense to you or not, okay? In Python, you can write a list comprehension code, and whatever code I'm writing right now will make a lot of sense to you in a second, okay? Feature for feature in or rather than this, can I do this? Okay, so let me take it like this, right? So feature for feature comma selected variable SELECTED SELECTED. Okay, so I for I comma variable, if I zip the values, so I should be able to get it, right? Give me 1 second. RFE, what do I have? I have a parameter like that. So what is the parameter? The parameter is called support. Okay. The mask of selected features. So number of features is this. This is fine. Then I fit the model and I get the ranking. What is the parameter like? So there is something called support underscore. Okay. Okay. All right. Feature for feature comma selected in zip. I'm going to zip two things. One will be the numerical features that I have passed. Other will be the recursive feature elimination. It prints something called as the support part. Inside this, only if it is a part of selected group. So SELECTED. Can you make a judgment or a guess what this list comprehension code is doing? Okay, so I can make this job a little bit more easier for you. If I say print F double quotes of, okay, SELECTED selected underscore FEATURES features by recursive feature elimination will be, it will be selectors. What do you think this code ID, sorry, if selected? I'm checking the condition if it is available in the selection. Okay. Is it going to give and print all the selected features that I or my recursive feature elimination code is running? Agree? All important features that were given in my problem or given in this data set, it will print that, but it will not print unless you do rf.fit and pass in the value of x and y, correct? Because in machine learning, for any algorithm or technique to run, you need to pass, right? Hey, can you please go ahead and print it, or as in run the algorithm? So dot fit means you have to, right? If I want to separate my code, importances or all the important codes, pd.data frame, okay, inside the pd.data frame, pd.data frame, what I'm going to do, I'm going to first, to make sure it is visible to you in a nice way, I will take a feature and pass all the numerical features that I have taken in the data set and the importance that feature hold. Importance, I'm going to pass in something called rf dot feature importances. Can you see here? This is already available by the module itself. I don't need to print it. You just need to mention rf.feature importances and it will give you that particular answer automatically. You don't have to worry about it. But you need to sort them in the ascending order, or sorry, in the descending order. You need to make sure that the highest one is at the top and the lowest one is at the bottom. So if I take importances, which is the same exact value, and say importances, which is the same particular value dot sort value, in Python we have a function called sort values. Inside this, I want to sort it on the based on importance. only and only on the basis of importance I want to sort them, and I want to say that the ascending value that you usually take, right, ASCENDING should be equal to false. What have I done here in this two pieces of code? What have I done here? Whatever answer my recursive feature elimination is giving me, this code is gonna give me. Am I going to run this code and give me the answer? What did I do? Did I make a mistake somewhere? RFE object has no attribute support. Did I take it correctly? Wait. There is support underscore, right? Have I taken the right spelling? Give me 1 second. Recursive feature elimination. Okay. So feature for feature, I have taken I for I comma X, which is this particular value. In zip, I have taken the zip variable, I have passed in the numerical features properly, and I have also done this. Let me comment this out first. Let me run this. I'm going to get the same error. So I for I comma X in zip of, I'm taking both the numerical features, which is correct. Is the spelling correct? Yeah, numerical features and recursive feature elimination dot support if selected. So if it is selected, let the whole code run. Wait, let me get this understanding correct, which is recursive feature elimination. Okay, so wait, let me uncomment this part. Let me run the estimators. Okay, uncomment this and let me see if I get this value. Support. I think maybe I'm taking it wrong. Recursive feature elimination. Recursive feature elimination. sklearn. support underscore. How do we use it? Right? Let's see if there is a code that can help me write it. Okay. So recursive feature elimination control F support underscore support. No, it does not have support. Let's look at the documentation very quickly. So recursive feature underscore F support so selector dot support. Okay, so if I fit the variable, oh, okay, I understand. Sorry, I need to fit it first, right? Oh, okay. I understand. I understand. Okay, because if the fit has not happened, then how do we run it? Okay, I understand. So wait, RFE dot fit, right? So wait, what is the sequence of order? I have given the RFE part. The selector will take the X and Y value, then the support value will be proven or given. So RFE dot fit, and inside the fit part, I will pass in the same exact value of X comma Y. Because it has not fit the value, it is not able to identify. Okay, I understand it now. Okay, got it. So now if I say I for I comma X in zip of numerical feature, get the support value if selected. And of course, it will give you the mask value of 0 and 1, which is fine. So if I fit it, run this once again, and let me do the same exact thing. Then I'm fitting the random forest model. That is correct. So RFE is fit, random forest is fit, my importances are fit. Once they are fit, but give me 1 second. If I take the mask of support, which is the true, false, which is masked as 164, whatever the values are, then pass it directly to the code. Okay, so wait, I can take it like this, right? So I will be here. So I for I, Z I for I, and X in zip. So zip will give me an array which is going to be passed. Okay, this is fine. I have run the importances. Now let me go ahead and run importances and run this. Okay, so out of all particular features that I have passed, including gender, senior citizen, tenure, online backup, tech support, monthly charges, dependence, total charges, paperless billing, and payment method, which feature is the recursive feature elimination saying is an important feature? Is it saying that tenure, tech support, monthly charges, total charges, and payment methods are important? Are you understanding what I'm trying to say? So what it did is it said that out of all specific values from all the potential candidates that you've taken, the most important ones are going to be the importance ones. So basically, I have sort of segregated them in, but I think we can also visualize it, right? Like I think we should do a plot to understand what this code does to get an idea. So wait, if I give me 1 second, guys, plot dot figure, and inside this, if I pass figure size is equal to 8,8. So if I want to plot and get an, okay, but if I want to do that, then I have to take importance. So how do I do that? I think I can do this, right? So wait, import Seaborn as SNS because I already have a bar plot available in Seaborn. So if I plot the value here, so if I can say SNS dot bar plot, and in how do I do SNS dot bar plot? Inside the bar plot, what was it? I have to pass in the X and Y separately, I'm assuming, right? X and Y are passed separately. Okay. So if I say SNS dot bar plot, X will be equal to importance, which is correct. And my Y variable that I want to plot is going to be my feature. And the data that I want to pass is the importances because this is just the data that I want to plot. Once this is done, I want to give it some title. So let's give it a title of feature importance, and yeah, I think this is more than enough. This is, I think, pretty enough. Give me 1 second, guys. Let it print the answer. Tenure. Okay. All right. Wait. Oh, I got it. Did I take it a little bigger? Okay. So tell me, guys, as per the feature importance calculated by the recursive feature eliminator or the recursive feature elimination algorithm, which is the least important feature in the entire data set that has shown any effect? It is the senior citizen part, then dependent, then gender, then online backup. So if I select the top five, 1, 2, 3, 4, 5, I have total charges, monthly charges, tenure, payment method, and tech support. Now, guys, think for 2 seconds and tell me, are the features making sense for somebody to take a decision whether you want to stay with the company or not? So tell me, how much money you have charged me for the service? That's an important factor. What is the overall monthly charges? That's an important factor. The overall tenure of the customer, the payment method, and the. Now tell me, if I go to the payment method part in the very beginning of this particular example, so see, payment method is electronic check and mailed check, meaning how did I make the payment happen? What kind of payment, what kind of source of the payment was? Depending on the data that we have passed to the recursive feature eliminator, these are the 5 top variables or values it is giving me as the answer. So these are the 5 variables or values that are important for my. If I would have said that the number of important features in my code would have been, I don't know, if the number of important features to select would be 10, I could have taken for 10. But can you see, I have gotten all the values, total charges, monthly charges, tenure, payment, tech support. I have only printed 5, but can I? Because apparently each and everyone has some, but I will still stick with the 5 values. So did I get the answer, guys? That preferred or prefer going through all these 5 values. Are we clear until here? See, here is the thing, right? See, recursive feature elimination, right? Okay, so in the most simplistic of the sense, let me tell you, see what happens is in recursive feature elimination, right? It will try to understand with the help of some algorithm, any classifier you can use, not just random forest. You can use a couple of other classifiers also. Based on that, what it does, it calculates something called feature importance. It has its internal way of calculating feature importance. If I use random forest, then it will use multiple different trees to calculate the importance of the feature depending on how your tree has been split, okay, or how many of those features were used in the creation of those trees. And then what happens, one by one, the unimportant features it will remove from the analysis, and it will repeat this exercise multiple times. And then out of multiple different says, where multiple people say that gender is not important, gender is not important, gender is not important, it will remove gender. So basically what happens is it will have a feature importance calculation to understand what features are important, and if the says about the importance are not available, or it doesn't add any value to that particular case, then it will say that that particular feature I don't need to keep because majority of the people are saying that it is not important, so it will not add it. Okay, sir, can RFE is used in, okay, RFE is used in the case of categorical target variable? Okay, so see, here is the thing, recursive feature elimination can be used for both classification and regression problem. Okay, it's not just that the RFE is only restricted to continuous variable, categorical variable and not continuous variable. That's not the scene. RFE is built in such a way that depending on the baseliner that you've used, in our case we've used a random forest, it can be used for regression also. It's just that when you use for regression, can you use a random forest classifier when you want to use it for regression? No, you can't do that, right? And I think all of you know that random forest algorithm is not just used for classification, it can also be used for regression. You guys are aware, right, that random forest is not just a classifier model, it can also be used for regression. At the same time, random forest can also be used to calculate imputation. Random forest can also help you predict what is that empty values number should be. As in, if you want to do imputation, random forest can also do that, right? Like it can also be used for that. So if you rather use a regression model to calculate it, congratulations, you got it, right? But guys, very simply speaking, what I tried to show you in this particular program is I first took the numerical features which I have taken, the potential candidate. I converted them into proper numerical variables, which is labels. I made sure to validate if everything still exists, no changes have occurred. X and Y is going to be my numerical features run against the churn. I have to implement a baseliner or a baseline model or a model that a recursive feature elimination uses. I used random forest classifier. And then I did a recursive feature elimination. Of course, you need to do a fit before you run anything. In the selected features, I ran a list comprehension model for me to filter out the support within the numerical features. And once the support are calculated, I want to filter out and print all those selected features, which is this. Selected features by RFE is tenure, tech support, monthly charges, total charges, and payment method. Please observe that when I wrote this list comprehension, I have not given any argument called sort. Because I did not give anything called sort, I also got my answer called tenure, tech support, monthly charges, total charges, and payment method crisscross, right? Because total charges is the most important one, I did not get total charges as the first variable here. So when I did this list comprehension, there is no way of sorting it because I'm just printing the importance based on this module or a method called support. Support will give me what variables exist, because I wanted to tell you guys that you can still print which method or which feature is important. So what did I do here? I took all the values in the data frame. I took their feature importances, which is another method. I made them sort and then I plotted them again. So this piece of code, my people, is going to give you the idea about what features are important in my data, and I get the idea. Agree, disagree? So I now know which features I'm supposed to take for my algorithms to be built. So now, my people, we can start building our model. Start BUIL building our model. But guys, do you remember in the beginning of the class, majority of you were confused about something? The confusion was, sir, how many hidden layers am I supposed? How many hidden layers should I take? What is the best way of identifying the hidden layers? Because majority of you had the curiosity that, sir, when I write a neural network, you did not teach us how many or how to add one hidden layer with second hidden layer with third hidden layer and then an output layer. First of all, you did not teach us this. You also did not teach us how to identify which particular hidden layer should have how many nodes or how many hidden layers I'm supposed to take. Like I said in the beginning of this class, I am going to teach you how to program this neural network, including, okay, instead of selecting, wait, somebody asked me a question. Instead of selecting the initial headings, can't we just give everything and let it select the most important for us? Yes. So Moses, you are right. Absolutely correct. But I also gave you the idea in the beginning of the class, Moses, that what happens is, if you take the entire operation of data, you got to understand one thing, okay? Okay, so Shiv Shankar Gupta and Samrat. I got the concept, my dear. I got the question. I 100% got it. I will explain you what zip is and I will explain you what RFE.sub. When you build any model in your career or as somebody who's learning data science, right? You got to understand there are two kind of effort. Effort number 1 and effort number 2. Okay. What is effort number 1? Effort number 1 would be exploratory data analysis. Effort number 2 would be fine tuning. Effort number 1 could be hyperparameter tuning. Effort number 2 would be writing efficient APIs, making sure that the predictions of your model are as fast as possible. Now tell me one thing, and I want all of you to listen to me. When you do exploratory data analysis, will the customer have to wait when the customer gives the data? Does the customer has to wait because your program will do EDA in the production? No. Your exploratory data analysis, your hyperparameter tuning, your fine tuning is something you do when you are building the model, correct? To identify which model is my best model. Am I making sense? Once you know the best model, this model will be used by the customer. So you have to understand one thing. Both in effort 1 and effort 2, you should write programs that are optimized. Just because you have time to do EDA, fine tuning, hyperparameter tuning doesn't mean you try every single thing. In my program, Moses, I told you in the beginning of the class that yes, you can take the entire numerical features as the input itself. Let me give you an idea. Give me 1 second, okay? Copy and paste. Give me 1 second. Give me 1 second. So Moses, tell me, have I taken all the variables? Yes. Will everybody agree that I have taken every single variable that was given to my data? Instead of taking any potential candidate, I'm taking this. Now, can you please observe the time it's going to take for my model to run? Give me 1 second. Import something called time. So guys, if you want to measure how long did it take for the model to learn or this particular cell to run, can I say start is equal to time.time and end is equal to time.time. Okay. Time for time taken for the entire cell to run is going end minus start. Okay. I'm going to run this program and I want you to understand one thing. Array, I have imported time. No. Where did it go? Sorry. Where did it go? Where did it go? Where did it go? Import time. Where did I import time? Import time. Oops. Sorry. Import time. Close this and time. Give it a second. Just give me 1 second. Let the whole code run. Okay. So the time taken for the entire cell to run for the entire data is 11 seconds. In my data set, what's the overall data set size? The overall data set size is 7043 rows. For 7043 rows, for every single column, including this customer ID, which makes no sense, it took 11 seconds. Now, my question to all of you is, if you work with a data set of 40,000 rows, 50,000 rows, 80,000 rows with 70 columns, 40 columns, 23 columns, do you know how much time it's going to take for the entire analysis to run? Okay. I also made one mistake. Churn should be removed, right, from the entire data, because churn is my target. I have also taken churn is the Y. So churn should be removed, no, because churn with churn will be 100% accurate, no. See, churn with the churn will be 100% accurate, meaning it matches. Churn with churn is like 100% matching. We don't want that. Let me remove churn and run again. Okay. Just for your understanding, okay, just give me a couple of seconds. It will run. It's still running. 25 seconds for 7,000 rows, all the way for these many columns. Are you understanding now why did we end up taking potential candidates? Because sometimes when you know the business, you know for a fact that not everything is important. But still, since Moses' question was very good, what answer did we get, everybody? Customer ID, tenure, contract, monthly charges, and total charges. Let me tell you one thing right now, guys. What ID you have, or what is your ID, is that going to be important for my analysis? No, it cannot be. So tell me, when I included all my data, did unnecessary garbage value, including customer ID, came into picture? It did. Yes, no? That is why it is important for us to be smart about it. And first, on or as per the business, select the variables or values which are important as per the business. So did you now get it why we have not taken everything? Because taking everything is not the intention. The intention as a data scientist should be to first understand what variables according to me make sense. So tell me one thing, can I remove customer ID? Makes no sense. I can keep gender, I can keep senior citizen. Do I need partner? Absolutely not. Dependents? Absolutely not. I don't need this particular variable. Tenure? I did not need phone services, multiple lines, internet services. This also was not important. Online security, online backup, device protection, tech support was important. I have taken it. Right? Listen to me carefully. I have taken this, taken this, taken this. I don't need, if we are getting streaming movies, streaming TV, I can remove this as well. I don't need, okay, let's keep contract. Okay, contract seems important. Paperless billing, payment method, monthly charges. If I run this now, give it a second, give me 20, 30 more seconds. Now it will give me some answers. Give me 1 second. So did it give me the answer? The one that we had? Everybody got it? So I ran the code for you, showed you the example. The answers are much faster. Good. Now, let me go back to some basic Python guys are asking me, so I will be teaching them. Okay. Let me put up a cell called basic Python programs. Python program. You're welcome, my dear. Guys, in Python, I have an operation called fname is equal to my first name is equal to Rudra. R-U-D-R-A. R-U-D-R-A. Rudra. Okay. Let's say the other name is, let's search for some names, right? Shiv. Let's say Gerin, right? Gerin. Or let me say Grace. Okay. And the will be, my surname is Sharma, Sharma. Shiv is going to be Kumar, and Grace is Matthew. Okay. Now, if I want to combine my F name with L name, okay, I want the output, Name. Okay, I want my output to look like this. Rudra should match with Sharma, Shiv should match with Kumar, and Grace should match with Matthew. So can I do zip of L name comma F or F name comma L name? But if I run this, I will get a item which says zip is available at this location. You got to unzip it, or basically you got to open that up. So you can mention a data structure called list. What about now? Are you able to map index 1 of array 1 to index 1 of array 2, index 2 of array 1 to index 2 of array 2, index 3 of array 1 to index, and list, or sorry, zip can take n number of arrays. So for example, I will add another array is equal to 1 comma 2 comma 3, and if I pass in comma array, do you see all the array got added? Rudra Sharma with 1 got added, Shiv Kumar with 2 got added, and Grace Matthew with 3 got added. Yes or right? So this is what zip does. But I have a small question, guys. Since you guys are asking me basic questions like what does zip do, how good up your Python game? Because I think the second or third class in Intellipaat, they must have taught you what is zip, what is map, what is sorted. Are you understanding what I'm so see, the reason I'm saying this is because when you write your Python, right? For example, okay, I'll give you a simple example, okay? Suppose you have an array is equal to Rudra, R-U-D-R-A. If you have an array called, or suppose if you have a number like this, 1, 2, 3, 4, 5. For I in array, print I. Okay? For I in array, print I. See, this is one way of looping. But if I want to square the array, can I do it like this? 1 square, 2 square, 3 square, 4 square, and 5 square. But rather than taking it like this, I square for I in array, I can also do this, right? Instead of writing a loop, which is a multi-liner loop, I can just write a list comprehension. I hope you guys are understanding what I'm trying to say. Guys, if this is the code that you're struggling with, I am very sure you must be struggling with, I don't know, this code also, right? Because the logic is not clear in your head. What kind of the functions and the code is running, right? Because see, isn't this code also something called my list comprehension? Got it? Sir, dot zip and dot map was not taught to us. When you taught us NumPy. Sir, we don't know what is zip and map. Oh, so I was the one. That's great. Okay. So you guys are confused about what a map function does, right? Like what a map or what a dot idea also. Okay. So let's take an example of map. So let's say, okay, if you want to use map in Python, what does map do? What would be the map function going to do? Is it going to map something with something? Example. So say, suppose, okay, suppose, let's take an example. Suppose if you have some kind of data like, let's say, car. Okay. What kind of car do you like? Benz. Okay. I like Mercedes Benz. I like Mahindra, right? I like Tata. I like Lamborghini. Okay. Oops. Let's say Lexus. It's easier to write. So let's say Lexus. And if I take another thing called the price of the car example. So if the price of the car is Benz is say, I don't know, 90 lakh rupees. Mahindra cars are usually 40 lakh rupees. Tata cars, you can get it for 12 lakhs also. And Lexus could be approximately 70 lakh rupees or 70, 80 lakh rupees. Example. If I want to map this, what could I do? Suppose if I want to map everything together, okay. So can I sort of map these values together? So suppose if I take a data frame is equal to df is equal to pd dot data frame, okay, data frame, and inside this data frame, sorry, f is supposed to be capital. In the pd dot data frame pass, I am passing the data. And if I print df, is this my data, everyone? the car and the... Now I want to map them, okay, with respect to the type of car they are. Example. So suppose type underscore car is equal to, so let's take another dictionary, and inside this, let's say Benz is a sports car. Mahindra is a car which is a normal hatchback, example, or XUV. It's an XUV type car, right? It's a UV. Okay. And let's say I want to say Tata, right? Tatas are usually hatchbacks. So let me copy them, let me paste it here. And let's say Tatas are usually hatchback, HATCH hatchback. And I want to map Lexus with a sports car. So let me copy this and let me paste it here. And let's say it's a, or maybe just for a simple person, let's say sedan, example, okay, for simplicity purposes. So what did I here? I already have a data called car and price, agree? And I already have a type of the car, that Benz is a sports car, Mahindra is an XUV, Tata is a hatchback, and this of this. If I take a new column called type, okay, type of the car is equal to, can I take df of data? Or if I don't want to take data directly, I can just take that, oh sorry, not data, directly from the df car dot map. What do I want to map it with? Do I want to map it with the type of the car? So type underscore car. What is this going to give me? If I run this piece of code and if I print my df again, what will this give me? Will this map my car variable or each individual value with the type? And I have printed that as a type. It's a sports car, SUV, hatchback. Did you get the logic what mapping does? Based on how you have passed the data, you can connect the variables one by one with the key pair value. That's all that map does. Did you, yeah, okay, good. So guys, now that you guys have built the particular recursive feature elimination variable where I have 5 features: tenure, contract, payment method, monthly charges, and total charges. To start building the model, what can I do? I already have the recursive feature elimination, that all of that is done. So can I say that my X variable or the feature that I'm going to be using for the machine learning model will be the selected features? Because these are my selected features that I got from the recursive feature elimination. These are my selected features. Look at this. My name of the variable is called selected features. After selected features, what will be my Y variable, guys? Will it not be df of churn? This is my X and this is my Y. So I need to split my data into X train data, X test data, Y train data, and Y. Everybody, I need to split my data into X train, X test, Y train, Y test. Agree? And to split it, we need to call something, right? We need to call something called train test split at the top. So if you want to import just the train test split part, you get it from the model selections package. From sklearn, when you do it from a model selection package, that's when you will be able to do something called train test split. So same way, from sklearn dot model selection, you are going to import something called as train test split. I'm going to run this. I'm going to come to the very bottom here and I'm going to import something called train test split. Now guys, while I implement train test split, what other things are you capable of doing in the train test split? Are you allowed to take a size of the data? Like for example, train test split, I'm going to pass the value of X, Y. Can I say test size of my data should be 20%? And just so your results and my results match, I'm going to also take a random state of 10, 20, 30, whatever you want. I'm taking random values here. Can I pass the values directly in the train test? As in, can I do the passing of the data directly? Look at this data. What else do I need to change in this? Is my data coming from multiple different ranges? Are there multiple different range within my data itself? If the data comes with multiple different ranges, what do? Do you import either standardization and normalization? You standardize the data. So what will I do? From sklearn dot pre-processing. Okay. What will I import? I'm going to import something called standard scaler. Sir, why am I importing standard scaler? Because in our example, the data distribution might be different, correct? To make sure they all come in the standard scale of the same number, I have to import something called standard scaler. So what do, my people, towards the bottom here? So can I say scalar, scalar? I want to take a name or a variable which would instigate or call the variable or call the method called scalar. Okay. So scalar is equal to, can I say standard scalar, everyone? Now my xtrain value, which is scaled, or scaled, scaled value should be what? Scalar dot scaler dot fit underscore transform. Agree, disagree? What I need to transform? My x underscore train value is what I need to fit transform. The same particular thing, x train scaled, you have to repeat the same thing for x test scaled would be x test. Agree, disagree? I have done, but in the scale part, should you fit? No, sir, when you scale the test data, you don't fit. Because at the time of testing, my test data would be used. So you have to remove the fit transform. Remember, only the training data gets scaled, not the testing learning, right? Now tell me one thing, guys. Once you do the scaling operation, suppose by mistake, my Jupyter notebook file's kernel dies. Do I have to do the scaling once again? Suppose if I close this Jupyter notebook and open it once again, do I have to waste my energy, time and resources to do the scaling once again? So in practical setting, guys, doing scalar operation, it's an expensive operation. Everyone will agree. If I do this scalar operation again and again, will that be expensive? Meaning I have to run the program once again. So rather than doing that, can I not save the scaled value somewhere? So I can name a variable called scaler.pkl. Whatever scalar values I have gotten, can I save it somewhere else so that I don't have to scale them again and again and again? So what am I doing here? Am I saving a file called scalar.pkl where all the values which are scaled using the standard scaler will be saved somewhere else? I don't need to scale them again and again and again. Once you scale them, I can save it somewhere else. In order for you to do that, you know what you need to do? You know what you need to do? In Python, there is a way of handling values or serialization. That is called pickle file. We call that particular operation as pickle, but I have not imported pickle, have I? In the operation that I want to import or work on, I have not imported anything called pickle. So can we go to the top? Here, right here at the very top. What can I import? Import a package called pickle and save it. Now tell me one thing. What am I doing? Once the scalar operation is done, am I trying to save it? So I will say pickle, P-I-C-K-L-E dot dump, D-U-M-P dump. What will you dump? The value of scalar, S-C-A-L-E-R, and it will be F because the name of the file you've taken it as F. Agree, disagree? This piece of code is going to save the scalar value, the scaled values to be used. Is every single person clear me? I taught you a concept that whenever you create a scalar based component or you create a standard scalar on both the X train data and the X test data, right? When you create this, it is important for you to save a pickle file because you do not want to create and run the program again and again. Because if I stop this Google Colab notebook, I have to essentially rerun the entire program to come to this stage. But what you can do is you can basically save the scalar component with this particular command And if you can see here, I have this file called scalar.pkl, which is a pickle file already created. Okay, so what I've essentially done, I have saved my quantities, which were the scaled values, in a separate pickle file. Now guys, let's start writing down our initial writing. Okay, so guys, to hyperparameter tune the model or to build a neural network, I need to tell the neural network that, hey, my input layers are not going to change and my output layer is not going to change. You are allowed to play only with the hidden layers. So the maximum you will be able to do is just change the hidden layers and play along with it. Please don't touch the input layer. Please don't touch the output layer. Why do we do this? The input layer is fixed because the goal of the project requires you to pass 5 features. Example, so the input layer will have 5 neurons or nodes. The output is a linear regression based output or a regression based output. So you only have one node. So you don't touch your input and you don't touch your output. Perfect. Okay. What I'm going to do, I'm going to write down a function called define create underscore model. Now guys, in Python, whenever you create a function, right, you are allowed to pass a parameter or an argument, specifically an argument, and I'm going to say hyperparameter is none. So what I've done here is I've written a small flag that says hyperparameter that I'm going to be passing will be none. If hyperparameter is found, meaning when somebody is calling this function. So before I teach you this function, let me tell you, in Python, when you define a function like add, right? So let's say define add of a comma b, right? And I can say return return and return a plus b. So how you consume this function or call this function is you define a variable called sm is equal to add, and inside the add you can pass the number 2 comma 3, and when you print sm the answer would be right there 5. I can also say something like this. F double quote of sum of a and b is a plus b. If I run this, if you can see the output, sum of 2 and 3 is 5. So basically when you call a function, you can pass in certain values inside these parameters and you can pass them while you call them. Okay, so keeping this concept in mind, what I'm going to be doing right now is I'm going to be creating, what did I say? Yeah, create model, right? Underscore model. And inside this, I'm taking the hyperparameter equals to none. What I've essentially done here is I have given a default flag. Flag meaning by default, this parameter will be none until and unless you change it. By default, it will remain none. Okay. Let me come over here and paste it. Yeah. So what I'm going to do is if hyperparameter argument is given by the user, if somebody does give the hyperparameter model, what I'm going to do before I implement a neural network of my choice, there are certain libraries that I need to make sure I import, right? Because right now I'm going to be teaching you a concept where multiple different neural network layers you can write. So in order to do that, what you need to do, you need to go back to your original import statements. And here we are going to import a couple of things. The first thing that we are going to import is, of course, import TensorFlow as TF, right? So we are going to import TensorFlow as TF. This is going to be the first import that I'm going to be making. The second import I need to make, okay, to make my answer as to be able to build a neural network is from TensorFlow dot Keras. I need to import two things, import layers and import model. Okay, actually models, not model. So from TensorFlow.Keras, I was able to import both layers and models. Because I want to do fine tuning, hyperparameter tuning, fine tuning is a different concept. If I want to do hyperparameter tuning, I will be using something called Keras underscore as KT. But the problem is, if you can see here, it's being highlighted in yellow. What it means is, you haven't imported or you don't have a Keras tuner available yet, or you haven't installed it yet. So what you need to do is go on Google and say pip install Keras tuner. And if you click on this, see, this is called pip install Keras tuner. If you do not have a package yet, what you need to do, just write down the package. It will give you the most recent distribution. Copy this, come over to the package, and here put a negative sign or a negate sign and do pip install Keras tuner. What it will do, it will start installing Keras tuner in your system. Now, if I run this particular thing, I have no error. Keras tuner and TensorFlow.keras are no longer yellow. It means in my bin, I have this particular package called Keras tuner. Okay. So what I've done right now is I've made sure I've imported every necessary library to make my job easier. Now, let me come back to my same program. What did I do? I said define create model. Yeah, that happens because distributions does not show up right there. If this still shows yellow to you, okay, what you can do is run them. If there is an error, like for example, I remove Keras S, the minute the module does not exist, it will throw an error. So don't worry, it sometimes so happens that in Jupyter Notebook or Colab, it will show you an yellow or a color which is yellow, but it will not cause much of a trouble there, okay? So if we come to the bottom here, I said if hyperparameter tuning or any kind of a hyperparameter is actually passed by the user that is going to call my function some other time, what I want you to do is I want you to create a model by itself. So I'm going to say model is equal to models.sequential. Perfect. Okay. So the beauty of Python is what you do right now is the minute you come to if hyperparameter tuning, right, just write the keyword called pass. Okay. Sir, why do you need to write pass? Because whatever I'm about to teach you right now is a little complicated logic. So rather, I would rather teach you the else statement first because that will make more sense. Okay. So guys, what I'm doing here is I am creating a neural network of my own. Okay. Network of my own with all the strict values. What do you mean by strict values? Saying that what will be my input layer, what will be my output layer, what will be my all sorts of layers. So basically writing down what would be your layers looking like, that is the output that you're showing. What I'm going to do is I'm going to write down a variable called model is equal to models dot sequential. Now, sir, why should we use this method called dot sequential? Remember, guys, whenever I taught you to write a neural network in the very first program, which is this program, and you wrote down a neural network that looked like this. Okay, that looked like this. Inputs equals to Keras dot input, x equals to layers dot dense, output equals to layers dot dense. The problem is in writing a code like this, writing simple neural networks is very, very easy. But if you want to add multiple layers, layer 1, layer 2, layer 3, layer 4, layer 5, layer 6, then writing it like this becomes very, very complicated. So to make sure you don't have to write like this and you can add as many layers as you want, we have a method in TensorFlow's Keras library, in both TensorFlow and Keras, called sequential. Sir, how do I use sequential? Very simple. Inside the models.sequentials part, come over, take a bracket and put a array sign or sort of put like a array. Now the first thing that you give this model is layers dot dense, D-E-N-S-E, dense. Inside this, write down 64 and say the activation is equal to ReLU. Okay, comma, input underscore shape. So if you can see here, input underscore shape is equal, inside a bracket, write down your x train scaled because you will be passing the training data inside the model, and I have taken the x train data right here. So what I've done is x train scaled dot shape and of 1. Now, before half of you start asking me what this 1 is, what this shape is, let me complete the program and I'm going to come to the program one by one. Okay, layers dot dense, and inside the dense I'm going to write 32 comma activation is equal to, let's say, the same activation ReLU. I'm going to come back here, layers dot dense once again, and inside this I'm going to write 16 comma activation is equal to ReLU. Again put a bracket here, and I'm going to say layers dot, I'm going to come back here and again say dense, I'm going to say 8 again comma activation function will again be equal to ReLU. Now outside, or my output layer will look like this, layers dot dense. Because I want only one output, I'm going to say 1, and activation function, because I want to do classification not regression, I'm going to call Sigmoid. Okay, Sigmoid. Now let me explain, sir, what is it that we have done in this particular code and how do we understand this code. So allow me to copy and take a screenshot of this particular code and paste it on our whiteboard and understand what we have done. So let me copy this here and let me paste it here. Is this particular code visible to everyone? Please let me know if you guys are able to see this well and clear. Let me expand this and make it incredibly larger. Okay, that's. Let's take the understanding, okay, of neural networks one by one. Okay, one by one. Let's say if you want to write a neural network with multiple layers, defining how many nodes you want in the layer, will you use the previous machine learning or the neural network code that I taught you, or will you use the one that I'm showing you right now? This one. Remember, it is always going to be this one, models.sequential. This is the one that you're going to use. Now, sir, what are we doing and how many layers have we taken? First of all, guys, my input data, okay, my input data has how many columns that I will be using as an input? Please look at this data. How many input column exist? 1, 2, 3, 4, and 5. There are 5 nodes that I am going to be taking. That's great. So tell me, when I passed the first layer, okay, everybody listen to me carefully. Sir, in neural networks, when I say I have an input layer, is it really a layer actually updated? Sir, can we actually call input as a layer? The answer is no. Input is just an input. It's not a layer. Layer starts with your hidden layer first. So the first hidden layer will be layer number 1. Are we clear? Technically speaking, your input layer is never considered as clear until here. In any technical library on the world, okay, you never take input layer as a layer. Input is just input. Layer number 1 starts with your input layer. Okay, now with this understanding very, very clear, guys, what have I done is, have I taken my first layer? Can you see the first layer? Layers dot. While mentioning layers, are you telling the neural network or TensorFlow that, hey, can you please create a layer for me? When you mention the keyword layers, you are basically telling the program, this is my layer. Agree? And when you say dense, you want a fully connected with what? With input. Agree? Because after input comes the first layer. Okay, that's great. How many neurons have you taken in this? 64. What are the activations on each individual neurons? So, note to every single person in this class. Notes to every single person in this class. Whenever you take hidden layers, the most frequently used, the most importantly used activation functions are ReLU and Tanh. That's great. The most frequently used activation layers in the feed forward network is going to be just ReLU and. So first of all, let's understand this. Sir, why are numbers looking like this? 64, 32, 16, 8, 1. Actually, 1 is output, we will ignore. Guys, let me ask you guys a question and please try to help understand what this particular thing. Have you seen a computer that started with an 8-bit computer, then a 16-bit computer, then now you have a 32-bit computer, then you have a 64-bit computer, you also go with 128? Okay, listen to me carefully. Sir, do I have to follow these numbers only? 64, 128, 64, 32, 16, 8, 1? The answer is no. You can take any number do you want. Are we clear? You can take any number you want. My answer is this. If I take a 128 layer input and a 64 layer input, will my output be completely different? Actually, no. After having multiple experimentations done on neural network, it has been identified that a small neural network and a very large neural network's accuracies are very close to each other. It's just that the larger neural network is able to understand the data even better. So, by that logic, sir, do I have to absolutely know like the God number, the perfect number to start with? Please remember, while building neural network, there is nothing called a perfect input layer or hidden layer with the perfect neuron size. The same neural network can be built with a 64 neuron and it can also be built with a 32 neuron. Your accuracies might be different, but you have to do trial and error and nobody can escape this. Am I making every single person understand? Do not waste your time or energy in perfecting. Sir, what would be the number? Sir, I think the perfect number God told me is 68, but you have taken 64. It does not. It will not matter. Your neural network is so capable, it will still understand the logic or the patterns hidden deep within the data. But to make my neural network better, I can take multiple different layers. Yes or no? To make the neural network deep, more the hidden layers I take, deeper the neural network becomes. Are we understanding? But sir, why have you taken 64, 32, 16, 8 and 1? Guys, it has been observed in the industry that whenever, Control Z, whenever somebody writes a simple neural network, they always start with a number like 64, 32, 16, 8 and 1. So here there are 5 layers. Everybody agrees that there are 5 layers here. Layer number 1, layer number 2, layer number 3, layer number 4 and layer number 5. Indeed there are 4 and indeed there are 5 layers. Sir, could I have taken 3 layers? Yes. Could I have taken 5 layers? Yes. We don't know which output is the optimal one until and unless you try every single permutation and combination. When two people get married to each other, try to understand my analogy, okay? If a person number 1 tries to rank the other person number 2 in 20 different criterias, this guy will never be able to find a partner, right? When you're so strict that I have to find the perfect partner, that perfect, you cannot do that, right? If you want to do that, then the person has to take the risk of trying out maybe 100 or 200 or 500 different partners. But in reality, you do not have the time or energy to go through so much hard work. Agree? So whatever samples, you can maybe give it a 5 try or 10 try. But whatever you get best in those 5 try, you consider that as the best aspect. Agree? That is exactly what we implement in the neural network. Your job is not to calculate the most optimum number. Put down a number, try it out, change some numbers, see which number works, keep that as your final neural network. Are you understanding? Do not waste your time or energy in perfecting the numbers. So always go with the sequence of 128, 64, 32, 16, 8 and 1. Are we clear until here, everyone? I'm going one by one. Okay, good. So tell me one thing. every single person can ask me one question. But sir, you haven't defined your input layer at all. I understand you say input layer is not a layer, but where is the input layer? Can you see I have told the first layer that my input will be here? The shape of my input will be X train scaled. My people, in Python, when you mention dot shape equals to 1, what does it return? It will tell the neural network that it will tell that my input is an array of size 5 and the values of those values are tenure, contract, payment, monthly and total. Are we understanding? What this X train scaled dot shape will return is all the 5 values in the shape of an array. So tell me, did you tell the neural network what my input shape is? And my first hidden layer will be of 64 neuron, and this is my first hidden layer. Agree, disagree? Then you tell your neural network that my second hidden layer is also a layer. I also want to fully connect it, but the number of neurons I want to give it this time is 30. The activation function that I want to give is ReLU. So this is my second layer. Yes or no? Agree, disagree? The numerical features. Okay. Copy and paste. Numerical features, right? So numerical underscore features dot shape of 1. Wait, what did I do? Oh, of course, I made one mistake. This is directly an array. I shouldn't have done that. Let me take this only, X train scaled. X train scaled, give me 1 second. I'll tell you directly from that. X underscore train underscore scaled. If I run this, do you see an array inside an 1 second? Yeah, shape returns rows comma column in it will be returned. Yeah, so it has to be multidimensional, but give me 1 second. Guys, do you see X train scaled in front of you? In front of you, like you guys are very, very well. Okay, 1 second. Okay. To make your life a little bit more easier, since you guys have some pretty basic Python questions, let me make your life a little bit more easier so that it doesn't become confusions anymore. Okay. Import numpy as np. Okay, as np, and import pandas as pd. Okay, give me 1 second. Imagine I have an array 1 example, an np.array, and inside this np.array 1, 2, 3, 4, 5 example. If I want to get the output or the shape of this particular array, can I say array1 dot? This will tell me how many elements exist inside the array. But please tell me, is this one dimensional or two dimensional array? Is this a 1D array or a 2D array? You guys tell me this. It's a 1D array. Okay, perfect. If I take array2 is equal to np.array, and inside this, if I take a 2D array, say 1, 2, 3, 4, 5, 6, example. If I say array2 dot shape, can somebody tell me what would the output look like? If I take a matrix that looks like this, give me 1 second. What will it look like? What shape of the matrix do you see in this? Is it not a 2 cross 3 matrix? So tell me, did I get the answer as 2 cross 3? Is it giving me 2 cross 3? Yes or no? If I take index 1, what does? So give me 1 second. This is 2 cross 3. From 2 cross 3, control Z, sorry. From this 2 cross 3 part, which is a row comma column, if I print 1, what does it return? Does it not return the row or the column? It returns the columns. No, not the row, guys. 2 is the number of rows. 1, 2, 3, 4, 5, 6. Row number 1, row number 2, column number 1, column number 2, column number 3. How many rows? 2 rows. How many columns? 3 columns. So when I did array dot shape, I got the answer as 2, 3. So row comes first, columns come later. When I say array dot shape of 1, what is it supposed to return? The columns, no or no? Now tell me, when you say return column, is it returning 1, 2, 3? Is it returning 1, 2 and 3, or is it just returning the number 3? Is it returning 1, 2, 3, or is it just returning the number 3? 3. Meaning, am I not telling the neural network that my input node will be of the size? In the neural network, in this piece of code, am I not telling the neural network that my input shape will be of input sample size 5? So please give my input layer 5 neurons to work with. Yes. So tell me this. If I don't want to take 34, sir, I want to take it as very good question. And in fact, you guys tell me, and it makes a lot of sense also. Sir, why are you only following 30, 64, 32? The reason I'm following this is because this has sort of become like the industry standard. Okay. Industry standard. But tell me one thing. Can I take a number of my own choice? 100% you can. As Tejaswini rightly pointed out, that sir, could I take a number that of my preference? Absolutely you can. And let nobody stop you from that. Are we understanding, guys? So for example, if your colleague is saying, hey, no, you can't take 35, you tell him, listen, my instructor Rudra told me I could take 35. I know he can't be wrong. So you are wrong. Be very confident. Just don't hit anybody, okay? Don't be a violent person in your life. If some of your colleagues come and tell you that, no, you can't use any other thing, tell him, my instructor told me I'm going to use it like it. Okay. This is my third layer and this is my fourth layer. Everybody agrees? My first layer, my second layer, my third layer, my fourth layer. Tell me, my last layer will always be my output layer, yes or no? My last layer will always be my output layer. And guys, my output would be churn, not churn. Basically, do you want to still be with the company 1 or do you not want to be with company 0? So don't you think I only need one node? I don't need one node to give me 1 and the other node to give me 0. Only one node will give me 1 or 0. So have I taken 1? And tell me, because the problem statement is a classification problem statement and that too binary classification, have I used the activation function called sigmoid? Because sigmoid will crunch the number between a number called 0 and 1. Agreed? So everybody, did you guys get the logic of writing down a neural network with multiple layers like this? I hope everyone is clear with how you will be capable of writing a neural network by yourself. But the complexity is not over. And what I'm going to do right now for you is what I would like to call as brain fry. Okay. What do you mean by brain fry? Brain fry means I will confuse you guys so much that at the end of this class, you will actually understand everything. Okay. And this is not an option for me because I have to do it like this. Okay. So listen to me carefully. Guys, do you see I have written something called as the if condition before the else condition, or sorry, before the else condition, I have written the if condition. Okay. Guys, when you want to do hyperparameter tuning, basically you want the computer to try out multiple different things, correct? So tell me, here I have taken 5 layers and I have told that I will be running a neural network with 5 layers. The first layer will be 64, second layer will be 32, third layer will be 16, fourth layer will be 18. But tell me one thing, can a computer program not do permutation and combination? 64 and 16, 32 and 8, 64 and 32 and 16, 64, 32, 16 and 4. Are you understanding? It can try multiple different layers, see how the neural network is performing and tell me out of these, which one is the best. Agree or disagree? What I have done, I have already given the neural network a strict model, a model that says, yes, I want you to build a neural network with these 5 hidden layers or layers like this. But can I not also make my network try 64 and 32 and see how this is performing? Then 64, 32 and 16 how it is performing. Then 64 and 16 how it is performing. Can I try multiple different things? And I can compare against. So I can run 2 different code. One is the strict 5-layer neural network and the other will be 64 and the 32 or 64 and 16 model and see which application model. I just wrote down the note a second ago that whenever you write the hidden layer, the most frequently used activation functions are either ReLU. So whenever you write a feed forward network or whenever you write a simple feed forward network, even forget 10H. Every single time, go ahead and use ReLU. It will solve the problem for you. Sir, why should you use ReLU? Because ReLU will allow any positive number to pass. In my feed forward network, I do not want any negative weightage to be passed in my neural network model. Hence, I am going to pass ReLU and ReLU works amazing. Okay. Sigmoid is default for binary classification. Every single time you want to do binary classification, can you use linear regression based? Should you use a sigmoid activation function? The answer is yes. That is the only way you will get the output. Okay. Sir, the order of node must be decreasing. What do you guys think? The order of the nodes in my neural networks, should they only increase or they can increase, decrease, increase, decrease, 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 increase, increase? They can be any order. They can be of any order. It doesn't just need to be decreasing only. It can be from any single order. Munna, if I want my activation function sigmoid to give me the output either 0 or 1, then don't I think I need? And dense 1 means only one output neuron will be available in one out. Very good. Okay, all right. So until here, sir, at one time this give only yes and no. Correct. In the output node, only yes could be the output or no could be the output. Are you understanding? It will not give you both yes and no. This is not what sigma. Sir, is the number 64, 32, 16, 8 and 1 are layers or nodes? Narayan, they are nodes, my dear. They are nodes. Layers are 5. Layer number 1, layer number 2, layer number 3, layer number 4, layer number 5. In layer number 1, 64. Only sigmoid activation function can be used or any other activation function can be used. See, you can use something called as a softmax activation function also, but you have to change the way softmax is used. So apart from sigmoid, you can use others also. Rudra are 64 nodes. Would this work if you had 128 features and 32 features? I'm asking, since the first stage has 64 nodes. Would this work if you have 128 features? Sir, if you had 5,000 features also, it would have worked the same way. It will not cause any problem. If it is node, then input are 5. How they can be 64? If their node input is 5, how can they be 64? Okay. Can my input layer be 5 nodes, guys? Because 5 is the value that I'm passing. Okay, that's good. Then the first layer will have how many? Okay. Then can I give 32? Then can I give? So are you understanding what I'm trying to say? The input node is always going to be the input size of that you're passing. Then the hidden layer 1 is going to be 64 node. The other will be 32 nodes, then 16 nodes, then 8 node, then whatever the value, and the output node will be 1. This is the neural network that you are building. So totally 5 layers, but nodes are 64, 32 and all of this and 16 and all of that stuff. Now tell me one thing. Sir, usually when we write feed forward network, if my input layer is 5, I usually should keep it less than 50%, right? This is explained once again. So please keep your ears absolutely open and don't be under your own presumptions and don't try to put words that I have never said. Point. I said that there are 5 input nodes. Everybody agrees to this. My input layer should always be equal to the data that I'm training it on. Is this a correct statement or a false statement? My input, okay, if my machine learning input is age, salary, CIBIL score, what is your years of experience in the previous company, and how many years of total experience. I am taking these many features to predict whether loan should be given to a person or not. Can I say if this is the data that I'm taking, 5 features I'm taking, my input node should be exactly 5. It can't be one more, one less. Agree or disagree? Is on this again, because this is so foundational. This is the ABC and I'm teaching you guys poem or literature but we are not clear with the ABC. So clear to everybody that the number of features that you're passing in the neural network, they have to be equal to the input node. Everyone is the hidden layers that I take, the hidden layers that I take, they can be many. Is this also a correct statement? They can be hidden layer number 1, hidden layer number 2, hidden layer number 3, hidden layer number 4. So Sonali says, I only want 4 hidden layers. But Pallavi says, my favorite number is 7. Then Toby says, my favorite number is 16. Is everybody correct? They can take as many hidden layers as they want. Toby is also correct. Pallavi is also correct. Sonali is also correct. Nobody is wrong. Agree? I can take one. One you should take. Minimum to minimum you should take two, should never take one. If you take one, your neural network is done. You cannot take a hidden layer with one input neuron. You can't expect your neural network to perform well. One output correct. That is correct. So let me ask you a question once again, everybody, so that our foundational logic is correct. Everyone, can I take many hidden layers that I want? Everybody agrees that I can take as many hidden. Okay, that's good. Now that you guys have understood that I can take many hidden layer, sir, can I take my first hidden layer as 4 nodes? Then the other neuron can be 7 nodes, and the other will be 3 nodes, and the other will be 2 nodes, and the other will be 7 nodes. Can I criss and cross, mix? Am I allowed to do that? The answer is yes, guys. Nobody stop. Yes, you can. You can take the first hidden layer with only 4 nodes, the second hidden layer with 7 nodes, the third with third nodes, then 2 nodes, then 7 nodes. Are you allowed to take this? The answer is yes. Sir, if I'm allowed to take it like this, am I also allowed to take it like this? My first hidden layer will have 64 input nodes. Sorry, 64 nodes. Yes. The second will be, sir, can I take 32 nodes? Yes. Sir, then can I take, so are you seeing that I'm also taking a decreasing number? The answer is yes. Sir, can I also do crisscross? The answer is yes. You can take whatever you want, however you want. The only thing you have to keep in mind is you have to experiment every single type of module, and whichever is working best will be the best neural network you are. My neural network, I am a hidden layer should be more than half of it. Priya, that logic will only apply to simple neural networks. Meaning one input layer with minimum number of one maximum 2 hidden layers and one output layer, or one output layer with 2 nodes. If you build a simple neural network, this logic, the one that I taught you, will allow or will work. But when you build a deep neural network, then the logic that the first input node and the second input node should be 50% will not. Yes, from this piece of code, can we go back and learn hyperparameter? Okay. See guys, hyperparameter tuning. Hyperparameter tuning. Sir, why do we need hyperparameter tuning? Listen to me carefully. See guys, whenever you do hyperparameter tuning, you got to understand one thing. You have some kind of a standard model, okay? Some standard neural network model where my input layer is of 5 nodes. My hidden layer number 1 is a 64 node. My other node, hidden layer 2, is a 32 node. The other neural network is a 16 node. Then I have a 8 node, and my output node is 1. This is my standard model. Can I say this is the standard model that I've created? This model will be implemented no matter what. But let me ask you a question. How do we know that 64, 32, 16 and 8 is important or enough? Sometimes my neural network can be implemented in even lesser, no? Just 64 is enough and 16 is enough for my network to do the best possible job. This is also possible, no? rather than unnecessary spending time, energy, effort on 64 node, then 32 node, then 16 node, then 18 node, then 8 node, and then 1 node. Rather than that, my best possible output could be 64 and 32. No need of 16, no need of 8, just 64 and 32 as the hidden layer. Output layer is 1 and my input is 5. This could be the optimal output. We don't know. We need to do something called trial and error, correct? Everybody agrees. This is what we call trial and error. Now tell me one thing, my people. When I say trial and error, is trial and error ever ending? Meaning, then I could start with 500 input hidden layer, then 400 hidden layer, then 300 hidden layer, then 200 hidden layer, then 64, then 32. Is this ever going to end in a It's never going to end. So tell me one thing. Can I select some top 5 values and then try them, and whichever is the best value, I prefer that as my neural network? This is what hyperparameter tuning does. Okay. Every single value, like for example, can you please build a neural network with 64 node and 16 node, 64 node, 32 node, 16 node, 64 node, 32 node, 8 node, 32 node, 8 node, and whichever is the best possible output is this will be the neural network that we will take. Agreed? And Mike, haven't we all learned something called grid search CV and random search? Grid search cross validation and random search cross validation. Okay. When you build a random forest, I can build a random forest with multiple different trees, right? I can build 100 trees in a random forest. I can build 150 trees also. I can build 200 trees also. I can build 400 trees also, correct? A random forest can have n number of trees that I can agree. When I build the random forest, I can also split my root node on the basis of Gini impurity. I can also split it on the base of information gain. I can also split it on the base of entropy. There are 3 different values I can do it, correct? You can also take that how much deeper you want your trees to be. Can somebody tell me what is the height of a tree? Suppose 1, 2, 3 and 4. What is the height of this tree? What is the height of this tree? How do you calculate the height of the tree? 1, 2 and 3. What is the height of the 3? So tell me, when I build a random forest, can I say that each tree should be restricted to only 3 height, 5 height and 7 height? Agree? No. Okay, good. So tell me, when a data set is given to me, of 1000 rows and 3 columns. So can I say I have a 3 column data A, B and C, A, comma, B, comma, C, comma, target, and this is my feature, which is 3 feature, 1 target, and the rows are 1000. Agreed. 80% of the data set is for training. So can I say 800 data will be used? When I use an algorithm called grid search, GRID, grid, SEARCH. You know what it will do, my people? It will create a random forest with tree is equal to 100, impurity will be equal to Gini, and the depth of the tree will be 3. So random forest will build 100 as the tree size, or let me take a different color. It will build a random forest with 100 trees split with the Gini impurity, and the depth of the tree will be 3. And the accuracy of the model will be 87.16%. Can I say? Okay. Then what it will do? It will try the same random forest with 150 Gini impurity and depth equals to 3. 86.19. Then it will create one more random forest with 200 same Gini impurity, depth equals to 3, 82.17%. Then it will create a decision tree or a random forest with 400 trees. Guinea impurity 3, the output will be. So are you understanding? It will try 100 with Guinea with 3, 150 Guinea 3, 200 Guinea 3, 400 Guinea 3. 100 information gain 3, 150 information gain 3, 200 information gain 3, 400 information gain 3, 100 entropy 3, 150 entropy 3, 200 entropy 3 and 400 entropy 3. Then every single permutation and combination, and whichever will be the best possible output, that output will be your decision tree of the value. So what grid search will tell you is, I got the best possible percentage when the number of tree was and the information gain and the split size was 7. So can you see, it tried everything and it said that this is the best possible values. This is called hyperparameter tuning with grid search. Are we? That's great. Sir, what do you mean by random search? Random search. Guys, listen to me carefully. If you increase the size of this particular tree, okay, for example, the more hyperparameters you give and the more size of the data that you increase, will the hyperparameter tuning that much amount of time? Because if you increase the number of values in the array and more hyperparameter tuning, it becomes an n square operation. Meaning it has to actually not n square, it becomes factorial operation because that many factors has to be considered, right? Meaning the time it takes for my grid search to give the answer will be very, very high, correct? It will be very, very high. So rather than taking the grid search, can I take random search? Meaning, tell me guys, how many random search do you want me to give? Give me a random number, everybody. Give me a random number between 1 to 7, 5. Everybody, what it will do is randomly it will take 100, it will take entropy, it will take 5. What is the output? This is trial number 1. Trial number 2, it will randomly take 150, Guinea and 7. Trial number 3, 200 in IG and 5. Out of the random 5 values, whichever is the best output, it will give you that output. Are we clear? It will not do all the permutation and combination. It will randomly select the values and whichever is the best out of it will give the answer. And did you know that it has been proven scientifically that random search is faster and better than random search is faster and in many cases better than grid logic. Okay. So if you guys got the logic of hyperparameter tuning, in my model, have I taken a standard model against which I will make, but I want to do some mixing and matching. I want to do some crisscross mechanism. I want to check whether randomly, if I select from this model only 64 nodes and 32 nodes in my hidden layer, then 16 nodes and 8 nodes. Sir, can I do it? Yes, you can do the trial and error, and I'm about to teach you right now. So in this, if hyperparameter is given to me, you can take a variable called model equals to models dot sequential. Everybody knows that if I want to build multiple different layers, you can take something called sequential and you can take this particular thing. So nobody is confused with this. If I want to build a neural network, the first thing I have to take is the sequential part, which is the model.sequential. Now, when I build my first layer, can I give it some options? Like for example, model.add. Now, what is this model.add? Give me 1 second, you will understand. Inside the models.add, layers.dense, and inside the layers.dense, I am saying units equals to hp.choice, choice, choice. I'm going to name the variable or the layer as unit underscore 1, units 1 or layer 1, whatever you want to say. And the values will be 32, 64 and 128. What am I doing here? I am telling that, can you please create a first hidden layer for me with how many values? First create with a 32 node, then create with a 64 node, and then create with a 128 node. Yes, I am asking my neural network to create multiple different. For every combination I create, what activation function? ReLU. Agree, disagree? I am telling my neural network that, can you please create a first layer? Call that layer as unit underscore one. There is a reason why you have to name it. I'll tell you in a second why. And activation will be this. But tell me one thing. Have I told this neural network what my input size is yet? Did I give that information? Sir, you have not given. So it's not complete. So can I copy the same thing? Input shape equals to this. Copy and paste. Now is my first layer complete? Now is my first layer complete? Absolutely it is complete. But tell me one thing. Sir, you have only done this for first layer. Sir, can I do it for all layers? Do you think you can do it for all layers? Yes, you can. I have only taken the first layer of multiple different values. So tell me guys, if I repeat this logic for second layer, third layer, fourth layer, fifth layer, sixth layer, will it not give me the output saying that I ran permutation and combination? The first hidden layer should be of size 32. The second hidden layer will be of size 64. The third hidden layer will be of size 16 and the fourth hidden layer will be of size 32. Example. Will it not give me the output like this? And now I know which is giving me the best possible. Are you understanding what I'm trying to say? But listen to me. I am not going to do this. You know why? You know why? Tell me this. Isn't this what every beginner would think? That this is how we could. A beginner data scientist will always write a code where he will take multiple hidden layers and write it like this. But is there a better way to write this? Yes, there is. Let me teach you what is the better way. Rather than writing this piece of code again and again and again and doing model.add, 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 we don't want to. Tell me guys, my model that I wrote here in the sequential is every single layer inside the model.sequential part. Yes or no? Every single layer is inside. If you want the layers to be outside, how do you connect it? With the help of model.add. If you want your layers to be outside, but you still want to connect them on that condition, you should use model.add. Then it will get added inside the model.sequence. Are we clear until here? Now, I'm gonna teach you a much better way of handling things, okay? Optional second layer if you want to build, okay? Second layer that you want to build. Inside the optional second layer, you know what I'm gonna do? I'm gonna create something very weird logic, okay? If hyperparameter tuning dot boolean, and I'm gonna write down a second underscore layer, or maybe, yeah, let's just say second layer and put a bracket here. Now guys, this is the most fun and the most smartest thing developers do or programmers do that are very senior in nature, okay? Model.add, okay? Just wait for 2 seconds, I will explain this code. Inside this, I will take layers dot, and inside the layers dot dense, I will take units equal to hp dot choice, choice, hp dot choice. I'm going to call this units underscore 2. You can call it layer underscore 2 also. Values equal to 16 and 32. Okay, let's take 16 and come outside this particular thing and say activation will be equal to ReLU. Now let me ask you guys a simple question. Did I tell this machine learning model that I also want to add a second layer called my optional second? Absolutely love your curiosity. Okay. I love the fact that you're very logically thinking, but no, you do not need a loop. And I'm teaching you why you don't need a loop. So just 5 more minutes and you will explain, you will understand why. Okay. No need of Python looping. You don't need any program, for loop, while loop, any kind of loop. I have taken the first layer, I have taken the optional second layer, but in this optional second layer, half of you must be thinking, why has he written hp.boolean? This must be like the burning question in your heart right now. Arey, what has he done so different? Why has he chosen this hp.boolean? Also, why did he write a if condition? Don't worry, I'll come to that. One step at a time, don't worry. I have taken the first layer, I have taken the second layer. But did I mention any output layer? I should mention my output layer, no? So can I mention my output layer towards the end? Output layer will never change. Are we clear? Your output layer logic will never change. Meaning model.add layers.dense, layers dot dense, and inside this dense 1 comma activation will be equal to ReLU. Any question? Sorry, activation will be equal to sigmoid. Any question? My output layer will be model.add layers.dense 1 comma activation will be equal to sigmoid. Okay. Now, please allow me to copy the whole code for you and explain what exactly I am doing in this piece of program. Okay, give me 1 second and let me paste it. Are you guys able to see this particular code in detail? If you guys are able to see this, let me know. Okay, perfect. So let me explain the logic to you very clearly. Sir, what do you mean by the concept of hp.boolean and why are you using something called hp? Most of the cases in neural networks, it has been observed that your input layer, your one hidden layer and one output layer is more than enough to give you the output that you want. Are you? It has been observed in multiple different times that your one input layer, one hidden layer and one output layer is very much good enough. But if you still want to try a second, do you see I have written something called hp.boolean? Now everybody knows in Python bool is a data type which is nothing but true and false, correct? Now in Python if I say if true, if I say the condition is true, only then will I enter the indentation logic. I will enter even inside the logic only if the condition becomes true at all. If the condition is false, I will never enter. Okay. You know what this program is doing? In this hp.bool, okay, in this hp.bool, I will tell Keras that can you first randomly take only the first layer and try 32, 64 and 128. But randomly make the Boolean layer true. Meaning in one of the trial, it will take 32 and create the model and give you the output. In the second trial, it will take 64, randomly make this true, and it will take the second layer at the node 16. So now the first layer we created 32 and the second layer or the second trial was the first hidden layer as 32 and the second hidden layer with 16. Then again, it will try third trial where the Boolean value will be randomly kept at false and the first hidden layer is created with the node 4. Then suddenly in the third or the fourth trial, 64 will be chosen and the second layer will be taken 32. Are you understanding what I'm doing? I am genuinely creating a chaos, mixture of yes and no. Let's understand. So tell me one thing. There are two layers, correct? Layer number 1 and layer number 2. Can I say this is layer number 2 and this is layer number 1? Everybody will understand this? Okay. My job is to fire, F-I-R-E, fire. I want to fire, meaning run. I have taken the first layer of multiple values, 32, 64 and 128. Agree? 32 nodes 64 nodes and 128 nodes. That's great. I am telling my program that can you create first neural network of only 32 nodes? So I have an input layer. My hidden layer is only one with 32 nodes and one output layer, and I will get some accuracy value, correct? Now, do you see I have a condition called if boolean is equal to second, or if my TensorFlow will randomly make this boolean as true. If I make this true, can I now only create layer number 1? In this first neural network created, only layer 1 was created. Agree? Only layer 1 of 32 nodes was created, correct? Now suddenly my TensorFlow made this true. So now I have to take layer 1 also and layer. So can I take layer 1 value as 32 and layer 2 value, the first value is 16 plus 16. So now I have an input value. My hidden layer size is 32. Hidden layer 2 is 16 and an output layer. This is my second model that my neural network. Now suddenly, randomly, my neural network became false. So can I say that the third model that I built will be only input layer of size 16? Then again the boolean will become true. Now 64 plus 16. So at the end of the day, I'm randomly doing 32 and 16, only 32, 64 and 16, only 64, 128, 16, only 128, 64 and 32, only 64 we already have, 128 and 32, only 128. So basically complete first layer, only first layer plus second layer, both I'm. Rather than giving the model and code again and again and again, will this 2 line of code make my permutation and combination much more? I know it is not easy to understand, but at least you got the logic. Now tell me one thing, I have a small question. In this piece of code, have I mentioned anywhere that boolean should be fire? Anything called random, anywhere it is? No. Sir, where do we mention that? It will be done automatically by the library called Keras Tuner. Do you see this library called Keras Tuner? Keras Tuner is responsible for firing the event of true and false. But sir, have we used the Keras Tuner yet? Did I use the Keras Tuner yet? No. Sir, should we? The answer is yes, we should. Now we will use the Keras tuner. Are we understanding? What is HP.choice? HP.choice means please pick up 16 or pick up 32. Choose between 16 and 32. That is why HP.choice is needed. Because, do you see I am passing a parameter called HP? Agree, disagree? Can you see I am passing something called HP here? So if I pass the parameter somewhere here, that choice will be taken automatically in this piece of code. And I will teach you how to do this. But at least this piece of code did everybody understand? Now tell me one thing. How many layers have I taken at max together so far? Only 2. Can you repeat this piece of code for every layer and now your job is easier? Rather than doing model.add and fixing and giving the values every single time, can I not just create this and my job is say sorted? Layer 3 will be called third layer, units 3, and whatever you want to add, 4 layer, 5 layer, 6 layer, 7 layer, whatever you want to do, you will only repeat this. That's what I'm trying to do. Since every single person in the class wanted the practical example, this is the most practical. Are we clear? Okay. Now tell me one thing. Is my neural network complete, everybody? Can I assume that my neural network can be considered complete? Sir, it is not, because in the beginning of the class, did I not teach you that if you want to run the neural network, you need to do something called model.compile. Until and unless you compile the model, how can you say that the model has actually, right? So tell me, sir, we also need to do the same thing. How do we do this? We have written the neural network in such a way that we have mentioned all the layers. The first optional layer, the second optional layer, and the third output layer. So right after the third output layer, I need to do what? I need to compile my neural network. Otherwise, it will not run. Sir, what do you mean by compile? Model.compile, model.compile, compile, 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 model.compile. In the compile part, do you give something called optimizer, my people? Optimizer is equal to, sir, if I want to give the optimizer, can I just say Adam, Radam, Ada, Grad, RMS, Prop? There are so many kind of optimizers. For now, assume I'm giving something called Adam. The loss will be equal to what? Guys, when you do binary classification, the loss function is something called as binary cross entropy, correct? Yes or no? I hope all of you know this. Categorical cross entropy, binary cross entropy, log loss, Huber loss, hinge loss. These are the kind of loss functions you have, right? You've heard of them, right? Okay. When you did your logistic regression, were two things taught to you? Or I'm very sure it would be taught to you. But do you know that there is something called maximum likelihood estimation connected with binary cross entropy? Mean square error and root mean square error. Okay. Guys, root mean square error and mean square error can only be used for linear regression, right? They can't be used for binary classification or classification. Your mean square error, root mean square error, mean absolute percentage error, these are all loss functions for regression, not for classification. For classification, you have Huber loss, hinge loss, right? You have categorical cross entropy, binary cross entropy. These are the losses you use. So tell me, what loss did I mention? Binary cross entropy. What metrics do I want to use? What metrics do I want to use? I want you to focus on something called accuracy. Now, is my model complete, everybody? But tell me one thing, what about now? Sir, you have written the if condition and else condition, but in the else condition here, you have still not mentioned the model.compile. So for this also I need to do model.compile. For this also I need to do model.compile. So optimizer, optimizer also will be comma, loss also will be equal to binary cross entropy. So let me take loss is equal to binary cross entropy. Let me paste it here. Copy, comma, and metrics also will be equal to accuracy. Meaning, when I'm running the neural network, what do I want it to give me? I want it to give me the loss, the validation loss. That's why I have said metrics equals to accuracy. Is this complete, everybody? Is the model complete? Is the answer complete? No. No, it is not. Because when you write any function like a defined function, what do you need to do? Do you not need to return? Do you have to return something? Like return statement has to be mentioned. Now tell me one thing. When I wrote down this piece of code, okay, let me remove the whole thing and let me give you the answer. Okay. So if my hyperparameter tuning is available, or listen to me carefully, please don't go anywhere else, okay? If my hyperparameter tuning is available, in that condition, I want you to follow what you call as the indentation for model. Then I will say model.add, and in the same indentation, I will get the if condition, correct? My if condition is given in the same part. If hp.boolean, my model.add, my model.compile, right? My else is in the proper indentation of if. Can you see? My if and my else is in the proper indentation. Correct? After the else, right? After the else indentation, I'm going to come over here and check my model is also in the right indentation. and my model is also correct. So model.compile. So if I come over here, and here I need to mention something called return model. If I run this piece of code, did I get any error? Absolutely not. Sir, please explain matrix part again. Pallavi, in classification, don't we have values like F1 score, accuracy score, precision score, recall score? When you mention metrics, it will give you two values, loss and validation loss. That's it. That is what metrics. Okay, good. Now tell me guys, when you write a function, should you not call that function? And sorry, sir, if I already have if condition model, why we need to choose? So in Python, when I want to, okay, in Python, we have two conditions, right? If condition and else. If my age is 45, call me old. Else, if I'm not 45, anything apart from 45, called me young. Example. So when my hyperparameter tuning parameter will be passed by the model, then the if condition will be okay. Object reference for a function call. But why don't have compile after if else? So the problem after if else is, the problem with Python is, so what I mean by indentation is, until and unless you belong to that indentation, that logic will not implement. And because if is being called separately and else is being one thing also. Are you guys confused that why am I taking model.compile in the else also and model.compile in the if also? That is the confusion you guys. I'm assuming that is one of the confusions you guys are having. Sir, can't we keep this model.compile in the outside of the indentation? So no matter if works or no matter else works, the indentation will still focus on the model.compile. Yes, you guys are right. If I keep this layer outside the indentation, it will still work. To make the program more readable and approachable, that's why I have written it in two different ways. Did you get it? So, practically speaking, in computers or in good programming practices, it is never good to take the logic outside the if and else separately. If you want to be called as yourself as a good practicing programmer or a programmer that follows good practices of coding, you need to mention the logic within each indentation of itself. But can you do it? Yes, you. Whenever you write a function, please make sure that the indentation is followed, right? In the line of if, there is the else condition, and in the line of else, there is a return condition, right? And if you see the nested if, it's ending only at if. There is no else given to that particular if. If that condition exists, great. Otherwise, we are pretty much done. Okay. So now that you know how this particular code is written, we were able to run this particular function. Okay. If part has two hidden layer and else four hidden layers. Why like that? Okay. That's a very good question, but a very simple question. Let me explain. The if part has the first layer. If the first hyperparameter or a hyperparameter is found, right, I would want it to work with just the first hidden layer. Okay, I just want it to work with the first hidden layer. Now, if the first hidden layer is actually run, right, and I want like a second optional layer to work, okay, so let's say that the condition of this if and this if will work based on the hyperparameters that I'm going to pass, and it will become slightly even more clear. You'll understand it in a second why I have written like that. Okay, you'll get the idea. In this function, when I return the model, does that mean my function is run? Actually, no. That does not mean the function has run. Now, I actually need to build my neural network. So can I say initial underscore model is equal to create model? Create underscore model. Now, everybody, please tell me that in this create model, have I passed any hyperparameter? Was any hyperparameter passed? If the hyperparameter is not passed, what do we assume? Let's wait a second and we will understand. Initial model dot summary. dot summary. If I run this piece of code, what answer are we going to get? Are we going to get the summary of the model that I have? So do you see that because hyperparameter tuning is not passed, it is exactly creating 64, 32, 16, 8 and 1, like how in Python program it is supposed to go. Because I have not passed any hyperparameter inside it, it went to the else condition just like it was supposed to, and it helped me create a neural network with the standard, the default neural network that I wanted to run. Did it run? Everyone, I want you to wake up and tell me if that makes sense. That's great. Okay. Once I do this initial model dot summary, I will create history is equal to initial model dot fit. Isn't this how any neural network works? I have taught you this, like before teaching you this neural network code, I have already taught you a portion of the neural network code that does exactly this, right? So inside the initial model dot fit, do I pass in the X trained scaled, which is my scaled data, my Y trained data, which is exactly to be passed like that? I can also pass something called epochs, everybody. Let's say the epochs I pass will be 50. Okay. Let's say I don't want recommendations. Okay. Epochs BATCH underscore SIZE. Batch size, let's say 32. Validation underscore split is going to be equal to say 20%, and the most basic thing is verbose will be equal to 1. What is this going to do for me? The portion of history, is this going to run my model? Is this fit thing, the method fit, going to run my neural network model and it will give me for certain number of epochs? Yes or no? Agree, disagree? If I run this in front of you, do you see the number of epochs running? Epoch 1, epoch 2, epoch 3, epoch 4, then 5, then 6, then 7, then 8, then it goes on and it will run for 50 different iterations. Yes or no? Sir, please explain param column. Which param column are you talking about? So Subhash, I've already done this, I think thrice or multiple different times, but I'm going to repeat this once again. See, my dear, from input layer to the first hidden layer, which is 64, how many different weight values will be connected? I think a little bit of revision is very important for all of you. This is a very foundational question that you've asked me. So please remember, when I taught you the first neural network, did I not tell you that from the first input layer to the first hidden layer, the number of weighted connection is the number that it is? So for example, if my input neuron is 3 and my output neuron is 2 or my hidden layer is 2, how many weight values will be connecting? So for example, this particular thing and this particular thing. So tell me, 3 multiplied by 2 is how much? 6? Is my understanding correct? So tell me, what is my input layer, or what does my input look like? What's the size of my input? 1, 2, 3, 4 and 5. How many? 5. And 64 is the hidden layer. So tell me, 64 times 5, if you just multiply 64 times 5, what answer are you going to get? 320. But is this 384? Why 384? Because each node's biases also will get added, correct? Is my understanding correct? So tell me one thing, guys. Is my model run? Everybody, I want you to please focus. Model ran. Now can I calculate the loss versus the accuracy, everybody? Can you see here? When I run the model, I am getting the accuracy in the answer as well. I am also getting the loss. I am also getting the validation accuracy. I am also getting the validation loss. Yes or no? I am getting both the loss on the training data. I am also getting the loss on the validation data. Now, if I say loss comma accuracy is equal to initial model, because that's the name of the model, dot evaluate, and inside this pass the X test scaled. Because tell me one thing, in machine learning also, don't you test your machine learning against the test data? Yes or no? So do I pass something called X test scaled, Y test? So I will be showing you how to interpret the loss with a plot towards the end of this particular file, and you will understand how a loss and an accuracy is supposed to be sort of visualized, sort of understood. Okay. The most easiest thing that I can tell you, Mike, is please remember when the loss value starts in the very beginning, it is supposed to decrease after every epoch. This is the most basic thing that you need to see. So if you look at the loss here, which is 0.53, do you see it is decreasing every single time? From 0.5 to losses are consistently decreasing, right? And accuracy is consistently increasing. Are you able to see this, Mike? So guys, tell me this. I have passed something called X test scaled and Y test. Okay, this is the data I want to calculate my loss and accuracy on. Why did we scale on X values but not on Y? How will it evaluate? Whenever you do machine learning, the data is divided into 4 sections. Is my understanding correct? Suppose this is my training data, or suppose this is my data. Okay, everyone, listen to me carefully. Okay, listen to me. This is my data. Okay. This is my feature data and this is my target data. Everybody understands what is features, right? In machine learning, what are features and what are target? Everybody understands this. So can I say that area of the house, locality of the house, and number of bedroom, hall, and kitchen will help me predict the price of the house. So please, guys, tell me in area, locality, and number of BHK, what is my feature and what is my target, everybody? What will be my feature and what will be my target? So price is my target and my area, locality, and number of BHK is my feature. Everybody clear? Just like you cut your birthday cake, just like how you cut and split your birthday cake, you need to split the data in machine learning or deep learning into 2 different cuts. How many cuts, guys? 2 cuts. One vertical cut, one horizontal cut. Let me explain how. You cut the data like this. So you split the data into 2 parts, right? One is the X data and the other is the Y data. Yes? After you make the X cut, you also make a cut vertically, right? Horizontally, correct? This is called as my training data and this is called as my testing data. Everybody clear until here? Guys, this portion of the data, is it going to be called as X train? This entire column that you see here is going to be called as X train. Yes. This data is going to be called as Y train. Yes. This data is going to be called as X test and this is going to be called as Y test. Now tell me one thing, when I did scaling of my data or when I did standard scaling of my data, please observe one thing. Okay. And what is that one thing, everybody? Let me explain the concept. Give me 1 second. When I did the standard scaling of the data, yeah. Tell me one thing, did I scale my test data by any chance? Please tell me, did I scale only the train data? Can somebody tell me why is the reason why we do this? See, if you look at this graph in front of you, do you observe something crazy? So do you see that my data has been split into 4 different parts? When we apply normalization and standardization, there is a rule, right, that you have to follow. Absolutely correct, Pratik. Love the answer. The value of standard deviation and the mean will differ for the training data separately and for testing data separately, correct? Guys, when we apply standardization, doesn't standardization require standard deviation to be calculated for the data? Yes or no? which data is always in majority and which data is usually in minority? So when I do scalar dot fit transform, do you see in this particular code I have done something called fit transform? Do you see this piece? The reason you do this is because you want to scale the entire X-train data. Depending on the size of the X-train data, you want to make sure that the scaling happens as original as possible, as authentic as possible. But sir, why don't we do it for the test data? Because whatever scaling has been done with for the X train, we don't require that scaling to happen on test. We just need to transform that scaling and that will make my job done. Min-max scalar, there is a kind of scalar called min-max scalar. It will bring down the number between 0 to 1. But when you do standard scalar, the ranges are not defined, but the number will always be dependent on its standard deviation. Yes or no? I hope I was able to give you guys a little bit of clarity that you never scale your Y test and you never test your scale. X test and Y test are never scaled. Only the X train is always scaled. Y test and X test, depending on the conditions, are only transformed. Is the idea clear? If you did not get the math behind it, it's okay. But are you going to keep this in your mind from now on that never in machine learning do you scale your X test value or your Y test value? You just transform them. That's the logic. If I did model.evaluate X test scale and Y test value, what does it mean? It means that I can print both my test loss and my test accuracy. So tell me, my test loss on my neural network, can I mention it like this? Loss, and copy the same thing and paste it here and say test accuracy, ACCURACY, and inside this I will pass accuracy. So please tell me, if I run this piece of code, do you see the test loss is 0.40 and the test accuracy is 0.80? This is just to give you a green light that yes, your model has been performing as per expected. Now tell me one thing, if I go to the very top of my program, let's say, have I imported matplotlib here somewhere? Oh, I have imported matplotlib. Very okay. I'm going to come to the bottom. Now guys, how do you validate whether your model has performed well or not? So tell me one thing. Here, we are going to plot some visual data and understand if my model has been performing good or not. So plot.figure, inside this figure size is equal to 10,6 example. Did I do something called sizing the canvas? SIZING, sizing the canvas, meaning how big do I want my model or the graph to look like? I am sizing it right now. Yes or no? That's great. Sizing the canvas. Plot dot subplot, 1, 2, 1. Guys, if you want to make a plot that looks like this, and like this, can I say this is a side-by-side plot? Can I say this is a side-by-side plot? Can I also not make a plot that looks like this, 1 and 2? Yes or no? Okay. So tell me, how many rows do I have in this plot, everybody? How many rows do I have? 1 row. But how many columns? How many columns? 2 columns. So 1 comma 2 comma, can you see here? 1 comma 2 comma, the name of the plot is going to be 1 and the other name of the plot is going to be 2. So can you see here? I have taken 1 comma 2 comma 1. So this is the row, the column, and which position that plot comes in. Are you clear, everybody? So plot dot plot, everybody, history, because this is how I have written my program. Okay, if you can see here, I have taken the compilation of my model as history. So I will copy the same history and I'm going to say history dot history, which is going to be pretty much same. And from history, I want to plot loss, comma, I want to give it a label as training, TRAINING, training loss. I'm going to copy the whole thing, copy the entire thing. Let me just copy it faster. Let me copy the whole thing, paste it in the bottom. Training loss versus validation loss. So if I just say val underscore loss, and the label will be validation loss. Validation loss. Sir, why did you write it as val underscore loss? Because when we ran the model, what is validation loss written as? Is it not written as val underscore loss? See, accuracy is accuracy, loss is loss, validation accuracy is val underscore accuracy, and validation loss is val underscore loss. That is why I have written this as val underscore loss. Plot.x label, just x label part of it, if I want to plot, can I say how many epochs I run the model, or how many epochs, how many iterations I ran the model will be on the x? And on the y label, I can say that what is the overall loss of my model. And I can say plot.title, title, title, I can say model loss curve, curve. And inside this, plot.legend, because I also want the label, and plot.grid, let me also make the alpha, alpha, alpha is equal to 0.3. Let me run this piece of code. Not very happy with the code. Give me 1 second. Oh, sorry. Of course, I am making a mistake. Why am I making a mistake? 8 and 6. Okay. How about we make it sort of square, right? Like 8 comma 8. I think this would sort of make a little bit more sense. Okay. Let me size it a little perfectly for you guys. Oh, you know what? Let me take this as a larger size, and this would make a little bit more sense. Yeah. Do you guys see this curve in front of you? So tell me this. So tell me one thing. Do you see the loss decreasing as the number of epochs or training has increased in my neural network? Is this the expected behavior of a neural network, that over the period of the time or over the period of the model's loss should decrease? It will jump, it will go up, it will go down, it will have the model will have its own ups and downs, but overall, is the loss decreasing? We call this as the inverse J curve. This is the behavior of any good neural network. Are we clear, everybody? This graph is also called as the inverse J graph. This is exactly how a neural network is supposed to perform, everybody. Are you understanding? Essentially speaking, the validation loss and the training loss should be smooth. But tell me one thing, is this smooth? Is this smooth? Actually not. Will it have a little bit ups and downs? Well, this is the behavior that you can expect from the data, from an actual production data, a data that has been captured on a real-time use case, or which sometimes the data has a noise. So please understand that a neural network isn't going to always have a very smooth looking curve. It's going to look like this. And if you see at the bottom, my validation loss peaked and it fell again. Do you see? My validation log did peak, but then it fell back again, meaning it went down again. So the validation loss and my training loss is following the same behavior. Agree? Yes or no? But tell me one thing. I have only plotted for the loss, but I also have the capability of plotting what? My accuracy over the period of time, right? I have just identified whether my loss decreased or not. But what about my accuracy? So tell me one thing. Instead of plotting the loss, can I plot accuracy? So rather than me assuming something, let me just copy accuracy here. So let me copy accuracy here and paste accuracy right here, and validation accuracy. So let me copy this and let me paste this particular thing here. Now there are certain problems that you need to change. The code will become 1 comma 2 comma 2 because this is the second position program. We will call this as training accuracy. So ACCURACY, training accuracy, and validation accuracy, right? So ACCURACY. And epoch versus accuracy, ACCURACY, and we can just say model accuracy curve, ACCURACY. So I think did I make change somewhere else? Oh, I apologize. Control Z, Control Z, Control Z, Control Z. 1 comma 2 comma 1. This is 1 comma 2 comma 2. Training underscore accuracy and validation accuracy, ACCURACY. This is epochs. This is accuracy, ACCURACY, accuracy model accuracy curve, ACCURACY, RACY. Okay, run this. Tell me this, what mistake did I do? This is 1 comma 2 comma 1. This is 1 comma 2 comma 2. What could I have done? Okay, I'll change that later. You need to change to VA underscore, oh yeah, val loss, right? Sorry, val ACCURACY. Validation accuracy. Did I speak the spelling right? Let me just copy this. Give me 1 second. Copy this, come over here, paste it over here and run this. Okay. Wait, did I make a mistake somewhere? Accuracy history dot this is accuracy. This is correct. Epoch, the number of epochs are over a period of time. That's correct. And the validation accuracy over a period of time is accuracy. Okay. Made any mistake. This is my first graph. Training loss. Oh, validation loss. LOSS. Yeah. Okay. Now, guys, if I don't print validation accuracy for even 1 second, okay, and run this piece of code, do you see my model accuracy improve over a period of time? It struggled a little bit. It went up. It shot down a little bit. But overall, my accuracy has gone up. Agree? Observe one thing, guys. Okay, all of us. Just first of all, is my model a default model? Yes or no? The model that I just ran, is it a default model? Sir, yes. It is the default model that you gave, which runs for this particular layer, correct? That the model that I've just run and shown you is a default model. Absolutely perfect. When I ran the default model, my model jumbled a little bit, right? Now, understand one thing. Sir, does frequently going up and down, is it a sign or is it a bad sign? The answer is no. As long as your accuracy or your loss has decreased and your accuracy has increased, it's a good sign. But do you see there's a lot of ups and downs in the curve? Now look at this part. What about this validation accuracy? Overall, my validation accuracy looks like it is stagnant, correct? Do you see? My validation accuracy. Now guys, don't get confused with the accuracy going down, because understand one thing. We started the accuracy at 0.79. The last value is actually slightly greater, right? But it increased, decreased, increased, decreased, increased, decreased, increased. There was a lot of shuffling, right? In the validation accuracy, it went up, then it went down, then it went up, then it went down. Sir, what does it mean? It means that the neural network was able to do well on the training data, but at the time of validation, it did not do well. Are we understanding? It performed good when it came to actually overall understanding, but towards the validation part, it did not do a great job. So to solve this problem, my solution would be something called hyperparameter tuning. Which neural network is the best neural network? Agree, disagree? How do we make sure testing part we haven't plotted? So when you say, sir, we haven't plotted the test part, what do you mean by plot the test part? Explain that to me in detail. So your question itself has the answer, but let's try to understand it from your perspective. When we say test, right? What do we test it against? But what do you see in this particular graph that gives me the idea of the neural network's output? Is it possible to calculate loss without the test data? Accuracy, loss, validation accuracy, and validation loss. Is it possible to calculate loss without knowing what your real value is? Yes or no? So, what what must have happened here? Like what could we, what would have, what did we do here in this particular piece of code? How did we get this accuracy loss, validation accuracy, validation loss? Is this on the test data? Is this on the validation data? Tell me. Is this on the test data or is this on the validation data? Sir, this is definitely on the validation data. 100% on the validation data. But tell me one thing. Did we not learn one thing in the beginning of the class? That whenever you train a neural network model, the minute you mention validation split, the training data will be training data, but the test data becomes the validation split. Because validation is a part of your is the part of your overall data, correct? The minute you say validation split, your validation is a part of this extra split in the data, which will be used for validation. But validating what? Your actual test, to validate, to check, to test whether a particular thing is worked or not. Are you understanding? You guys got the logic of how we wrote a neural network. But is my job over? Because I got the output, does that mean my job is over? Your job is far from over, guys, because you haven't done something called hyperparameter tuning. Now, let me ask you guys a simple question. Sir, if I want to do hyperparameter tuning, how can I do it? First of all, guys, you need to be aware of the fact that what are you going to be importing as a part? What are you going to be importing? Can you see I've imported something called Keras tuner? So here validation data and test data are the same. When you give a validation split from the original data, 20% of the data, randomized shuffle data becomes your test data. And the actual test data that you've taken can be used for hyperparameter tuning. In fact, you can use it against test, but use validation also for hyperparameter tuning. Tell me this, is this my Keras tuner? The module or the program that is used to tune my model. But guys, it is not very easy to understand. So all I want you guys to do is just pay a little bit more attention, because the code that I'm going to write right now, right, it's going to be a little tricky. Why tricky? Because TensorFlow plus Keras tuners syntax are a little bit weird. Okay, a little bit weird. So try and stick with me, you'll get the idea. See, gone through it. Okay, so if I say, for example, print, okay, star star multiplied by 50, and I don't know, okay, print parameter tuning, right? Let me copy this and let me paste it here. Actually, let's reduce this to a little bit more smaller, 20. This makes sense. 15 or 10 is fine. Yeah, this is fine. Let's take it as 10. Okay. Hyperparameter tuning, right? Tuner, any variable that you want to take, okay? Guys, let me ask you this. Is hyperparameter tuning a mandatory thing in machine learning or neural networks? Everybody, whenever you implement as a data scientist, do you think it's a mandatory thing? How many of you think it's a mandatory thing? Grid search in a practical setting. Okay, in a practical setting. Okay, let me ask you this. Imagine, guys, imagine all of you are in police. Okay, you all serve the Indian police, example, and you are searching or sort of doing a roadblock. Okay, you have done something called roadblock. Now tell me one thing. Every single car that passes through the roadblock, you have been given the instructions from your, your superiors that every car should be checked. Okay. Now, because every car needs to be checked, there is this big jam or a traffic jam. Okay. So some you are going to let go and some you are going to check. So can I say, if you ever find a family with a wife or a husband and a children, you might let them go. But whenever you find a bachelor, a single man or a male, or a single female, you might check their car. This is the rule you will have in case if you want to check the car. Now let me ask you a question. Is this written as the law? No? No. Okay. But did you end up making an exception that if you have a family with a child, we don't want to disturb them, we will let them go. So tell me one thing. Hyperparameter tuning, who does it depend on? Whether you want to do it, not do it, does it depend on the data scientist? Point number one, completely and absolutely dependent on you. When you say you, is it on your judgment? Is hyperparameter tuning going to guarantee that the model will be always the bestest of the best model? No. Even if you do hyperparameter tuning, are you 100% sure that the model given by hyperparameter tuned model will be the model better than the one that you ran? You have no guarantee, no confidence. But tell me one thing. Here your experience as a data scientist comes into picture. The goal of the problem comes into picture. Your data comes into picture. So basically so many different things comes into picture for your judgment to work. Agree? So if I give you a simple plain answer yes or a simple plain answer no, it would be complete injustice to all of you. I don't want to lie to any single person here. Guys, hyperparameter tuning is going to be completely your choice. But remember one thing, personally speaking, personally speaking, I always do hyperparameter tuning. I don't care if the problem statement is basic, not basic. If it is too basic, I don't do hyperparameter tuning. But I always want to know, is there a way my model could be improved further? To make sure to increase that 2% accuracy or precision or recall, I always end up doing hyperparameter tuning. Tell me, hyperparameter tuning will take maximum 5 minutes or maximum 10 minutes worth of code, correct? It will not take you more than 5 minutes or 10 minutes. It will not take you more than, I don't know, CPU is absolutely cheap, right? Your computer CPU is enough to run it. If you want a GPU access, GPUs are what, $12 an hour? For an 8 gigabyte RAM DDR4, 12 gigs of RAM GPU is what, $12 an hour. It's not very expensive. Your company can afford this. So if the data set size is like 1 million, 2 million, 3 million, run the hyperparameter tuning and see what's the harm. But don't run hyperparameter tuning unnecessary when you know the model is already performing at the best optimal capacity. Tuning it further and increasing the accuracy by 2% isn't going to make much difference. There is no law, there is no rule that it has to be run every single time. But I personally prefer running it because I want to know how better can I do? What better approach can I implement? Okay, that's why. So now, can I say Katie because I have taken my hyperparameter and I think somebody said random search. So can I say random search is a part of hyperparameter tuning? Yes or no? What is the name of my model? Is the name of my model create model, everybody? The name of my model is called create model. How did I create model? Did I create the instance of a model like this? My initial model is called create model. So tell me, what is the object that I took? Initial model. But what is the name of my model? Create model. Yes or no? So I am passing down not the object, but the name, the proper name, create model. What will be the objective of this particular hyperparameter tuner? I want to calculate something called validation accuracy, ACCURACY, because that's the one that's not doing correct. No. Validation accuracy is the one that I am more interested about. So tell me one thing, what is my objective? How many trials do I want to run? How many optimized models does it want to calculate? Can I say 5? Up to 5 trials? Run only 5 trials. Run only 5 trials. Why 5 trials? Guys, tell me one thing. My question to you all is very simple. If I tell you, you have 5 t-shirts, red, green, blue, yellow, orange. You have 4 pants, white, black, gray, and blue. And you have 3 watches, golden, silver, and leather. Guys, what is the permutation, what is the combination possible through all these variables? What's the combination that's possible that I never repeat the whole thing once again? So tell me one thing. If I told you that my neural network's first layer will be 16 nodes, or my first neural network or my neural network's first layer will be 32 nodes, then 16 nodes, then 8 nodes. The second layer will be 16 node, 8 nodes, and the fourth layer will be 8 nodes and 4 nodes. How many combinations are possible for this particular data? Everybody give me the answer fast. How many are possible? 3 into 2 into 2, 12. So tell me one thing. When I say max trial is equal to 5, it means this will be one random value. This will be another random value. This will be third random value. This will be fourth random value, and this will be fifth random value. Out of 12 possible combinations, random 5 combinations will be tested. Understanding? It will not try all the combinations. It will try 5 random combinations, and out of those 5 random combinations, which one works best, it is going to give you that answer. Are you understanding? This is the core philosophy behind random search. Grid search would have done every single permutation and combination. Yes or no? But tell me one thing, between grid search and random search, which one would have taken absolutely humongous amount of time? Grid search. Grid search would have taken so much amount of time that it would not have made my life easy. But random search, I am only running how many maximum trials, everybody? 5. It is randomly going to select the parameters for you. Are we clear? Agree, disagree until here? Okay. Now guys, after you mentioned this, you mentioned something called directory. Okay. Now, don't worry about the word or the whole thing. But what you have to do is you have to mention a keyword called directory. Okay. Directory is equal to Keras, Keras underscore tuning, Keras tuning, and the project underscore name, whatever project name you want to give, churn underscore prediction. Okay. So tell me one thing, sir, what is this particular variable tuner doing? Tell me one thing. How many different values have you taken? First of all, the name of the model itself, correct? The name of the neural network or the model you have taken. What you want to fix, on what basis you want the fix, okay? On what basis do you want the fix that you have taken? Validation accuracy. Sir, does it mean that every single time I have to take validation accuracy only? Can I not take accuracy itself? You can take whatever you want. Your objective is a list of values that is given. From that list, whatever you want to take, you can take. Nobody will stop you. Are you clear? Maximum trial is 5. The directory is equal to Keras tuning. Sir, what do you mean by directory? What do you mean by this? Oh, I am so sorry. I am so sorry. This is not trail. This is trial, which is IALS. I apologize. So let me tell you one thing. It's an honest confession to all of you. I am a user of Visual Studio Code. I'm not sure if you guys know this, but uh, if you've heard of Visual Studio Code, it's this beautiful IDE, right? Integrated Development Environment. The problem with this integrated development environment is, do you see I have this particular thing called spell checker? Like if I want to have a code spell checker, so even if I make a mistake of writing a wrong spell, or write down the name of the spelling wrong, or if I make a mistake on anything, the spell checker will help me make my life easier. So what's happened is, because of consistently using Visual Studio Code for the last 13-14 years, my spellings have completely taken a toss. So maybe if a Western country wants to invite me for a speech, and if they decide to take my test on spellings, I'm pretty sure I'm going to be failing. That's a guarantee. It will completely depend on the algorithm. Sir, what do you mean by directory? Sir, here you have taken something called directory, right? Directory is equal to Keras tuning. Sir, what does it mean? What is the meaning of this? Right? So tell me one thing. In Keras, everybody listen to me carefully. Okay. Guys, whenever you specify something called directory is equal to Keras tuning, right? What happens is Keras tuner saves four things. Okay. Keras tuner will save four things in your model or in your local system. One is the Keras logs. The second thing it will save is something called as the config path. And the third thing itself will be the config files. Okay. So three things are automatically saved when you do hyperparameter tuning. You know why? Because when I do trial number one, I need to save the file somewhere, no? Trial number one's result, what the results are. Then if I run trial number two, what the results are. When I do trial number three, what the results are. Four, what the results are. Five, what the results are. I need to save a lot of details for each individual trial, right? That's correct, Munna. You're absolutely right. Are you understanding, guys? For each individual model, it will save all the files in your local system, which is the log file, which is the Keras logger, the config path, and the config file. When you mention directory is equal to Keras tuning, it automatically by default takes care of that for you. So if you ever want to run a Keras tuner, please do not miss this line of directory. What will happen is if you want to create a pickle file, it will become a little complicated towards the end of the class, okay, or towards the end of the program. So always mention directory is equal to Keras tuning. It will save all of that for you, okay. Conflict path, okay, not conflict path, config path, configuration path, config, config, config. Okay, so let me explain. When you have a folder, when you have a folder, does the folder, have you seen the folder have a name C//programs, Toby slash Philippines slash my file slash my folder.csv? Have you seen a path like this? Yeah, this is called as your config path. You understand what I'm trying to say, right? And every single file inside this path is called as a config file. Okay. If you want to find the name of the file, my file name is called my_love_ml.py. If you want to search this file throughout your computer, have you never used grep or awk? See, to be a good machine learning developer, you also need to do server-side scripting. Believe it or not, I'm not gonna lie. I'm not kidding. The knowledge in system design, infrastructure, understanding what Azure is and all of this, when you open up or spin an SSH, do you think you have a button to click on your folder, go inside the folder? No, right? grep will be your helper there. Imagine if you have a Linux server, you have SSH'd into that server. What will you do to create directory? Don't you use the command mkdir, create the directory, create a file called touch space my.txt. I mean, you use these commands, right? This is an absolute and 100% requirement for every single person in this class. Guys, it's super critical. Super duper critical. Either Unix, Linux based commands, or in Microsoft, you have something called PowerShell. Learn whatever you want, does not matter. Any shell command you want to learn, but please learn. I would like to give shell commands 5-star rating. Absolutely critical. Sir, how server side scripting, how difficult? I learned it in a day. SQL can be learnt in maximum 2 months, max 3 months. Just like that, server-side scripting, I'm not talking about bash scripting. I'm not talking about that. I'm talking about simple script, simple commands. One day, more than enough. Don't go high level. You don't need that. Now, guys, listen to me carefully. I am teaching you a concept right now. I want you to make a tattoo of this in your body, in your hand, in your leg, in your arm, in your chin, does not matter. And the concept is called early stopping. Everybody, I want you to please pay attention right now. This is absolutely critical. When you're running a neural network model again and again and again. So suppose you ran the neural network model 1, the loss was 0.50. You ran the neural network for the second epoch. This is the first epoch. Second epoch, my loss is still 0.50. I'm running my model once again. My loss is again 0.50. If I'm doing my model again it is 0.50. Is my loss decreasing at all? Is my loss decreasing at all? But you know how many epochs did you said? You told the neural network run for 100 epochs. After 4 epochs, if the loss is not decreasing, is it going to decrease for 100 also? No, it's going to remain the same. But are you wasting your time, energy and effort in running for 94 more epochs? Your model will keep running and running and running and running for 100 times. But you got the idea here itself, right? That my model is not decreasing. So when the losses are constantly the same, they are not decreasing, there is no improvement. What can you use? Early stopping. What can you use? Early stopping. If my losses are not decreasing consistently, they are the same value again and again. After 4 value, stop the neural network automatically by itself. Tell the neural network, stop, don't run further. Are you understanding? Are you getting it? Now tell me one thing. If I can monitor for loss, can I also not monitor for accuracy? If the accuracy is not increasing over a period of time, stop the model. It's wasting my time. Everybody, what am I going to implement here? Early stopping. What are we implementing? Early stopping. Stop underscore early, EARLY, early is equal to TensorFlow dot TensorFlow dot Keras dot, I'm assuming, give me one second guys, I'm so sorry I forgot. TF dot Keras dot, I'm assuming it's in the callbacks mechanism, right? Callbacks, early stopping. Oh, perfect. Oh, thank God. tf.keras.callbacks.early stopping. Give me one second, guys. I just need to check if I am taking the, so monitor is fine, patience value is fine. So I think I only need 2. Okay, so I'm taking it correct. So tf.keras.callbacks, callbacks backs dot ear. Did I import TensorFlow properly? I'm assuming I have imported TensorFlow properly, but it is not populating my TensorFlow part correctly. Maybe I did not import TensorFlow properly. Give me one second. Let me check. So import TensorFlow as TF. I have done that. I did not make a mistake in importing. Okay, no problem. Then let me just copy paste the same thing. tf.keras.callbacks. Okay. I always go wrong with my absolute brilliant spellings, so I don't want to risk it. Let me come over here and let me paste it. So let me say tf dot, oh, I'm so sorry. Instead of taking Keras, I took it as gears, right? Yeah, that was the most stupidest thing to do. Anyways, so what did I do right now? I have implemented something called Keras, early stopping, and inside the early stopping, what do I want to monitor, everybody? What is it that I want to monitor? I want to monitor the validation loss. Are you understanding? I want to monitor my validation loss. And what is the patience? Patience will be equal to 5. What do you mean by patience equals to 5? My patience equals to 5 meaning if consistently for 5 times the loss is not decreasing, then put a stop to it. Max to max check for 5 times. If the consistency repeat, stop it. Are you understanding? So did we implement something called early stopping also, guys? I made a smart decision of running hyperparameter tuning with early stopping also. But if we do early stopping, it can stop our model after want also, right? If you are not getting any improvement, tell me one thing. I'm just gonna bring in some real life examples. Let's say you are with somebody, you give your energy, your soul, your strength into the relationship, but the other partner never returns the energy. You will wait for 1 year for that person, 2 year for that person. But what about the third year? Will you leave that person because it's no longer working out for you? It's not good for your own personal health. Now, let me ask you a simple question. If this condition has to be applied on a neural network, I ran my neural network for 80 epoch, 90 epoch, 100 epoch. But is it not wasting your effort, your energy? First of all, compute resource are being wasted. Second of all, your energy or your time is being wasted. If my model is not increasing, it's adamant, it does not want to improve, does it not make sense to just stop? That is the logic for early stopping. And this is why it's a very important process. Very, very important process. Remember, without this, you can. Okay, now, tuner.search. Guys, if I actually want to perform hyperparameter tuning, please listen to me carefully, okay? Tuner. I am passing something called X train skilled, comma Y train. Any question if I pass the X train and Y train for the tuning? Because this is how my model will. Epochs will be, okay? Validation underscore split. How much validation split do I give my people? 20%? Agree, disagree? Because you have implemented early stopping, there is a argument called callbacks is equal to, inside this, pass the variable called stop early, stop underscore early. Okay, can you see, guys? I have mentioned my tuner dot, and I think we can also take verbose equals to 1. Verbose equals to 1. So what did you understand from this piece of code, everybody? Guys, what do you see in this piece of code, everybody? Do you see that I have given the values for the tuner to search to perform the hyperparameter tuning? If I write it down, perform the hyperparameter tuning here, yes or no? Once this is done, can I go ahead and run the model? Okay, what answer did I get? Cannot convert 5 to a shape. Let me check what mistakes did I do. kt.random search. What did I do? Okay. Create model. Do I decrease the size? I think it's not because of the max trial for sure. Okay. Let's look at the error carefully. It says cannot convert shape to a shape. Cannot convert 5 to a shape. What do you mean by cannot convert 5 to a shape? Okay. kt dot random search. Did I make a mistake somewhere? Let me just check. Keras tuner dot random search. Okay. I have taken my random search create model, which is the name of the model, which is fine. I also have passed in the objective as none. Objective can be any of my objective argument which I have passed, which is fine. Max trials is equal to 5 and directory is equal to, so where is the directory part? Okay, wait. Tuner is equal to tuner. Okay, but I think I can anyways give it as a part of it, right? So if I pass that particular thing as, so where is the value checker for changes? kt.random search instead of kt underscore. Is in the shape, I'll explain. Can you see here? I've imported Keras tuner as kt. So kt is my alias. Munna, I have taken the Keras tuner itself as kt. So my kt is no longer Keras tuner. It's just the alias that I've taken. So kt also works. That's not the problem. I'm assuming the problem is in the shape, but let me figure it out what the problem is. Give me 1 second. Let's run this 1 point at a time. Let's try to solve this. Kt, wait, hold on. Did I make a stupid mistake? Kt.random search, create model. This is the name of my model. And once the model is created, which I have done, oh, okay, wait. So did I take it correctly at the top when I ran the model accurately? I did that as initial model, or my initial model should be the create model part, no hyperparameters passed, and I have printed the summary. So to get the idea, I passed in the scaled value, which is the X train scaled, and my Y train value, epochs will be fine. So I will move this particular thing towards the bottom. And my tuner part should be able to give me the value for the tuned value. So it will say what? Validation accuracy. And it will also give me, okay, so can I change this to maybe 2 or maybe 3? Maybe 3. Okay, I'll just try to give it a 3. And let me not run the tuner yet. And let me see if it's still giving me the error. Oh, it's still giving me the error. So, kt dot random search, create model, model is passed, objective is passed. Is this the right spelling? Validation accuracy? Give me 1 second. Is this validation underscore accuracy? Val underscore ACCURACY. The max trials that we have is 3. Max trial in place of max trials. No. It should be max trials. So if you can see here, I can see that it is max trials. TRIALS, which is TRIALS. That's not the spelling problem. It's not the problem of the spelling. So Keras tuning is done as well. Why does it say that the conversion is going to be cannot convert 5 to a shape? So I'm assuming it must be getting some kind of a string value. Okay. Validation does not run for 5. I have no idea why I'm getting this error. Give me 1 second. Let me check. kt.random tuner. Let's see if somebody has solved this problem. I'm reusing this after a long time. Okay, so how did this guy use it? Okay, this is using a convolutional network model. Okay, build model. This is the name of my model. So build model, that's correct. I have taken the same exact thing. Let me close this. So if I call the model itself directly, give me 1 second. Let me CREATEMODEL. Let me just, for simplicity purpose, come over to the bottom and pass in just so that I have not made any mistake. Create model, no problem. And then you can pass in objective is equal to val accuracy, max trial equals to fine, directory equals to tune. I think I can take this and chuck it out. So let me just chuck this out, Control X, and let me just paste it somewhere here. And let me also Control X and paste it somewhere here. Okay, let me close this and run it once again. Churn prediction. Oh, apologies. Let me Control Z, Control Z, Control Z. Okay. So let me remove this, put a bracket towards the bottom so that the bracket is matching. Max trial is equal to this and this. Okay. That is not the problem. The problem is something else. Has it been deprecated by any chance? Pip install Keras underscore tuner. Give me 1 second. So Keras tuner. What version of Keras tuner do I have? I think it is 1.4.7, right? So give me 1 second. Let me check. Did I install Keras tuner recently? Yes. So it is 1.4.7. This is also 1.4.7, which is fine. We've taken the value correct. So if I have taken the value correct, which is how I did it, okay. Let me check why is this not giving me the value. Okay. Keras tuning is tuner is equal to kt dot random or can I do this? Or I think I can do a much better thing, right? So if I directly just take it like this, right? So if I say kt dot random search and run this. Hyper model is equal to none. We only allow not specifying hyper model if the user defines the search space in tuner.runTrial. by subclassing a tuner class without the hypermodel instance. Okay, 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 okay. So if that is the case, then I will just pass the create model. Wait, did I make a mistake somewhere here? If hyperparameter tuning is different, I took the sequentials part. So it is causing the problem in the if condition. Let me see what the problem is, right? So layer dot dense, I've taken the units. The units is fine, values are fine, activation is ReLU, input shape is also given, which is not going to be a problem. I also took the hp.bool, which is the second layer, model.add, layer.dense, units equals to hp.choice, units to values equals to 16,30, activation ReLU. I also gave it the model and I also gave it a dense activation function, and the activation is sigmoid, which is correct. And the model.compile optimizer is Adam, loss is binary cross entropy. So CROSSENTROPY, which is fine. Metrics is equal to accuracy, that is fine. I go to the else condition. Even if I do that, so that would mean, sir, shape 1 is causing error. It's that, my dear. It's not the shape. It's always the way the layer is defined. It's not the shape. It's not, I don't think so. That's the problem. Okay, let me see how the works. So in my activation, sorry, in my last layer, I have taken 64, 32, 16, and 8 and 1. So activation is ReLU, 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 ReLU for all four. Sigmoid is this. And the scaled value is going to be reframed into a symbol value. So this is also xtrain scale dot shape equals to 1, which is fine. So this model ran, the whole thing ran as it is. How about if I take a different kind of a search metric? So maybe instead of hyperparameter tuning it with random search, let me do kt.grid search. But I think this also should work. Kt dot, wait, what? Wait, did I make a mistake somewhere? I think initial model is fine. This is fine. This is also okay. So if I bring to my code, kt dot grid search. Right, so if I just come over here and type kt dot, let me copy this, let me paste it here, kt dot grid grid search. Hyper model is equal to none, objective equals to none, max drive equals to run. So optimizer is hp dot choice, model name, values is equal to sgd and Adam, learning rate is equal to hp dot choice, learning rate is equal to this. Okay, did I also take it like this? But I don't need to pass in the model name. So which is units 1, which is fine, the one that I have mentioned as it is. And I have also passed in the value, and it is hp dot choice, but before passing it to hp dot choice, it is to be hp. I am not sure why this seems to be the problem. Okay, fine. Let's do one thing. Let me figure this error out. I gotta see what seems to be the error. So I'm gonna teach you hyperparameter tuning. Maybe I need to see what the whole thing is. I have not seen what the callback mechanism, sorry, what the tuning mechanism does. I need to check what this is, and I'm gonna come back to you in a second. But let's say if I would have done the tuning issue, and if I don't pass it, then again it's like something that you don't handle it that easy. And I am assuming, wait, give me 1 second, guys. What does the scaled value look like? Give me 1 second. Oh my God. I think I get it. Wait, I understand now. This is a 1D data, right? Guys, I think this is a 1D data that I've passed. Why would we do this? We know for a fact that the shape format changes, right? Absolutely correct. It does. Let me remove this and let me check only for the tuner object. Give me 1 second. Oh, remove this and remove this. Cannot convert. Okay, give me 1 second. Even if I did change it, see if I can change this particular thing to the input shape. Now it is maintaining the dimension, but it is still giving me that error. Yeah. So I think I need to figure out. I'm very sure it's something to do with my if condition. I am very sure it's something to do with the if condition. It would not run without the if condition issues, because that's the one that I'm trying to actually check. So I'm gonna check it. Don't worry. I'm gonna let you guys know what the issue is. I'm gonna figure it out. I have to sort of check it and let you guys know what the hyperparameter tuning issue is. But yeah, let's not let this stop us from implementing anything important. So tell me this. The best model that I have run so far. What is the name of the best model that I have run so far? Which is the else condition model. What is the name of the model? Initial. My best model so far is the model by the name called initial model. If this model I am very satisfied with, I'm the most satisfied with this particular model. Okay. This particular model that I have run, I want to save it. Now tell me guys, have you guys learned the concept of something called serialization? Anything called serialization or no problem. Suppose a neural network has run and understood the data really well, and the knowledge and the intelligence of the model I already know. Instead of running the program every single time again and again, is it a way to save the intelligence somewhere? The answer is yes, you can do that. When you run machine learning, when you run a machine learning program for say decision tree on a data of 50,000, your Jupyter notebook dies after a certain period of time. The kernel will die. Will you run the 50,000 data sets again for the decision tree, or will you run the decision tree and save the intelligence or save the model? We agree, disagree? Just like that, which is the model that I have created? I have created a model called initial model. This is the name of the model which is currently running, which ran for my entire data set. So if you can see, the model that I ran is the model that I actually created. But tell me one thing, if you want to build a model, or if something has to be built, after you create the model, you summarize the model, actual model will be implemented by the name of the variable history. Agree? Because this is where you have done the dot fit. Am I making sense? You have run the dot fit, and this is the name of your model. So if I actually print history, okay, just listen to me. HISTORY, history. Can you see? It's written like this is the model where I have actually done something, create a sort of like a fit of between two models. So if I want to run this piece of code, what does it mean? Like, sir, what do I save? How do I save it? Okay, first of all, have you guys heard of a concept called pickle everybody? Not the one that we eat, but the one that you guys use in Python. No? Let me help you explain something. Very important concept. Do you see something called Python object serialization? Okay. When you run the model and you save the model, you can save it as a pickle file. But the problem in pickle file is, pickle file is saved as a binary file 01001001. Can I say this is a binary? This requires a lot of memory and a lot of resources to be converted. Instead of using pickle file, you have a format called .hd. In neural reinforcement learning, computer vision, natural language processing, in all these fields of machine learning, you guys save your model max to maximum in a file called HDF5. HDF5s I call hierarchical data formats. The full form of HD5 is hierarchical data format. See, listen to me carefully, okay? HD5 extension is called .h5. Are you? So how your file names are written as my underscore file dot txt or my underscore file dot docx file. This is one of the extension of saving the file. Are you understanding, guys? So .h5 is the extension of saving any model that you want to save. Sir, how can I save any model? Very simple. Come over to the, just mention history dot save. What do you want to save the model as? My model, my underscore model dot h5. What will this do? What is this going to do? Run this. Now see, this particular thing called dot save will be like history object has no attribute save. This is one of the problem that you are going to encounter every single time you are going to save something. And the problem is, sir, I am trying to save the history, the model which was written to me and the top. Okay. So see here at the top, the name of my file or the folder is called history. Can you see here? Where I have done something called initial model.fit. If I directly try to run this initial model.fit is equal to run or try to save it, it's not going to do it because there is one small problem in Python program. What is it? Have you seen or heard of a concept called with keyword in Python? To last class, did I teach you guys a way to open a file, close a file with the with keyword? In the, sir, we don't know what. Okay, so let's say you want to I don't know, write a file or create a file. How do you create a file in Python? So let's say I want to create in Python. Okay, if I want to create a text file in Python, how do I do that? Can I use the with? If I just want to say with statement, so for example, okay, assume with, what should be the name of the file, everyone? Can I say Python underscore basics, BASICX dot txt? Can I say it like, okay? You want to write and create the file, yes or no, guys? You want to write it. You want to append on it. So what will you write? W. W means write as file file. Okay. Now file dot write, WRITE write. What do you guys want me to write in the first step? This is a class for neural NN. This is my first line. File dot write, okay, file dot write once again. Inside this I will say, oops, inside this I will say, this is my second line, line, and let me also give it like a slash n here and a slash n here. Okay, slash n here. Now if I run this piece of code here, did it run? Did you guys run this piece of code? Can you see here? You've created a file called python basics.txt. Is this visible in front of you? This is a class for NN. This is my second line. So tell me, while doing file handling, is with an important keyword? It is. Okay. So tell me, if I just directly come here and say history. Sir, could I save a file like that? Say, you can, no doubt about it. If you previous classes, did I not teach you how to save a pickle file? Just, yeah, right here. I taught you guys how to do this. Now tell me one thing. Sir, could I have saved my history also as a pickle file rather than saving it as h5 file? Yes, you could have done that. But the topic I am more interested in teaching you. Tell me, when you create or write a neural network or train a neural network all yourself, actually when you're saving the .h5 files, sir, what are you saving? What is it that you're actually saving? Guys, you are saving the value of all the weights and all the value of biases. Are you understanding, everybody? When you say I am saving the intelligence of the model, or I want to save the model's intelligence, all you are saving is nothing but from my input layer to the hidden layer number 1 to the hidden layer number 2 to hidden layer number 3 to my output layer. What were each individual weight values? I am saving all of them in a dictionary format. Actually, not in a dictionary format, but for example, and all the biases value are also going to be saved. But apart from your weights and biases value, your logs are also going to be saved. Metadata like when was the file created, and this file is not directly readable. It will be converted into its own format, and that format is what you call as a .h5 file. Because so many values are being added, tell me one thing, won't the memory of the file will increase? To make sure that the memory of the file retains same, it follows something called hierarchical data format. What this format does is, if you want to save a certain amount of data, certain compression, I'm not exactly going to say compression, but it will make the file appear smaller in size. Now you can ask me one question, but sir, why is this concept very important for us to learn? For two reasons. Tell me one thing. Are you going to literally hand over the neural network code with all the graphs, all the analysis that you've done to the developer or a DevOps or a ML? Is this how you hand over your program in a company to somebody to put it on a server side rendering? Or absolutely not. What do you do? Do you not run your model, do your analysis, figure out the best model, and that best model you save? Yes or no? This model is then passed on to your server, or saved in the server, and that server is going to give the prediction in the future. Are you understanding? But let me ask every single person a small question. Guys, if you work in a company like e-commerce company like Myntra, Flipkart, Jabong and all of these companies, specifically talking about Indians, right? We Indians are very easily influenced by new products in the market, correct? So in January and February, we loved wearing Korean pants. But in March and April, we love wearing, I don't know, Jamaican pants. Example. So tell me one thing. The neural network was trained on the previous data. But what if the trend shifts? Is my neural network going to understand that the trend has been shifted? No. The predictions that I'm going to give are still going to be relevant from the previous history. In this case, my people, the best friend in your life will be a topic called ML Ops. Have you ever heard of? You've never heard of this? Okay. Whenever your data shifts slightly, you train another neural network model. This is called neural network model underscore 2 updated model. Your neural network underscore 1 is already serving the customer. Suddenly, you replace the neural network 1 with neural network 2. Now, customers will be served by neural network 2. All this will be done without one customer facing any downtime or any problem. Are you understanding? The customer won't even realize the neural network model went. Making sure you manage multiple models at once, and this particular philosophy of ML ops and even more is going to be handled. In that case, your H5 files or your H5 files are going to be pretty handy. Are you understanding? If you guys are okay, do you want me to teach you how to build an? So the neural network that you create, would you want me to teach you how to upload it on a server and access it via an API, a public API? If you do this, you don't need anybody else. You will be able to crack your interview with absolute comfort and peace of mind. If you guys API, and we'll see it face to face, how it actually works. Are we clear?
Hello everyone. Intellipaat offers executive postgraduate certification in data science and artificial intelligence in collaboration with iHub IIT Roorkee. Through this particular course, you'll get to learn multiple tools like Python, PySpark, SciPy, NumPy, Pandas, Matplotlib, TensorFlow, Git, etc. You are going to learn multiple skills like data science, natural language processing, deep learning, fundamentals of generative AI, prompt engineering, and application based generative AI, as well as recent trends like agentic AI. This course is designed to get you ready for the AI world. So do check out link available in the description. Also through this course we have already helped thousands of learners take positive step in their career. You can check out their testimonials on our Achievers channel.
Yesterday, I was trying to build the Keras tuner. I actually did that and I'm going to show you the output. I actually wrote the code for Keras tuner. But one small update for everybody, Keras tuner has some methods or functions that are deprecated. Okay. What you mean by deprecated is, I'll give you guys a small idea. You'll get an understanding what I mean, right? So see what happens is, suppose a library like NumPy is written, okay? Now NumPy is a library that's written by a group of developers, okay? What happens is, suppose if NumPy started with 1.2.1, now some new updates were made to the library and the newest version is called 1.2.2. Then again, a new update was made to NumPy, so now it becomes 1.2.4 example, right? Every single time the version of the library changes, suppose in NumPy 1.2.1, there was a method called dot sort, right? If you update the library to 1.2.2, it might have the same method like dot sort, again dot sort. But when they updated the library to 1.2.4, the dot sort will not work because this dot sort method is now changed to dot underscore sort underscore method, MET underscore. So this is what you call as deprecated, meaning the older version's method does not work with the newer version's method. Okay. So I have also seen the updated documentation of Keras Tuner 1.4.7. There have been some changes. Let me explain what those changes are and you'll get the idea. Yesterday's class, I told you that we take a very simple variable called tuner and I am importing something called kt.random search. And inside this random search, I have taken the same exact thing, which is the create model, which is the name of my model. The objective for me to work on is my validation accuracy. The maximum trial I want my neural network to run will be 5. The directory is Keras tuning, which is how it will maintain certain things within your application, like a config file, config path, multiple other thing. And if you want to name the project, you can also do that. I have named it as churn prediction. I also implemented something called early stopping. Early stopping basically means if the loss functions have been constantly decreasing or increasing or there is no change, they are consistent, there has no update on it. If it sees it for maximum 3 times, it will change or stop the neural network from functioning altogether. Okay. So this is what you call as a callback. Basically, sorry, TensorFlow and PyTorch, both of these frameworks support something called callback mechanisms. So please understand, early stopping is an absolutely important aspect. Okay. Sir, what is objective? Objective means what do you want to run for? What is the objective metric that you want to see when you want to tune a model? Do you want me to see accuracy? Do you want me to see validation accuracy? Do you want me to check loss? Do you want me to check validation loss? On what objective do you want me to work on this function? So that objective means this, and you can only and only give one at a time. Okay, one at a time. In PyTorch, you can give two as well. Okay, in PyTorch, you can give two. Okay, here value can be different. Yes, you can change the validation accuracy to loss, to validation loss, to accuracy, anything that you prefer according to the objective or the goal of your problem. Okay. What I'm doing here is I'm passing a method called tuner.search, and inside this I have passed the xtrain data, which is scaled, ytrain data, the number of epochs, the same validation split, but this time I want my neural network to work with the callback mechanism. Meaning, if you don't see any improvement or decrement, if you see consistent numbers, stop it. I don't want it to work anymore. I want you to stop it. Okay. Now, this is the portion where I saw yesterday that there is a change in the way you get the hyperparameter. Okay. So let me give you guys a small idea. Let's say I am building a decision tree. Okay. So tell me guys, when I build a decision tree, the decision tree split. So example, the node is split like this. Example, the way you split the node is decided on Gini impurity. It is decided on the base of Gini impurity. Apart from Gini impurity, there is also something called entropy. Agree, disagree? Entropy also splits my data into two. Or there is another thing called log loss. Right? If you guys have heard of the concept called log loss, there are three different types of methods that can help you split a decision tree. Now tell me one thing. If I want to build a decision tree, I can also decide how deep the decision tree is, correct? Is it only one height decision tree? Is it a double height, multiple layered decision tree? I can decide that. Okay. So remember one thing. When you build a decision tree, there are many ways you can build the same decision tree. Out of these decision tree, for example, my splitting criteria could be Gini impurity, could be entropy, could be log loss, right? My depth of the tree could be 5, could be 6, could be 7. When you build a decision tree, depending on the data that you are building it on, we get the output that if you build a decision tree which splits on Gini impurity with a depth of 7, this is giving me the maximum accuracy. This is the aim of a hyperparameter tuner. It will tell you out of the permutation and combinations for all these values, which tree, which hyperparameter gives you the best or the maximum accuracy. Just like that, in neural network, we have a method called .get best hyperparameters, and number of trials that you run is 1. Because this returns a tuple, we return something called index 0 because this is what we want. And when we print for param in best hyperparameters dot value and you print them, you actually get the output of which parameter or hyperparameter returns the best possible value for that particular thing. Okay, what is the index? If you have a tuple that looks like this, a comma b, 1 comma 2, and another array called a comma b. If I return an index called 0 for this particular tuple, example, this is a tuple called t is equal to this. If I write t of 0, what will it return? Is it not going to return the first index, the one that returns this particular value? So when I write down the index in this particular path, this is what I'm expecting it to return because the hyperparameters are available in everyone is clear that this is not a very complicated Python method. You write down 0 to return the index of that particular tuple. Okay. Now guys, the most interesting part of the entire hyperparameter tuning is this line of code and this line of code. Now everybody listen to me carefully. Have I already passed to my tuner what is the name of my function called create model? I have already passed the name of the method that I want to work. If you go back to the name of the method, can you see here? If no hyperparameters are passed, it automatically goes to the else condition. Okay, observe this and you will get the idea absolutely clear. What am I doing? I am saying that my best model is tuner.hypermodel.build and you are passing something called best hyperparameter. Are you passing the hyperparameter to something called tuner, which is already mentioned here, which is right here? Tuner is equal to kt.random search. Yes? you are passing a reference to an object which is already mentioned on top. Now listen to me very carefully. Do you see that I have taken a model called best history is equal to best model dot fit, X train scaled, Y train scaled, epochs is 30, batch size 32, validation is 20%, and verbose equals to 1. What this piece of code does, I want you guys to observe this very, very carefully is, right? If you see this piece of code, I want you to just focus on this piece of code even more than the other part of the code. See what this does is, see, you have this method called hypermodel, okay? You have a name of the method called hypermodel. I want you to focus on this. And I want you to also focus on another variable, sorry, another keyword called dot build. Now tell me one thing. My tuner has a reference to something called create underscore model. Inside this tuner.hypermodel.build, am I passing the best hyperparameters already? Meaning I am passing some hyperparameters known. I already know what kind of those hyperparameters are. And this best model, I am then passing a reference to this particular thing called best model.fit. Can you see? Once I realized what hyperparameters are actually giving better accuracy, I am passing the same thing to the model.fit method. Meaning, I want to run the entire neural network based on the hyperparameter that I got. But observe one thing, guys. When I wrote down my neural network in the first go, the create method model, do you see I have given something called the optional as a second? It means that only and only if one layer is enough to run the entire neural network, only and only the first layer will be run. And all the random values 32, 64, 128, the optional second layer will not be implemented at all because my first layer is more than enough for it to run. So if I come to this piece of code, right, run the model, observe one thing, guys. If I run the model, do you see I have plotted both best loss and best accuracy for the model? And I am doing the best model to the previous classes and I plotted the answer. Can you see the answer, everyone here? The best hyperparameter found was unit 1, which is layer number 1, should be how many variable? Sorry, how many nodes should be available in the first layer? 32. And in the second layer, how many layers have been found to work the best? 16 nodes. Once I run this model, do you see that if I subtract my best accuracy minus the previous accuracy and print it, can you see here? The initial model's accuracy was 80%. The tuned model's accuracy is 80.67%. What is the only and only 0.07%? So tell me, did hyperparameter tuning actually do any improvement? Or can I say that doing hyperparameter tuning actually gave me a better output? The answer is no. Let me tell you one thing, guys. If you build a neural network with 4 hidden layers and your accuracy is not coming good on these 4 layers, making and improving or increasing the layer is not going to do much. If 4 layers was not able or were not able to give you the accuracy of your choice, of your preference, increasing the nodes or the layers aren't going to help you do anything. You have just got to realize that there is the maximum that you're going to achieve. Either you will have to change the algorithm, either you have to increase the size of the data, but that is the maximum that you can achieve. Are you understanding what I'm trying to say? Wasting the time in increasing the layer, hoping that it will improve, will only end up wasting a lot of time and resources. So tell me one thing, guys. When I have tuned the model just for safety reasons and say that even though 0.07 percentage it has increased, I am happy with it. I am happy with 0.07% increase. Okay, let's say you are happy with the increase of 0.07%. So tell me, your previous model is called history.model, correct? If you can come over here, can you see here? History. This is the previous model that runs and what is the newest or the perfect model which has given you a better accuracy or not a significant accuracy but somewhat near. What is the name of that model? The name of the model is called best model. Can you see here? You have used something called best model is equal to tuner.hypermodel.build. This is your best model before running your fit. Can you see here? You're running this best particular thing, your best history and your best model. So here I have run something called tuner.hypermodel.build and I'm passing something called the best hyperparameter here so far. So tell me one thing. Sir, I want to save the best particular model that you have or I have achieved and I want to save it somewhere else. Point number one, why should we save? Why should we save the model? What is the core reason behind saving either the history, okay, or the model itself? Whatever you want to save, you can save both, the history and model both. What is the main reason? Because I want to reuse the entire model once again without training it again, correct? Without going through the training once again so that I could pass on the model to the server to any other instance. I want to reuse that particular thing again. So if I say the best underscore model, okay, MODEL model dot save. If you remember, I spoke to you guys about this method, okay. Now let's say best underscore model dot h5. Do you remember we had something called dot h5, which is called hierarchical data? Now tell me, my best model is named here. Okay, everyone listen to me carefully. My best model is saved here and my best history is saved here. So these two lines are code or these two lines of code are going to give me what? The history of my neural network and the model of my neural network itself, correct? These two lines are going to give me the best history will tell me the entire epochs, how many epochs did I run and the model itself, okay? When I try to save the model, okay, best model dot save best model dot h5 example, and I run this particular thing, okay. You are saving your model as an hdf5 file via model.save or keras.save.save model. The file format is considered legacy. We recommend using the native Keras format, which is model.save my model.keras. So tell me one thing, two things. I can save my model in the H5 format. This is one of the ways I can use it. This is one of the way that I can use it. But did you see there was a problem? We recommend using the instead Keras format. What it is telling you is rather than saving the model in H5, which is a legacy or an old method, I request you to save the model exactly in the same fashion called best underscore model dot save. And what will you write inside this, my people? The internal structure that has been defined by the Keras library itself. So can I say, I can say best underscore model sorry, not nodal, model model dot or underscore new dot Keras. Is this another way I could save, or is this something that could also help? Absolutely yes. But tell me one thing, a small question, everybody, just a quick question, okay? You used to work on HDF5 formatting and now suddenly you want to move to Keras. Tell me one thing, if you are already in production, your code is already live, do you think shifting like this is a very great thing? Or it will save your time, it will save the energy? Absolutely do that. See, understand one thing. .txt format and .docx format, are they different? They both save your textual data. Agree, disagree? See, text file will also save your, your content. Docx also will share your content. But the way you consume each format, isn't it completely different? Am I making sense? If you want to store how much money did you give to your friends, how much they owe you, text format is a better format. If you want to write a script for your movie, you can't do it in TXT, you do it in docx because it will allow you even more flexibility. Just because I'm getting this error, or not an error, a recommendation message, do you think it is something that you can follow all the way through? You don't have to, guys. It's a recommendation. even if it's a legacy system, till date, including in 2025, there are packages that use .h5 method till date. So just because it's a legacy method does not mean it's a bad method. I hope everybody got the logic. It's legacy, meaning it's old, but we still use it, including till date. Okay, H5 works best. Now, if you go to the file and if you go to the folder, can you see I have already saved the model called best model. Yes or no? Now tell me one thing, guys. When you ran the entire neural network, even before running the neural network, did you also save something called selected features? The features that my model says these are the best features for the neural network to run, correct or not? Instead of saving this as a array, right? Can I say that I can do, what can I say? I can also save the selected features, meaning I can also give the selected features to one of the other. Agree, disagree? So if I say with open selected selected underscore features dot pkl. Now tell me one thing. Am I using a h? Are we going to use h5 method? No. Because the data set size is so small, just 5 values inside it, I can save it as a pickle file. So what will I do? WB. WB means write binary. Okay, write in binary, and I'm going to save this as a file. I already taught a couple of this yesterday, how you can append new lines in the data. So can I say pickle, pickle? Now if I go back to my import statements, let me very quickly check if I have actually imported pickle library or not. I don't think I have. Let's see. I have, right? So I'm going to run this once again. I'm going to come to the bottom. I have imported. Now we'll come to the last section and I'm going to be like pickle dot dump dump. And what can I do? Pass in the selected features and write the file into the method. Now, if I do this pickle.dump, what is it going to do for me? What's the benefit I'm going to have with this? The selected features are also going to run that particular thing. So if I run this piece of code once again, if I come back, oh, I've already closed the file, right? So let me come over here, paste it here. What did I do? Pickle.dump, write to close file. Did I take it? Oh, I did not complete it. Sorry, file. Yeah. So if I come over here and see selected features are also already updated here. Selected features.pkl. So I have run both my updated method, which is the best model.h5 and selected features.pkl. Now, if you club everything together in a folder, right? If you want to give your folder away to your colleague, you already have a pickle file for what? Your selected features. You have a .h5 file for your entire neural network model. These are the two things that we can do. These are the models that I'll be able to give to my colleague for him to use. Now tell me, assuming you have already given the model to your colleague, what can he or she do? Like, what is that one thing that they can do? Will they consume the data? Will they be able to consume the H5 or the .h5 model that you have written? So how would you consume it? Like, how would I be able to use the data? So do I have to read the .h5 file and then work on it? So tell me, to consume my data, can I say load underscore model underscore component? Yes, I think I can give this method. Now tell me one thing. What is this method going to do? Define load model component. What will be the responsibility for this particular method? This method is going to make sure every single time you have some kind of a h5 file or a pickle file, this method will help you load that data to your model so that you don't have to rewrite the code every single time, but use the name of the method every single time. So tell me, if I have written down this method, what is the first step that I need to do? The first step is to load the model which is saved in the h5 format. So how do I do that? Model is TensorFlow.keras dot models underscore, there is a method called load model. Can you see here? In TensorFlow, within the Keras submodule, within the models, you have something called load model. And what will you pass inside this? Go to this particular thing, rename the file. So go over here and don't copy the path, just copy the file name. So I'm just going to take it model.h5. Now tell me, have I taken the name of the or no? Guys, please remember, this will only work on Google. This particular way of loading the file will only work on Google Colab. If you are working on your local machine, I want you to copy the path. Can you see here the file path? So if I paste the file path here, can you see? You have a file path, content slash bestmodel.h5. Let's say you are in the desktop, okay? You are in the desktop. Within the desktop, you have a name of the file called Harsh. Under Harsh, you have a file called machine learning. Under machine learning, you have a file called neural network. Under neural network, you have a file called best underscore model .h5. So remember, when you load anything like that, if your folder is available in desktop and you have to go all the way within, make sure you load the path and not the file. This is only going to work in Colab because Colab, everything is available right there. Understanding what I'm trying to say? Don't make the mistake that my code is not working in your local machine. It won't. You have to be very careful with the way you give the path. Now, I want to open my file. So with open, what am I going to load, my people? In this particular example, do you see I have loaded the model called scalar.pkl, which is the scalar used before the program. Do you remember we used a concept called standard scalar where we did one thing called fit transform and we also did something called transform. If I want the output or if I want my data to be transformed, I have to use this scalar. So can I call this particular thing called scalar.pkl? Now tell me, if you want to read this model, how will you do it? RB. RB means read binary. Because you want to read the model, you will end up calling something called RB as FILE as file. Now I will say scalar, the one that I'm using will be pickle.load load and you can pass FILE. So tell me one thing. Did I just load my scalar value also? The one that will scale or transform the values that are going to be passed as an input and I can change. So this is just for me to load the scalar value in the prop statement. After I load the scalar value, can I also load the selected features that because I already have the selected features data also available with me that I can pass it down to other developer to use to understand what is data point number 1, data point number 2 and data point number 3. So if I copy the same exact code, come over here and paste it, what do I need to change here in the .pkl part? The selected features part. So selected underscore FEATURES dot pixel. And I am also going to save this particular scalar as SELECTED underscore FEATURES. So tell me, did I load both the scalar to transform the data? I have also loaded something called as my selected features, correct? Every single time my function is called, what do I want to do? I want to return. But what do I want to return? I want to return the model. I want to return the scalar because this is what I want. And I also want it to return exactly what, everyone? The selected features. Agree, disagree? My function is done and it is going to help me every single time I'm going to load this method. Now, at the end of the day, your neural network needs to make some predictions in the future, right? This is one of the reasons why we have actually wrote the neural network. If I tell you what is my age, my gender, my X and my Y data, I want you to tell me whether I will leave the company or stay with the company. So can I also make a function called predict underscore churn because this is what I'm trying to do? Agree, disagree? To predict something, For example, whether you are going to be with the company or not be with the company, do I need to pass data inside this particular thing as an argument? I need to pass some kind of a data to predict. In Python, you must have learned something called as args and quags. Yes or no? Have you guys studied something called args and quags? Arguments and keyword arguments. Help me understand this. You guys know what args and quags are, right? In Python? What is called argument and keyword argument in Python? What these are? If you don't know, it's okay. Let me explain the concept. See, okay, so let me ask you guys something. If you want to add two numbers together, or if you want to add numbers together, right? Suppose you have a method called define sum and bracket, return something. Tell me, if I want to write a function that can take any number of value, 1, 2, 3, 4, I want you to add this also, 1, 2 also. If you write a function like this, define add of a, b, how many arguments have you passed? Only 2. But what if you pass 4, 8, 15? I want my Python to automatically handle that for me. So in that case, we have a variable or a concept called arguments and keyword arguments, right? So if I want to do that in my function or in my method, if I write one single star and say args, what will this do? Whatever number you want to pass, 5, 4, 3, 8, 40, 50, 60, 800, whatever those values are, will my function allow all those values to pass as an argument without giving me any error? The answer is yes, it will. It will just let me load the whole thing automatically. But we already know to predict or to make predictions for the neural network, what arguments did we take or what features have we taken? Have we taken 5? Number 1 will be tenure, number 2 will be contract, number 3 will be payment method, then monthly charges and total charges, yes or no? So if I come to the bottom, do I need to worry about it? Actually, no. I already know that the argument's length will be up. Don't need to worry about it, right? So tell me one thing. The minute I write down predict churn, what can I say? Model comma, scalar comma, selected underscore features is equal to, can I load this function, my people? The one that I've just loaded, load model component. The same exact thing called load model component. If I copy this, come over here and paste it, can you see here? I am also returning model, scalar and selected features. So load model component, I am done. Can you see here? Load model component, done. Now, I want to take input from my variable or some kind of a variable. So if I say input underscore data is equal to pd.data frame, inside this, what did I just pass inside this particular function? Did I not just pass something called args? A, comma, B, comma, C, comma, D, comma, E, or 1, comma, 2, comma, 3, comma, 4, comma, 5. That data I'm going to pass as it is to the pd.dataFrame part. And what will be the name of those columns? The columns or the name of the columns would be selected features. Yes or no? Because I already know the first thing is called tenure, the second thing is called something else, the third thing is called something else. So am I taking my input data and I'm converting it into a pandas data frame? If I take the data, can I use the data directly for my analysis? I can't. Do I have to scale the data? So to scale the data, input underscore scaled is equal to, can I use something called scalar, which I have already used here? Dot, what do you do towards the end of the data? Don't you do transform? You don't do fit transform, only transform. Transform what? Everybody? Input underscore data, the one that you have just taken or whatever you have passed inside the function. Once I have scaled the data, I am going to make the predictions. How will you make the prediction? Prediction is equal to model dot predict. Inside this particular thing, what will I pass? Will I pass something called input scaled? Yes or no? Input underscore scaled. The one that I have passed through the scaled data. Okay. Now guys, this is something that you guys will be a little confused about. But whenever you make a predictions in neural network, you have to pass in indexes like this, 0 and 0. Can somebody tell me what does it mean if I pass two indexes like that? 0 and 0. What do you mean by that? So I hope everybody knows what do you mean by nested array. I hope you know. For example, suppose if I have a name like this, Rudra, R-U-D-R-A, Rudra, comma, let's say, I don't know, Sheetal, right? Sheetal, comma, let's say I take another array called Toby, and let's say another array called Mike. So if I have this variable f is equal to this, if I only want to print Rudra, so can I say 0 of 0? In a two-dimensional array that you return, the predictions method will return. I only want the prediction value, which is the probability. Actually, it's actually the number, which I'm going to change later. But this is what the number will be, which is the prediction value. It's not going to be probability. It's going to be the number, which is 0 and 1. So I have already made the prediction, which is going to give me the answer like this. Whatever probability is, right? Probability, probability will be, convert this into a float point value and pass your prediction as it is. So what am I doing in this piece of line, my people? When I know that the predictions data type is not correct or proper, am I converting it into a type called float, and I'm making the variable called probability, which is the probability of my prediction, 70%, 50%, 60%, yes or no. So after I calculate probability, I can create something called churn status is equal to, if I'm going to say yes, my model or the customer will churn if the probability is how much, my people? So if the probability that I have taken is, what threshold do you want to keep, my people? Beyond 50%, can I say the answer is yes, the guy will leave the company, and below 50%, the guy will say no. So if the probability is greater than 0.5, the answer will be what? What will be the answer of the churn? The answer will be yes. Else, what will be the answer? Okay. Else the answer will be no. So once this particular model is done, what do I want to return? What am I interested in returning? I am interested in returning two things. Churn probability, which is going to be what exactly, everyone? It's going to be the probability value, which is this particular thing. I want to return both the probability, and I can return whether this person will churn or not. HURN. So what will be the answer of will churn? It will be churn status. Agree, disagree? So my function is going to make sure it returns this value whenever I use predict churn method, and I'm going to run this, right? Now tell me, guys, have you ever heard of a concept called Gradio? Or have you ever heard of a library called class? Okay. How many times has it happened that you want to build a front end for your application, but it becomes very, very hard because you don't know JavaScript, specifically React, or you don't know TypeScript, or I don't know if anybody uses Angular anymore, but yeah. You want to build a good looking front end, but you don't want to learn JavaScript, TypeScript, Angular, or anything like that. But you still want to do it. If you want to do it, you can use something called Gradio. Okay. I'm going to teach you how to use it so that we can have a very good, beautiful looking front end. Okay. So pip install, let me see if there is something called Gradio. How do we install this? Give me 1 second. Pip install Gradio. I'm going to come to this. I'm going to go to the very top. Give me 1 second, guys. And 1 second. Can I install it here? Come over here, pip install Gradio. Let me comment this out and let me install Gradio once again. Is it open source? Yes, it's absolutely free. It's absolutely open source and it can keep your application up and running for 1 day for free. And if you want to make it run forever, then you can use something called Heroku. Have you ever heard of this? Everyone? Any idea of what? So if you want to run your application and you want to run it for free, you can use something called Heroku. Okay, it is basically test deployment of sorts. It's not a very complicated thing, but it's okay, no problem. So guys, I installed a package called Gradio. If you can see here at the very top, can you see here? I just installed a particular package. Gradio is installed. What I'm going to do here is I'm going to import Gradio also. So import Gradio as I don't know. Yes, let's also import OS because I need to change the way I'm going to load it also. So let me also import OS. Okay. So if I come to the very bottom, guys, to make predictions in the future with the neural network, have I already written the method called predict churn? Is this already written by me? All I need to do is just use the method and I will be able to make predictions. Yes. I don't need to write a single line code, but I can use this particular thing again and again and again. The Gradio part is a little tricky to understand because Gradio has so many different things. Like for example, if I open and show you an example in Gradio, okay, give me 1 second. So Gradio, right? So let me show you an example. Playground. Let me open up playground. Let me open up, how do I open it up? Not this playground, but maybe something to show you an example maybe. Oh yeah. So if you can see here, RUDRA. Can you see here? I have a button called submit button, clear button. So if I click on submit, it gives me an output here. Hello. So I have a button given here, a text bar given here, and uh, this particular front end given to me. Can you see this? So this is how you are able to also sort of mention, do you want a button, the color of the button, the how many buttons do you want a slider or not? All of this stuff you can define. So I'm going to write down the code for you. You guys can understand. So let me say create underscore Gradio underscore interface. Okay, interface. And inside this Gradio under interface, let me actually load the component. So Control Z. I don't want this. Control Z, apologies. Don't want the name, don't want the name, selected underscore features. So 1 and 2 will be equal to load underscore model component. I'm going to load them first. Inputs would become what? An empty array of sorts. Then I would load them for feature in selected feature for all of them one by one. So selected features one by one. If feature in what was the name of the features that we took? Give me 1 second, guys. What was the name? Gender something something. What was it? Gender. Where did I load it? Okay, so this is the feature, right? Let me copy this. Let me paste it here. So if feature in, can I give it like this? If feature in tenure, contract, senior citizen, partners, and total charges, if the features are found, actually convert them into say input. The features will be converted to what? Change it to gr dot, maybe we can give it like a radio button. And the label that I'm going to be label, the label that I'm going to be passing here will be the feature, and the choices should be equal to this. Either the choice is there or either the choice is not there. And to give you guys an understanding, I can say that whether 0 would mean it is no, or that particular thing is a female, or if I give it a 1, it would mean the answer is usually yes, or the answer is usually a male. So male is 1 and 0 is female. So that would process the data in a separate way. For that, we have a radio button. And if in the else condition, if the data sets is different data type, then all the inputs that I have that I'm going to be taking for inputs inputs dot append, anything apart from the binary type would be used as a slider method. So gr dot slider, okay, its S is capital, and inside this, the minimum value I will give is going to be 0, and the maximum value, I don't know what the maximum value should be. So give me 1 second. Gender is how much? Gender and tenure, contract, payment method, monthly charges, and total charges. So gender is 0 and 1. Tenure is 134 something something. Okay, so to get a better idea, I can actually do something called df.describe. So if I run this, okay, so gender is 0 and 1, that's fine. Tenure maximum is 72. And payment again, what? There is nothing beating 100. Okay, so there is nothing called 100 as such. So I can give the maximum value as 100 also. So if I come over here to the very end of the data, maximum should be equal to 100, but only if the feature is available. Okay, but if that is the case, wait, if that is the case, give me 1 second. What would happen to tenure? What is the maximum size of tenure? So df.describe will be 72 and okay, and the maximum size of the data that we've taken is this much. Is it after the conversion or before conversions? Wait 1 second. Column numerical feature, column importance is done. Okay, so I can do it like this. Okay, so I can come over here in the bottom, and for safety reasons, I can say if the values are given, if the feature set FEATURE is just tenure, only and only if I check for tenure, else the whole thing should be up to 200 because I can give the numbers value is different. And the label I want to give this is, let's also give it the name of the feature itself. So FEATURE feature itself. Okay, if this condition makes sense. So inputs. So I've handled what? Both the binary features and the numerical features. Is there any other feature type available in the data? Wait, df.describe. Okay, let's take df.info once very quickly so that there is no error. So object is what? So basically payment method, no wait, gender, tenure, and what was the selected feature that we took? Payment method and contract. So contract is also int64. Payment method is also int64. Total charges is float64. Fine. Okay. So if I take interface is equal to gr dot interface, and inside this I can pass in the value as the predict churn. This is what I want the function to return. I want the input value to be just the input which is given to me. So the input would be input, which is the variable here, which is fine. The output of this particular function, so the output would be equal to the Gradios JSON object, which is JSON object. And inside this, the label would be churn prediction. Okay. We can also give it some kind of a description. Description will be equal to churn prediction neural network demo code. Okay. So we have given the description also. Or wait, could we say kindly enter data to predict. Okay, kindly enter data. Kindly use sliders and radio button to enter data, to feed data. Let's say it like this: to feed data. Okay, to feed data. Okay, description is done. I think Gradio also has a theme. Gradio theme. Just give me a second. What other themes there are? Monochrome, citrus, base, ocean. I think there was also something called Gradio hugging face. Radio hugging face theme. What is the name of that theme? Theme gallery is. Oh. So we have. So this is theme preview toggle. This small and pretty calm sea foam. Miku Interstellar Paris. Calm sea foam. Or if I can just directly give it hugging face. I'm not sure if this will work. Hugging face, just like a hugging face theme. And examples that I want to give it for the data would be, I think, something like this. So for tenure, can I say that the person has stayed with me for one? The contract data looks like, how does the contract looks like, right? So let's say df dot head of 2. So let's come over here, df dot head of 2. What does a contract looks like? Contract, 0 and 1. So let me say contract is 0. Then my payment method will be also 0 and 1. So let me also say 1. Payment method is 1. And monthly charges is $29. So let me just say $30, for example. Decline. So let me just say $30. And what is the last variable? Total charges. Total charges could be $1,000 also. So let me say, I don't know, $2,500. If length of selected features is going to be equal to 5, otherwise I'm going to give an error, right? So else I'm going to return something called none. So if the features are exactly equal to 5, then the data runs. Otherwise, I will say that there is an error here. So return interface. Okay, please don't give me any error. It did not. Okay. So interface is equal to create Gradio interface. This is going to be fine. And if I say interface dot launch, will it run? It will run. I am sure it will run. So the interface is going to run. It's going to load the model and what? Oh, okay, fine. Okay, all right. Monthly charges and total charges. So did I make a mistake somewhere? I think I did. Tenure is female, not female. So if it is going to be for the choices of 1, which is going to be fine. Otherwise, it goes to the numerical feature. So if it goes to the else condition, the input values will be attended, and I have a slider mechanism which is going to give me the minimum 0, maximum 100 if the feature is tenure, otherwise 200, and the label will be feature once again. And in the selected features part, I am also checking it out. So what? So if I say this, and this and submit it, 0.04, no, not churn will be this. So what do I have? 4 values here. Selected features is fine. Load the component. Inputs is fine. For feature in selected features, if feature in tenure contract, or if I print selected features once again, selected underscore features, tenure, contract, payment method, monthly charges, and total charges. Okay. Radio button is available. Label is the feature. Inputs.append. gr.slider maximum equals to 0. Fine. I understand. Okay. So if you open this Gradio box up, or if you open this link, forget or ignore for now the code that I have written for Gradio. Just let it be separate. Everyone, you have a small URL called h8efgbd. Okay, I want you to play around with this link for a second. I want you to just play around with the link a little bit and see what answers do you get. Okay, just play around. Don't do anything else apart from that. Just play around with the code and see what do you see in this particular piece of code. So here is the idea, right? What you did with this particular Gradio was you were able to create a front end for your particular data with different kind of mechanisms. Actually, you are able to do it with the radio button. There is also something called slider buttons. Everything, of course, is a radio button. But okay, what do you see in the Gradio part, right? Like, what do you see in the Gradio part? So are you able to sort of create a simple front end with the kind of buttons you want, a radio button or a slider button or anything like that with Python, right? So if you observe very carefully, right, specifically speaking, if you guys were able to sort of create or write your code, which is going to give you the answer for, say, a given data, like, say, for example, tenure or contract or payment method or monthly charges or total charges, essentially, either monthly charges or total charges should have been sliders. Are you understanding what? So if you see the total charges here and the monthly charges, they essentially should have been a slider. Now, do you see in the else condition, I've also mentioned something called slider. So if you can see here, I have mentioned something called sliders. Within the input features, I have mentioned something called gr.slider, but the slider is not running, which is the slider is not popping up for the data, which is not what we want. We actually want the sliders to pop up if the features are what? Numerical in nature. When you say numerical, $2,000, $5,000, $23.86, aren't these all numerical features? So essentially speaking, I think we should also have an else condition, which I think we can debug. But if I debug and assume that the debug is correct, what would slider give me, everybody? What would the slider feature give me? The slider feature would have essentially given me a slider which looks like this, right? So if you look at the Gradio slider, so if I just say Gradio slider, what would happen? It would look something like this. It would look like this. So if I show you the slider mechanism, so let's copy this and let's see if this works. Can we do a launch? Let's copy this and paste it here. Give me 1 second. Come over here, go to the bottom and paste it and run this. Let's see. Okay. So if I run the slider here, so see, if you can see here, the link expires in 72 hours, right? Do you see the slider here, my people? The count, choose between 2 and 20. And the animal is dog. So see, this is an example where you can create your own slider, reset the slider, or go back to the default value, change from cat, dog to bird, click on the clicker, which is basically this value, and you can add, say, for example, 8 also, and say morning and submit. So can you see here, the 4 cats from Japan went to the park where they swam and slept and ate until the morning. So what this code is basically trying to do is, can you see here, you can build the interface like this. You can have a slider with the values inside it. You can have a drop down called gr.dropdown. You can have a checkbox called gr.checkbox. You can have a gr.radio, gr.dropdown. So My point is, as a data scientist, you sometimes want to present in a very fun and a very better way, including the data that looks like this for people to use it. Now, if I just open this Gradio link up, right, copy this, and if I give it to you, you guys will be able to use the link very, very easily. Are you understanding what I say? This link can be used for prototyping, for people to test your program, to make it, to give you feedback on it. And if you don't want it to work, so for example, you are done with the program and you want to close it, all you have to do is just come to interface dot close, okay, dot close, close. And if you run this, do you see here the server is done, it is closed. So let me close this and rerun it once again. So can you see here? The server is now closed, which was running on the port 7860. So if you open the link that I gave you, not this one, the first link that I gave you, it's no longer going to work. I think I gave you this link, if I'm not wrong. This is the link I gave you. If I refresh it, the interface. So in case if you want to make a prediction, or in case if you want to run the code, the interface is not going to run. You can close the entire interface and your front end is going to be closed. If you want to run it, just go with interface.launch once again and the whole program runs for 72 hours for absolutely free. Okay. If you want to launch it forever, if you want this particular front end to run forever, then go to Heroku and deploy this on Heroku. There will be Heroku link that will be live as long as the server is live. Understand of your time, how to deploy an app or a Python app, how to deploy a Python app on Heroku. Just look at a YouTube video for a 10 minutes video or a 20-minute video. It's a very easy process. If you learn how to deploy Heroku, you guys will be, it will become easy in your career to work with Amazon Web Services, Azure, or GCP. If you want to work with any of these cloud platforms, your life will become very, very easy in that case. Are we understanding? You got the logic? If you ever want to be able to sort of make or work with that, you guys will be able to do it. Sir, I don't want to work on Heroku, meaning I don't want to work on Gradio also. I don't want to work on Heroku. I don't want to work on any of this. I want my code to run as a function, meaning, sir, I want to just simply make a prediction. Suppose define demo underscore prediction. And inside this, I am going to do what? Model underscore scalar, SCALER, comma, selected features. So let me copy this. Let me copy, 1 second. What did we do? Yeah. So let me load the component. Give me a copy here and let me go ahead and paste it. Sir, I want to write a function. The minute I call this function, I want the prediction. So tell me one thing. Will you take the model? Yes. Suppose your sample customer, SAMPLE, sample underscore customer, guys, what features did we have for the model? Did we have a features which is tenure, contract, payment method, monthly charges like this? So can I say I can take this data for my data example? This 10132,500, can I take it as an example? For my selected feature, pd.data frame, okay, my sample customer's data looks exactly like this, right? So let me say it looks like this. How do I take it? Let's take it like this. pd.data frame, input data, let's copy this and let me paste it here and say my pd.data frame. Guys, tell me, can I say that my data is this? The input tenure is 1, then 0, then 1, then 30, then 2500. Can I say this? This is going to be my input data. My selected feature, or if I print the selected features for everyone, selected underscore feature, my tenure is how much? This is, apologies, but you know what? I think we can let go of the demo predictions. That's fine. Did you guys get the logic? Did everybody get the idea that how a prediction is done? How did you guys run the Gradio method here? Okay. Can I request you guys to kind of go through my code once again, sort of repeat my code or go through the code, understand the topics of the code once again, sort of rewrite the code, try to change the code, try to change the hyperparameter question. Okay. Sir, how do we use grep and how do data scientists use this? Okay. So what happens, guys, is have you ever heard of the concept called SSH? Anybody? Has anybody heard of the concept called SSH? Okay. So let's say you have a Linux server. Okay. Simply speaking, imagine you have a computer operating system somewhere in the cloud. Okay. If you want to access this server, you have to SSH into a port 192.182.1.7. Have you uh, um, ever seen an address that looks like this? Your IP address? Okay. So when you have an IP address, you SSH into this, you basically open this, link. When you SSH into this in the terminal, you open up a server where it has its own C folder or F folder or any other kind of folder. If you have multiple different files, suppose your project is very, very complex. It's a very complicated project. And you have a file by the name app. You're not able to find it. Okay. You are able to load everything into your SSH, you either using an UI or either using terminal, and you want to search for a file name .add.py. You can do that with grep. Are you understanding? You will be able to find the file, search the path of the file, remove the file, delete the file, add anything to the file, all using grep and some basic terminal commands. I hope you got the logic. Why do we use it? Now what happens? Because Amazon Web Services or Azure has made life easy, on Amazon, you can actually go inside a piece of a server with the help of UI. I hope you guys got the logic what I'm trying to say. So if you want to deal with the file terminal level, you want to go inside a file, outside the file, remove the file, delete the file, all of those, search, split, max, all of that can be done using something called. Sir, I don't know grep. Please explain use, objective, benefit. So my recommendation is Google search grep, you will get. If you just search for grep online, you will get numerous resources that will tell you exactly how grep can be used. I'm giving you the idea of grep because in the interview, if you go, sometimes since you're a beginner, they will not ask you this question, but if you're 1 or 2 years experienced developer, they definitely do ask if you know grep or not. So knowledge of grep or awk is considered as a bonus or a plus, that yes, the guy actually knows or can handle if I give him or her a. Is that clear, everyone? Like, did you get the concept? If you want to go inside a particular folder or a file, but you don't have a UI, like for example, you don't have a folder icon, double click on it, you can go inside this button. Sir, do we need to learn React and Java? Question. Sir, do I need to learn JavaScript or do I need to learn TypeScript? Okay, first of all, everyone, so see, I have been in the AI industry for about 11 years now. My personal experience is this. Okay, this is my personal experience with the teams that I manage. Okay, see, learning React is always going to be beneficial for you. Let me explain why. Sir, as a data scientist, do we work on front-end technologies like building the application? How does the application look like? No, that's not your job. But in real life, when somebody is building the application for your company, at least won't you look at the code, how the code is written? Is there any bug or any error that might occur in the code? And let me also ask you something. Because you guys are AI developers, the most work you do is back-end work, but you need to integrate it with front-end. So back-end needs to be integrated with front-end so the application can work smooth. So if you have a front-end application knowledge, not extreme knowledge, just a little bit of React knowledge, then this will be beneficial for you. But sir, do we have to learn React? Like if I don't want to learn React, don't worry. If you absolutely don't want to learn React, it's absolutely okay. You don't have to learn it. Sir, what about TypeScript? See guys, the difference between React and TypeScript is object oriented and React is a functional programming concept. So if you want to create design patterns, then TypeScript is a much better programming language to do. But remember, TypeScript also requires help from JavaScript itself to build the whole application. Only on TypeScript you cannot build the whole front end. Are we clear? If you say, sir, I will only run TypeScript, then that's not going to do any favor. Only TypeScript will not help you. Your front end will still require you to know a little bit of HTML, a little bit of CSS, a little bit of JavaScript. See, this all this would be required. But personally speaking, I learned it because I wanted to know what server-side scripting is, like with Node.js and React.js, but I am not a very pro or expert in it. Like I know how Node works, I know how React works, but only to read the code that my front-end developers write, only to review it, not to program it. I've never deployed an application where my front-end script was used for deployment. Are we clear? Absolutely good. We have imported all packages, the one that we will be requiring or needing at the end of my program or towards writing the program. No problem. What about this line of code, everybody? Any questions in this piece of code? I have taken a GitHub raw user content URL. I'm reading the URL and I'm printing the top 5 values of my. That's great. So can I proceed forward with the next? Okay, that's perfect. Now I wrote this piece of code because the data set is 21 column data and some columns were absolutely being missed, correct? Some columns were being missed. Because some columns I was not able to see, I used 3 things. One is called display maximum column. The other is called expand frame wrapper. And the other is called max column width. Sir, why am I doing this? What is the need for doing all 3 of this? What will the first line of code do, which is called the display.max column? What is the job of display.max column? The display.max column is going to do one thing for me. It's going to display all the columns in my program completely for me to visualize. If I want to view all the columns at once, it will give me that. Sir, what about expanded frame wrapper, which is this particular code? What this piece of code does is whenever you take this column names also would be wide, right? Like multiple lines underscore this underscore that. I want this particular thing to override my already existing column so that the column's width is made. The wrapping part of it in Excel, don't we do wrapping? Wrapping means wrapping would mean, for example, what do we use? Sheets, right? Sheets.new example. So if I write down my name like this, my name is Rudra Sharma and I am a data scientist example. So do you see that this particular text is taking up 3 columns? So if I select this column and if I use wrap, so it would wrap. Where is the wrap in Google Sheets? I have to search. Yeah, this is the one. Do you see that I wrapped my text? Now everything is in the same column. Okay. Now tell me, if my name of the column is make this a proper column. So tell me, do you see it is wrapped now? Every single time it is wrapped. Okay. Maximum column width will make sure that the columns width are always maintained equally for each individual data depending on the type of the data it is. So these three pieces of code, you need to mention not just one, not just two, all three to make sure that the display is absolutely clear for the data. Are we okay? Good. So now I actually convert or map the data to 0 and 1, and I also convert the data into numeric because we did this while understanding or doing something called data analysis. My data, total charges, was converted or was available in the string data. I wanted to convert it into new data. I also used a Python's function called .map. Sir, could I have used something called label encoder? Instead of doing mapping directly, you also could have chosen using something called label encoder. It would have done 0 for female and 1 for male. Okay. But because I did 0, I wanted 0 to be specifically female and 1 to be specifically male. That's why I did not use a label encoder. I used a map. In this piece of, that's great. This is a simple data sort of analysis schema where I can check the minimum value for the given data point, the maximum value for the given data point, the percentile of the data, the standard deviation, and the total count of. I hope you guys got the logic of describe df. Okay, that's great. I also wanted to check if there are any empty values or null values in the data. Were there empty values in the data? Yes. In the total charges, there are 11 empty data. My question to you is, if we can check for empty data, can we also not check for duplicate data? Agree, disagree? I have just checked for empty data. I can check for duplicate data. In SQL, you call this thing as distinct, right? Sir, is two numeric code remove some rows from a data frame? No. Two numeric will not remove any row from your data. It will only remove if there are any errors available. So if the coerce is found to have any special character, then it will remove. It will not keep it. It will not keep it because you said I only and only want numeric data to be saved in the total charges. Understanding? So if you don't mention coerce, it's not going to remove and it's your job to remove. The focus is please make sure that the error is coerced. So if I found there is if there are empty values inside it, did I drop the empty value? df.drop na? Very good, absolutely good. Now I am printing all the columns to get the data. So tell me, my first job as a data scientist, as a machine learning engineer, is to understand feature importance. Correct? Which feature is important for me and why it is important for me? If I don't know which feature is important, how can I make my prediction? Great. To understand feature importance, what libraries or what techniques can we use? Can I use chi-square method? Chi-square analysis? The answer is yes. Sir, can I use ANOVA? Yes. What kind of ANOVA? Two-way. Sir, what about recursive feature elimination? Yes. Sir, what else can you use? You can use a library called Teapot. Have you ever heard of a library called Teapot? Do you know what Teapot does? Okay, no? Okay, let me answer that for you. See guys, have you ever been in a situation or you will be in a situation, Teapot machine learning, where you don't want to run all of this all by yourself. You don't want to run the whole thing all by yourself. You want auto machine learning feature to be enabled where the machine learning itself tells me what feature is the best feature and it will tell me which feature is the best feature by running all these libraries and I will take the best of all the library. What if I want to do? If you want to do this, there is a library called Teapot and Teapot is something called as automated machine learning. You just give it data, it will run the entire analysis for you. It is an automated machine learning method or a library. You don't need to run it. It will run it all for yourself or for you on your behalf. Okay. Now, I have used a variable called start is equal to time dot time and end is equal to time dot time. Why did I do this? Why did we do this? Sir, can you please show me one simple example? Ramesh, what I recommend you do is go through the library yourself. Spend some time, understand what it does. If you have any problem, then let me know. I will do it in the next class. At least spend some time yourself researching about it, understanding how it works, and you will get that's great. So I have used start time and end time, and I gave the entire data column or the feature column to the numerical feature, correct? Once I did that, I made sure I converted everything into numerical factor because Python does not understand string value. Once I did that, I wrote down a validation step where every single check or every single variable is checked whether it is still available in the data or not. Even if you don't use this piece of line, it's not going to make any change in the program. This is a simple validation step. That's it. Once you do that, did I take all my features separately and my target separately? X is my feature data and Y is my target data. Okay, good. To run my recursive feature eliminator, I used a library or an algorithm called random forest classifier. Can you see here? I have used something called random forest classifier. And in the random forest classifier, the estimators, the number of forests or the trees that I want to build is 120 and random state equals to 42 is going to basically mean that your results and my results will match. Good question. So the reason why we use recursive feature elimination is because recursive feature elimination is a technique that works best for all kind of data. Classification data or categorical data, numerical data, image data. Actually, image, there are much better libraries for it, but any kind of data, recursive feature eliminator or elimination technique works better. So just because it works better in majority of the cases, I thought maybe I could teach you recursive feature elimination. I could have taught you a different kind of technique also, but I thought because recursive feature elimination works best for all, so I ended up thinking that why don't we learn the best one so far? That's what we did. Okay, no problem. So I ran first the random forest model, and in the random forest model, I took the model and I passed it in the recursive feature eliminator method. Can you see? Once they pass recursive feature eliminator, can you see I have run something called recursive feature eliminator, which is to run the model. That's good. So for all the selected features, okay, all the selected features, am I doing a looping in such a way that I am combining numerical features and the support? Support means if gender is the variable that is mapping the most with the churn, will the gender be the highest or the support? If the support for gender is the highest, and if I'm looping in this Python code, what will be the output in this particular code? So let me give you an example, right? Let me give you a very simple example. Suppose if I have a array1 is equal to arr1 is equal to feature comma, the other variable is say, and if I have array2 is equal to, I don't know, 100 comma 200. If I zip them together, do I get a tuple, everybody? My output will be a tuple value, array1 comma array2. Do you see here? It's a tuple. Tenure with 100 is mapped and contract with 200 is mapped. So for I comma v in list of this, print I and v. So if I print I comma v, what do I get? I get the tenure separately and 100 separately. If I want only v, can I do this? Are you understanding what I'm trying to say? I am looping for a value which gives me just the Suppose array2 is a support. So if I have written a Python program in a way where what am I saying here is I'm going to loop for feature in feature, comma selected, okay, in zip numerical feature, and this is supported if that particular selected value, which is, where is this selected value here? So if I take this, right, double click on this. Do you see here? I have mentioned it here. Feature for feature, comma selected in zip if selected, which is if the condition is true. And if I print the selected features, can you see here? The selected features by the recursive feature elimination, all of them are here based on the support, meaning whichever has the highest support. So if you see here, the loop here is only returning the item. It's not in with respect to the maximum value, because I have not given any keyword called max, or I have not done any looping where I'm doing any kind of sorting, right? I have not done any sort. I am just looping. If I print the value, so if you can see here, X is equal to importance, Y is equal to feature, and the data is importances. So can you see here? Here, whichever feature importance is higher will be printed first. So can you see here? Out of tenure, contract, payment, monthly charges, and total charges, as per the level of importance, which is the number one? Monthly charges. Number two, total charges, then tenure, then contract, and then tech. Got the Sir, instead of taking only 5 values, could I have taken all the values? All these values? Yes, you can. No doubt, you can do it. But do you see here, after payment method, it's... So see, we've taken gender also, paperless billing also, senior citizen also. If I want to take all 4, all 5, all 10, all 20, yes, we can do it. No problem. Recursive feature elimination is only there to give you a mathematical advice that yes, based on the data, I think monthly charges is very important, directly important, whether somebody is going to remain in your company or they will leave your company. So this is just to give you the idea. The decision is... Are we clear? So any questions in recursive feature elimination? What recursive feature elimination does? Why do we use it? How do we use it? Exactly the same kind of program you will write. Doesn't matter what kind of data you have. You can ignore the validation step. Don't need it. It's okay. You can remove it, but you can run the recursive feature elimination. I also printed the time because I wanted to tell you that don't go with taking all the features directly, because sometimes what happens, you know that one feature is not important, but if you still don't want to believe me or have faith in your colleague or your boss or your manager, you still want to test it, absolutely go ahead with the numerical feature. That's not a wrong practice. It's actually a good practice to test everything by yourself. Okay. Sir, if we ignore RFV while building the model, what will happen? Your model's accuracy will be lesser.
Hello everyone, Intellipaat offers executive postgraduate certification in data science and artificial intelligence in collaboration with iHub IIT Roorkee. Through this particular course, you'll get to learn multiple tools like Python, PySpark, SciPy, NumPy, Pandas, Matplotlib, TensorFlow, Git, etc. You are going to learn multiple skills like data science, natural language processing, deep learning, fundamentals of generative AI, prompt engineering, and application-based generative AI, as well as recent trends like agentic AI. This course is designed to get you ready for the AI world. So do check out link available in the description. Also, through this course, we have already helped thousands of learners take positive step in their career. You can check out their testimonials on our Achievers channel.
Keeping up with the AI advancements can be exhausting. One day it's a new chatbot that can write poetry, and the next it's a model predicting stock trends. According to a report from the World Economic Forum, 85 million jobs are going to be replaced by AI by 2025, but at the same time, 97 million new roles will be created in areas like AI development, data science, and human AI collaboration. So, how do you stay ahead in this rapidly changing data driven world? By building real hands on AI projects. Working on projects not only helps you understand AI concepts better, but also prepares you for real world challenges. is the best way to learn, grow, and make your skills future-proof. In this video, I'm sharing 10 AI project ideas, 5 for beginners and 5 for advanced, designed to give you the practical experience you need. Whether you're just starting or ready to tackle the big stuff, these projects will help you build something meaningful while also making your resume stand out in this competitive field. So the very first project idea that we'll be discussing is the product recommendation system. This is a system used by companies like Amazon, Netflix, and Spotify to suggest products, movies, or songs based on what users like. A product recommendation system is an algorithm that analyzes user behavior to suggest products that they might like. For example, the system or the algorithm might recommend phone cases or screen protectors if someone buys a phone. This makes shopping more personalized and engaging. An interesting fact before you dive into this project: Amazon's 35% of sales come through product recommendation engine itself. This tells you how valuable this project would be if you were to make a career in any e-commerce company. The first step in this project is to gather and pre-process data such as user ratings, browser history, or product descriptions. You can find a sample data at Kaggle or UCI repository. You'll then use machine learning techniques to develop the recommendation model. Popular methods would include collaborative filtering, where you recommend items based on what similar users have liked, or content-based filtering, where you recommend items similar to what a user has shown interest in before. Now, the tech stack for this project would include Python as the main programming language, with libraries like Pandas for data handling, scikit-learn for building machine learning models, KNN for collaborative filtering, or decision trees for content-based filtering. You can also use Flask for building a simple web app to display the recommendations to users. Completing this project will give you hands-on experience in machine learning, data manipulation, and web development. From a resume perspective, this project is a great addition because product recommendation systems are widely used in many industries like e-commerce entertainment like Netflix or Spotify and online services. Now, the second AI project idea is cancer disease detection. This project uses artificial intelligence to help detect cancer at an early stage, which can be crucial for saving lives. Now, in order to get started, you will need a dataset that contains labeled medical images of cancerous and non-cancerous cells. There are several datasets available online like the Cancer Image Archive, TCIA, that can help you with this. Once you have your data, the next step is to pre-process it. For medical images, this might involve converting them into numerical arrays or normalizing them to ensure consistency. For the tech stack, you will be using a combination of Python and deep learning libraries. The most popular deep learning framework is TensorFlow or PyTorch. Now, these libraries are great for building and training machine learning models. You will also work with CNNs, which are specifically designed for image recognition tasks like this one. CNNs analyze patterns in the medical images and then classify them as either cancerous or not. Now, to handle the data, you can use Pandas and NumPy. You can also use Flask or Streamlit to create simple web app for your algorithm. This way, doctors can upload images and your AI system will analyze them and give predictions on whether the image shows signs of cancer or not. Now, what's the benefit of working on this project? By working with the real-world medical data and applying deep learning techniques, you'll develop technical skills in AI, machine learning, and data processing. Now, this can prove to be highly valuable for your resume. Completing this project will demonstrate that you can work with large data sets, develop models, and even deploy AI systems, which are skills in high demand. Now, moving ahead to the third project idea. Businesses and consumers rely heavily on online reviews to make decisions. However, reading through thousands of reviews to understand customer opinions can be time-consuming. This is where sentiment analysis comes in. It's a technique in artificial intelligence that can automatically determine whether a review is positive, negative, or neutral. Through this, businesses are able to quickly gain valuable insights into customer feedback. The project will begin with collecting product review data, which is publicly available from sources like Amazon or Yelp, and then pre-process it. For the model, we will use machine learning techniques, specifically natural language processing, to understand and analyze the text. Initially, a simple model using techniques like bag of words or TF-IDF combined with a classifier like logistic regression can be implemented. Later, you can enhance the model using deep learning with RNNs or LSTM, which is long short-term memory, for better accuracy, especially for complex sentences. On completing this project, you will not only boost your understanding of NLP and machine learning techniques, but also make your resume stand out. This project will demonstrate your ability to handle both data pre-processing and model building, skills that are highly sought after in AI and data science roles. Additionally, it's a great way to get hands-on experience with Python and machine learning frameworks, both of which are valuable in the tech industry. Moving on to the fourth project idea. Job seekers today face a major challenge: getting their resumes noted by recruiters. Many companies use an applicant tracking system or ATS to filter resumes before they even reach a human recruiter. These systems scan resumes with specific keywords, job titles, skills, and qualifications. If a resume doesn't match these criteria, it may never get seen by a hiring manager. Now, the goal of this project is to build a system that can automatically pass and extract important information from resumes. This makes it easier for ATS to process resumes and for recruiters to find the most qualified candidates. The resume parser should be able to extract details such as the candidate's name, contact information, skills, education, work experience, and certifications from various resume formats like PDF, docx, and plain text. It will also analyze and categorize this information, helping job seekers optimize their resumes for ATS. In order to get started with this project, we'll use natural language processing or NLP to extract and understand the content of resumes. For parsing different formats, you can go ahead and use libraries like PDF, Miner, or docx in Python. You can then employ machine learning models for keyword extraction, entity recognition, and classification to identify and organize this information. There are also libraries such as Spacey or NLTK that can be used for text processing. Once that is done, we might also want to integrate a simple scoring system that ranks resumes based on the match to a job description. Completing this project adds immense value to your resume and skill set. You'll gain hands-on experience in working with text data using libraries and tools commonly used in industry for NLP tasks. You'll also understand how ATS systems work and learn about their role in modern hiring processes. This project will strengthen your proficiency in Python, machine learning, and NLP, making you a more attractive candidate for roles in data science, AI, and software development. Plus, it will give you a practical project to showcase, demonstrating your ability to solve real-world problems and adding a highly relevant skill to your resume. Moving on to the fifth project idea. This project focuses on a world where machines can see and interpret the environment just like humans. Real-time object detection is all about teaching computers to identify and track objects in live video feeds, such as recognizing a car, a pedestrian, or even a stray animal crossing the road. The problem this project addresses is simple yet impactful. In many industries, from autonomous driving to security systems, there's a need for technology that can detect and respond to objects in real time. Without it, processes remain slow and manual, and in some cases, this delay could even lead to accidents or inefficiencies. This project allows you to bridge that gap by creating a system capable of detecting objects instantly, enhancing safety and efficiency. You'll begin by collecting a dataset of images with labeled objects such as COCO or Pascal VOC. These labels help train your model to recognize different items. Then you can go ahead and use a pre-trained deep learning model like YOLO, You Only Look Once, or SSD, Single Shot Detector, which are designed for speed and accuracy. With frameworks like TensorFlow or PyTorch, you'll fine-tune the model, feeding it data and teaching it to detect objects in real-time video streams from a webcam or CCTV camera. Finally, you'll integrate OpenCV for video processing and visualization. The tech stack includes Python for coding, TensorFlow or PyTorch for building the AI model, and OpenCV for handling video feeds and a GPU to process the data quickly. You'll also use libraries like NumPy and Pandas to manage the data. For your resume, this project will showcase your expertise in computer vision, machine learning, and handling real-time data, which are sought-after skills in the AI job market. On the other hand, for organizations, the benefit is enormous, whether it's enhancing surveillance systems, improving vehicle automation, or optimizing industrial workflows. Moving on to the sixth project idea. For a business that receives customer queries day and night, hiring people to answer these questions 24/7 can prove to be expensive and sometimes inefficient. This is where chatbots can help. A chatbot is an AI-powered assistant that can understand customer questions and provide instant answers, saving time and money while improving customer satisfaction. To build this project, you'll start by defining the purpose of your chatbot. Will it assist with customer support, book appointments, or maybe help users navigate a website? Once you figure out the main category of support, you'll need to gather or create a dataset of common questions and answers related to your topic. Next, you'll use tools like Python and frameworks like Flask or Fast API to create a conversational interface. For the AI brain, you can use pre-trained models from libraries like Hugging Face, which help the chatbot understand and respond to text. The backend might use an NLP model like BERT or GPT. These models analyze the input text, understand its meaning, and generate appropriate replies. If you're making a more advanced chatbot, you could connect it to a database or APIs to retrieve specific information like product availability or order status. Once the chatbot is built, you can again deploy it on website or messaging platform using tools like Heroku or AWS. This project is a fantastic addition to your resume. It shows your ability to solve real-world problems using AI to automate processes and build systems that improve user experience. By completing this project, you'll demonstrate your skills in Python, NLP, and deploying AI systems, which are in high demand. Plus, it gives you a practical example to discuss during interviews and sets you apart from problem solvers ready to tackle real business challenges. Moving on to the seventh project idea. Now, if you're a developer working on a large project with multiple team members, understanding someone else's code is like solving a puzzle, especially when the code lacks clear documentation. Writing documentation is tedious and time-consuming, which is why most of the coders neglect it. This is a common problem, often leading to miscommunication, bugs, and slower onboarding of new developers. Code Document Generator is an algorithm designed to bridge this gap. This project aims to automate the processing of creating detailed and accurate code documentation. You will build an algorithm that will analyze the structure, functions, and logic of the code base and generate human-readable explanations for each part. To build this project, you can use technologies like Python and Hugging Face transformers. A model like GPT-4 can be fine-tuned to understand code and generate meaningful descriptions. You'll also work with frameworks like LangChain for chaining tasks and Fast API to deploy the tool as a web service. You can also go ahead and add a front-end interface using Streamlit that will make the algorithm user-friendly and visually appealing. By completing this project, you'll gain hands-on experience with advanced AI concepts like working with large language models and deploying them in real-world applications, while also highlighting your understanding of generative AI. The next project idea that I'll be talking about has been inspired by Google's revolutionary Cotton Ace project, Pest Monitoring Application. This is basically an AI application that helps farmers protect their crops by guiding them on aspects like the best time to spray pesticides. Pests are a huge challenge for farmers. They damage crops, lower yields, and increase the cost of farming due to the needs of pesticides. Many farmers don't realize there's an infestation until it's too late, leading to significant financial losses. This is where technology, especially AI, that can step up and make a big difference. The application will use image recognition to identify and track pest infestations in real time. Farmers can upload photos of their crops, and the app will analyze the images to detect pests, classify them, and provide actionable recommendations such as whether to use pesticides or take other measures. To get started, you'll need a dataset of pest images and healthy crop photos. Then you will need to train a machine learning model like CNN using frameworks like TensorFlow or PyTorch. Then you can go ahead and add a user-friendly interface, perhaps a mobile app where farmers can upload their images and receive instant feedback. You can even incorporate weather data or other regional trends to make the app more accurate. For this project, you'll use tools like TensorFlow or PyTorch for the AI model, OpenCV for image processing, and a cloud platform like AWS or Google Cloud for deployment. The mobile app can be built using Flutter or React Native to ensure it works on multiple devices. You could also add APIs for weather forecasting to give farmers extra insights. This project is a great addition to your resume. Employers value candidates who can demonstrate technical skills with practical applications, something that brings a change in the everyday lives of the people. Now moving on to the ninth project idea. Consider a situation where a marketing manager needs to come up with engaging content for products in an organization. Every campaign is going to require hours of brainstorming, research, and editing to create creative emails, blog posts, or social media captions. This is where an AI-powered marketing content generator can make life easier. Repetitive content creation takes up time and resources that could be better spent on creative ideas and connecting with customers. By building an AI marketing content creator, you can automate the task, making it faster and more efficient while still maintaining quality and personalization. To develop this project, you would start by training a generative language model like OpenAI's GPT or Hugging Face transformers to create different types of marketing content. You can feed it examples of blogs, email campaigns, or social media posts to fine tune the model for specific industries. Adding features like customizable tone, keywords, or target audience will make the tool more versatile. You can also integrate a user-friendly interface using tools like Streamlit or Fast APIs so marketers can simply input a prompt and get ready-to-use content instantly. The tech stack will include Python as the primary programming language, libraries like TensorFlow or PyTorch for deep learning, and LangChain for chaining tasks like summarization and editing. Hugging Face can provide pre-trained models, while Pinecone or a similar vector database can store embeddings for fetching quick text. To deploy the app, you can use cloud platforms like AWS or Google Cloud. Completing this project will add immense value to your resume. It showcases your expertise in generative AI, NLP, and creating end-to-end solutions for real-world problems. By building a marketing content generator, you will not just be solving a technical problem, but you will be creating something that directly drives business growth, improves efficiency, and demonstrates the power of AI in everyday tasks. Here comes the last project idea for this particular video. Managing finances today can be complex and overwhelming for many people. Financial advice are often expensive, and individuals with limited resources may not have access to professional guidance. This is where a generative AI powered chatbot can bridge the gap by offering personalized, real time financial advice. To build this project, you would create a conversational AI model capable of understanding user inputs such as financial goals or challenges and provide tailored recommendations. The chatbot would use natural language processing to understand queries, retrieve the relevant data, and then generate meaningful responses. For example, if someone asks, "How can I save for retirement?" the chatbot could analyze the user's income, expense, and investment options to provide advice. The tech stack for this project includes Hugging Face transformers to build and fine tune the conversational model, then LangChain for integrating multiple knowledge sources, and Pinecone or Wave8 for storing and retrieving user data efficiently. Tools like Fast API can be used to deploy the chatbot, and a user-friendly interface can be created using Streamlit or React. Security protocols like OAuth can be added to ensure user data privacy. Completing this project will be a big win for both the individual and the organization. For you, it would demonstrate your ability to work on real-world AI problems using advanced tools and showcase your skills in generative AI and multimodal data integration. It's a standout addition to your resume, especially for fintech.